Change is the only constant. The question is, who is leading it and why? Because purpose is everything. It's the bold ambition needed to take on the multi-generational challenges before us. It's the creation of a contemporary and accessible education ecosystem to drive greater social cohesion and prosperity. It's reimagining partnered research of focus at scale to become an engine for growth. Adelaide University is Australia's new university for the future, designed to empower individuals to be the best they can be. With more than 180 years of collective experience and achievement, Adelaide University will leverage the capabilities and resources of its foundation institutions to launch bright futures and breakthroughs. We're transforming teaching and learning by co-designing degrees with future employers. Our students will be equipped with an entrepreneurial mindset and will be ready to take on an AI world. Ethical leaders who do what is right over what is easy. Adelaide University is establishing South Australia as a centre for progress and innovation. As a group of 8 universities, we're combining the investment and infrastructure needed to accelerate future-making research that is nation-critical and globally relevant across defence and national security, creative and culture, food, agriculture and wine, personal and societal health, and sustainable green transition, from society to seas to space. We're partnering with industry, communities and regions to create impact that transcends borders and time. As an exemplar for excellence and equity, we bring together the esteemed and enterprising to prepare a diverse next-generation workforce that's adaptable and ready to respond to an ever-evolving world. To provide a nation-leading student experience that unlocks individual potential and passions, to connect an inspiring global community of over 400,000 alumni, to contribute an estimated $4.7 billion a year to our national economy, and to deliver value across the full chain, from research translation to commercialization. Adelaide University is a force for positive change. Together, we'll shape what's next for a better Australia and a better world.
Australia is a nation of creators, aviators, protectors and innovators. From aviation's first light to the dawn of the jet age and beyond, at Boeing, we're building the future together here in Australia, inspiring those in pursuit of new frontiers, connecting, protecting and exploring our region and the world. Home to the broadest aerospace portfolio in Australian industry, powered by talented, dedicated and diverse teammates. Delivering manufacturing excellence, building composite aircraft parts for the world's most efficient airplanes, using advanced robotics, materials and digital technologies, never compromising on safety or quality, always focused on sustainability. Solving tomorrow's problems today, with Australia's leading researchers, scientists and universities, developing new military platforms and communications networks, and helping ensure they are always mission ready. Keeping customers airborne by providing the services they require. We stand shoulder to shoulder with Australians during natural disasters, on the front line and in peacetime. We support veterans and our community, and we nurture the next generation of aviators to excite, to be bold. Boeing Australia. Made in Australia by Australians for the world.
universities came together to create a global university for the future. Welcome to Adelaide University, a defining mark in our state's story of firsts.
welcome to day 3 of the Australian Rover Challenge. I'm Georgia Dollymore and I'm joined this morning by the fabulous Shagaf and Feeder who will make up our commentating team today. It's a cloudy morning here in Adelaide, South Australia, at the home of the Australian Rover Challenge at Adelaide University. We're up at Roseworthy, which is a short drive north of the city, and the teams are getting prepared for 2 brand new tasks. So over the Thursday and the Friday, we saw teams compete in the post-landing task and space resources. Now we're shaking it up a little bit. Got excavation and construction happening on pitch A over the weekend, while we have mapping and autonomy happening on pitch B. So we will talk through all of the tasks and what's involved for the teams over the course of the day. And this morning we will have Swinburne competing at 9 a.m. And we're here today on the lands of the Kaurna people, and we'd like to pay our respects to their elders past, present and emerging. So Shagaf and Vida, it's your first time here, and we've got a leaderboard from the last 2 tasks. Legendary Rover up there on top, and Monash in second place, UQ Space rounding out the top 3. How are you feeling about the competition heating up, Shagaf?
This looks incredible, and it's also looking really close as well. We've got the Legendary Rover at the top, followed by Monash Nova Rover, and UQ Space in 3rd place as well. We've got an incredible lineup this year, I think, and we're also officially halfway through the competition. Now it's just starting the 3rd day of the Australian Rover Challenge.
And what about you, Vida? It's been about 12 months since you've been back here at the track. What have you been up to in the meantime, and how are you feeling about being here?
Well, thanks for having me again. This is such an awesome event. I've been just working full-time in the software industry. It's been cool to see that there has been such advancements in the software side of things in the Rover Challenge as well. I'm really excited to see how teams have integrated with AI and LLMs and ML models, so that'll be quite interesting to see, especially with the mapping and autonomous challenge coming later today. It's also such a cool event where we get so many people from all over the world come. It's always cool to meet new people. It's cool to connect with people with the similar interests, but on the other side of the world. So yeah, I'm very keen.
Yeah, it'll be fantastic to get your thoughts later in the afternoon with the mapping and autonomous tasks. So Feed will be our roving reporter for the day. We've definitely heard a lot from the teams over the last 2 days about their integration of machine learning and neural networks into their rover this year. And that's been a really recent development as well. Like you were just saying, this technology has absolutely exploded in the last couple of years, and it's amazing to see the teams right at the cutting edge of that and constantly pushing their rovers to the limits. Speaking of that, we've got Swinburne Rover team coming out onto the pitch to be the first team of the 2026 Australian Rover Challenge to complete excavation and construction.
Let's do it! Right, your task time is in 1 minute.
All right, looks like Swinburne University has set the rover down with 1 minute to go until the clock starts ticking for the excavation and construction task on pitch A here.
That rover looks roaring and ready to go, doesn't it? Ahead of time.
I love the red and black colours as well, really showing a bold style there.
So this morning in excavation and construction, there are a number of different challenges that the teams have to complete. So they have to leave the start gate area and clear some rocks or debris. So we're imagining we're further ahead in the progression of those foundational services on the moon. So in the post-landing task, we're imagining a situation where the rover had just landed on the moon and it was doing a bit of a site evaluation. It was performing some maintenance, checking the status of some equipment that we assume some astronauts had left on the surface. Now that it's completed those tasks, it's also found some resources, that all precious water. It's going to start constructing a lunar habitat. And of course, as part of any site preparation, you need to clear a site. So the rover is going to have to remove some rocks from an area, and they get points depending on how many they're able to clear and the size of those rocks. And then once those rocks are cleared out of the way and the foundation's ready, the rover will be required to do some construction of a berm.
So once again, for those who have just joined us on the live stream, we've got Swinburne University Rover team on pitch A. The time has started about a minute ago at 9 o'clock local time. They are today going to attempt the excavation and construction task. This task is presented and sponsored by Caterpillar, and it's got about 5 or 4 main subtasks, as you can see there on the screen.
That's right, and if you're here out at Roseworthy this weekend, Caterpillar actually have a tent set up just next to the grandstand where you can be part of their simulation experience. So if you want to have a go at doing some operations of autonomous trucks, very similar to what the team in the base station is doing right now with trying to remotely operate their rover, you can give it a go this weekend. Now, on top of doing the excavation and construction, there is also a paver construction element of this task. So we're imagining that the rovers are going from end to end of setting up a lunar habitat. So they're clearing the site, they're laying down the foundations, they're constructing a berm, which is sort of a protective barrier. A berm is something that we hope would be used to protect sites from, I guess, the harsh lunar dust that gets kicked up by rockets landing on the surface or lunar landers. And once the rover's completed that, they could do paver construction to create a safe pathway for astronauts to be able to traverse across the habitat site. Now, the teams were required to construct their own pavers, so if they elect to do this part of the task, they had to stay in some pretty strict dimensions, and the pavers can't be connected before they start. They need to be able to lay them out one by one individually and then connect them together. So I don't know about you, Shagaf, but that sounds like a pretty complicated set of subtasks.
Absolutely. I think this is one of the most, or one of the more complicated ones compared to what we've seen earlier in this competition. But it's also one of the most exciting as well. I think it presents opportunity to see a lot of action and really see the capability of these rovers that these student teams have fully designed and built it themselves, both from Australia and all over the world.
I couldn't agree more, and hopefully Swinburne will get underway shortly.
In the meantime, in about T-minus 10 minutes, we should be seeing over on pitch B at 9:15 local time, NU Aspen Rover team should be setting up there shortly to attempt the mapping and autonomous task.
You can see that Swinburne is still on the two-way radio over there. That means that they have not officially called the task start yet. So while the team in the base station is getting set up, they're allowed to communicate with the field team. And then when they call the task start, which can happen anywhere in their 40-minute window, that two-way communication is cut off. You can see them catching a few Z's in there. I'm sure it's been some many late nights over the course of the last 3 days. Hopefully they'll get that caffeine into them soon.
And you know, it's not just the last few nights. I think it's also important to recognize the action we see from these rovers, the technology, the all the demonstrations that come out of this, this is, months and months of hard work, of late nights, of failures, of trying again and again, prototyping, testing, all coming together in these moments in the Australian Rover Challenge.
Yeah, that's spot on. And we have one team from South Australia, the Adelaide Rover team, representing our host university, Adelaide University. But apart from that, every other team, all 17 of them, so 16 teams, have travelled here to South Australia from around the country and also overseas. So it's a massive, massive effort from the teams. And we can see Swinburne doing some troubleshooting here. Checking the suspension system. They did have a slight mishap yesterday where one of their wheel axles sustained some damage. They've had to work to repair that in the hours between finishing yesterday and competing this morning.
So just a reminder, Swinburne University Rover team here has about a total of 40 minutes to complete this task, and that time has started as of 9 a.m. local time. So 6 minutes into their task, not a lot of pressure, but it's starting to build up slowly. The team hasn't officially called the start to the task, which means they've still got two-way communication open between the on-field team and the team inside the mission control. Once they're ready, they're going to call that start, and all communications will be cut off between the outside team and the inside team, really simulating what it's like to actually operate a rover off Earth, where you don't actually have a team, for example, on the lunar surface or on Mars, but rather you're only relying on the communications and the feed that you're getting directly from the rover.
And the communications is certainly one of the challenging aspects of this task. There are other rover challenges throughout the world that allow teams to use Wi-Fi instead, but of course, we don't have Wi-Fi on the moon yet, do we, Shagaf? There's no YouTube or internet streaming of any kind, so they're reliant on radio frequency, which is a very robust method of communications. It's been in place for many decades for spacecraft communications, and that's what the teams have had to replicate here. And it's certainly an extra element of complexity because this is not something that's really taught in university degrees, specifically undergraduate degrees. So they've had to learn this skill completely on the side.
Absolutely. And communications is usually also what we see drop out or fail in this competition as well. It is really the culprit of so many of these waiting times or failures or things going wrong. And presumably that might be what Swinburne University Rover team is trying to fix over here, as we haven't seen any movement yet from them.
That's right. So Shagaf and I were both on the Adelaide Rover team sometime during our undergraduate, and we definitely experienced this. I remember so many times we would be checking the communications to each of our wheels, and when you just see that blinking red or orange light telling us that they weren't connected, it's like, no, this was working perfectly in the workshop about 5 minutes ago. This is also Swinburne's first major attempt in the Australian Rover Challenge. They came along last year as a demonstration team, soaking up the atmosphere here, and now they're back as a competitor. So it's really fantastic to see the development that they've undergone in the last 12 months to go from being here not as a participant and then actually entering the competition today. Now, Shagaf, we spoke to Fida earlier about what he'd been up to in the last 12 months. We, of course, haven't seen you since the 2025 Australian Rover Challenge. What have you been up to lately?
So that's a great question. 2025 was such a big year for me. I finished my last year in my degree, and that was my honours year as well. So you can imagine how hectic that was. last year I was grateful enough to be part of an awesome team which was designing innovative propeller designs for human-powered submarines. And also as part of my honours project, we got to start a club as well that was going to put all of the systems together as well. So it really reminded me a little bit of the Adelaide Rover team days when, we had so many different teams working on different systems that had to come together in a competition like this. So a bit similar but more underwater, you could say. And yeah, I completed my honours last year in November and I graduated recently as well. And it's been an awesome ride, but I'm glad to say that I've finished my degree now.
That's amazing, and a big congratulations on finishing that. And what's next for you? What are you looking for post-graduation?
That's a great question. I'm still trying to judge my options, and there is a possibility that I will consider a postgraduate degree. Even though, while you're doing undergraduate, you always say, and I've said the same thing, we'll never do postgrad. And here we are, we're seeing movement from Swinburne University's Rover team. Wow. Enough about me, I think we need to look at the Rover now.
We'll come back to you later, that's for sure. I see some signs of life from Swinburne Rover team. Can they keep that comms link sustained?
And so just a reminder, there's 100 points available for this task. 5 of those points are actually for descending that lander ramp, but it seems like they've started at the bottom of the lander ramp, kind of skipping that task.
I think you're right, and potentially that might be related to some of the issues that the team experienced yesterday with one of their wheels. Maybe they didn't want to risk it. You can see the field team chatting with the base station team there. It's potentially an intervention is going to be called. You can see new Aspen Rover team waiting in the wings. They'll be getting started on mapping and autonomy in just 3 minutes' time, and it seems like the Rover is ready to go. So we'll have a look at their run out on the pitch shortly.
It looks like an intervention has been called.
Now, for anyone who has just joined us or hasn't had a chance to watch the live stream of the last few days, when an intervention is called, this is allowed. It gives the team a chance to look under the hood of their Rover, do some systems checks, and see if they can do some troubleshooting on the fly. And they will take a points penalty for calling one, but sometimes it's the right call to make. Take a points hit, but you get your Rover up and running again. Now, it's possible that the wheels might have been oriented the wrong way around, potentially, which will affect the control that the base station team is trying to do. Sort of readjusting those wheels there.
This is really one of the key skills that these teams are learning as part of this competition, other than all the engineering that goes into it, is teamwork and working under pressure. And that really does cultivate into their careers later on in life. Working under pressure is such a critical skill to have, particularly when you're working with systems or space systems, when any small mistake or any minor decision could really have a major impact on the mission.
That's right, it's definitely a high pressure environment, but as I was chatting with some of the teams yesterday, I said, diamonds are made under pressure, and I think we've seen a number of diamonds throughout the course of the challenge so far.
Over on page B, we're seeing a new Aspen University setting up their Rover. This is for the mapping and autonomous task.
Now, similar to all of the other tasks, they'll have 40 minutes to complete, and there are 100 points up for grabs for mapping and autonomy. So the teams have been given like a rudimentary map and the rover needs to now explore a new area. So you might notice that there are some little placards on the map, and these are some landmarks that scientists are interested in imaging in more detail. The rover's going to have to navigate to these without human intervention. So they can do this either autonomously, meaning it's going to drive around completely by itself, or it will have some slight operator control.
That's where the semi-autonomous part of this competition really comes in. It's really in this mapping an autonomous task. This task is also presented and sponsored by Boeing. And it's 9:15 a.m., which means the clock has officially started ticking for a new Aspen team. This team is from Kazakhstan, the very first from Kazakhstan to participate in the Australian Rover Challenge. Again, just shows how much growth the Australian Rover Challenge has seen just over the last 5 or so years since its first instalment in, was it 2021?
It was indeed.
And that's just such an incredible growth that we've seen, just to go from, a small competition which was previously held at the Adelaide University City East Campus to now just this 4,000 square metre field, and teams not just from Australia but all over the world. And even though we've only about 17 teams competing at the moment, there was actually more from different countries like India, Bangladesh, and a few others that did register but did not get to come down or compete in the challenge, unfortunately.
Well, of course, there are a number of different stages for entering the Australian Rover Challenge. You can't just say, I've got a rover, I'm ready to go. The teams need to show that their rovers are up to the task and that they've done the necessary systems engineering to be able to design a functional system. So in real life, engineers go through a number of design reviews in the engineering life cycle, and some of the key ones are a critical design review and a system acceptance review. So teams have to submit both of these reports and pass them to be eligible to get an invite to the Australian Rover Challenge, and then the top scoring teams from those make up the group that you see here over the last 4 days.
That's right, and it's important to remember as well that the final scores do also make up, a part of it makes up that critical design review and systems acceptance review points that they receive as well.
That's right, because I think if we looked back at the leaderboard, the number one team, Monash Nova Rover, are almost on 300 points, and there's a total of 600 up for grabs. So they've clawed almost 50% of the possible points.
All right, we're seeing some movement on the wheels there from pitch A. It's stopped again. Hopefully we'll see some transverse and some trekking across the field. The sun has also come out, which is quite lovely. It was a bit chilly this morning, and now we're getting nice, slowly warming up.
See the judges very happy to get some warmth out there on the pitch.
Really an interesting change of weather compared to the Australian Rover Challenge 2025, where we were having a heat wave during the competition. It was quite warm out here. This time around, it's actually much more nicer. We're getting a balanced sort of temperature. 20s today, I think, low 20s, and tomorrow mid 20s, which is just perfect, I think.
Absolutely, and certainly over the last couple of days we have had all 4 seasons in one day, so while we might be enjoying the sun now, it could take a turn at any moment, but we'll take a while it lasts.
All right, and an applause from the crowd there as we see movement from Swinburne University Rover team.
Some cheers there from the team.
And we've stopped again, and that's just a little bit of the reality of this competition and of space systems in reality. But we're taking it baby steps as we go, and we've seen progress and improvement. We're just about halfway through their task this morning. So 9:20 a.m. local time means they've got about T-minus 20 minutes left to try and get as many points as possible.
Waiting patiently there. This is already a great effort by the team to be here on the field this morning. After the damage that they sustained yesterday, they had to work to get that wheel prepared overnight.
You can see the determination and the working under pressure there inside the mission control. Over on pitch B, we're still waiting to see some action. I think a new Aspen Rover team is troubleshooting at the moment. They're about 6 minutes into their autonomous and mapping task.
Something unique about this task is, like we were saying before about autonomous and semi-autonomous, this task is split into two distinct phases. So the teams can start out in the autonomous phase. All the base station team members can only interact with the controls only before the rover has moved for the first time. And once that happens, then it's hands off and they enter the autonomous phase. But if they're having issues with that, of course, autonomous is a pretty complicated thing to get on board your rover, especially for the newer teams. They can then choose to enter the non-autonomous phase and undergo some mapping of the pitch, and they can get points for that.
Mapping an autonomous task, in previous years has always been one of the more difficult ones to get running to make it work for every team. Only a handful of teams have been able to actually successfully complete this or partly complete this task. But really, autonomy in real life, in space systems, in planetary exploration and space exploration plays such a critical role when we're trying to establish, human presence on the moon, when we're trying to send the first humans to Mars. Robotics plays such a key aspect, and having these robotics be autonomous is just such key, really, in trying to get these systems, especially in the early stages of setting up human presence or setting up a colony. You really need some sort of autonomy to make a space system really work.
That's right, because we were discussing a little bit the other day about, well, why do we want these rovers to be working autonomously or semi-autonomously, and why do we even want rovers at all for these types of tasks on other planets or celestial bodies? And I think it's got down there. It's exactly right. It's because humans are awesome, but humans wear out pretty quickly, and we don't want to send any astronauts out to do a task when a rover could be doing it instead. It's much safer, much faster, and doesn't put those lives at risk. And if we're talking about going from the moon to Mars, which is pretty much the core aim of the NASA Artemis program, it's a pretty long journey to get to Mars from planet Earth. It's anywhere between 9 to 12 months. So if you can send the rover ahead of time to do the scouting and the site preparations, then that makes the journey much easier for the astronauts later on.
And autonomy is important because it also means that robotics and rovers in space and on other planets can make decisions on the spot, particularly when there's an emergency or something has gone wrong. If you're trying to operate a rover from Earth to Mars, that's about, roughly a wait time of 20 minutes forward and back to send and receive communications and instructions and feed, and it really does impact the mission with such a long wait time. So autonomy really makes sure that rovers can make decisions on the spot and can operate efficiently without intervention of human control.
Yeah, it's really all about efficiency as well as safety, and these are features that they've introduced onto the NASA Perseverance rover recently, and allows the rover to do identifications of geographical landmarks and other sites of interest. So you don't constantly need a human operator there to tell it what to do, and especially with that delayed time in sending commands, that helps make operations go just a bit smoother.
So over on pitch B at the moment, what we're seeing is a new Aspen Rover team. Looks like they haven't called the official start of their task. This is the mapping and autonomous task once again. They're about 10 minutes into their total of 40-minute window to complete this task.
Now it looks like Swinburne are getting ready to take their rover off of the pitch. Not being able to quite get out of the start gate today, but they did get a chance to test their wheels, so they've tested their communication system as well. Okay, we're hearing from the judges they're going to go for reposition. This allows them to test another system, going to where the rocks are, so we might see some more action in a moment. Just one of the advantages of being able to call an intervention is that if you don't have one of those core subsystems quite functioning, you might still be able to pick up points if you've got other systems working.
Really carefully moving that rover across closer to where the rock clearance task is. So one of the subtasks of this excavation and construction task is clearing some rocks from a designated zone. So trying to skip that, moving across with some of the issues they've been having, and just really using up the rest of the time they have to try and accumulate as many points as they possibly can. We're seeing them now placing down that rover. You can see those rocks in view as well on the pitch. They've been carefully placed by our wonderful judges and volunteers. T-minus 13 minutes. Will we see some action? Shout out to the volunteers sweeping the lunar surface, the regolith, ensuring everything is top notch.
And doesn't this lunar surface look glorious, Shagaf? The team here at Adelaide University have really done a fantastic job getting quite a realistic looking surface down to the details and the craters and how the regolith feels as well. It might look like beach sand, but it's not quite the same. It's a little bit denser, it compacts differently, and that all plays into how the rovers perform as well, particularly with their tyres.
Absolutely. Lunar regolith is one of the most challenging aspects of trying to operate a rover or any system on the surface of the moon. It's actually quite abrasive or sharp and can get caught up in mechanisms and wheel systems and can really mess up some subsystems of rovers. And we've seen that as well happen, rovers getting stuck in the sand and having to troubleshoot around that issue.
Yeah, that's right. At least every single year we see a rover getting bogged down in that sand.
We're also seeing over here, this is pitch B, the NU Aspen Rover team still troubleshooting, hopefully looking to start soon their mapping and autonomous task. As we click over to almost 9:30 a.m., they're about 15 minutes into their task time. You see the team hard at work, troubleshooting, communicating with the mission control team.
We've got an essential tool there of a multimeter. Wouldn't be a rover challenge if we didn't see some duct tape and multimeters out on the field. Now, Shagaf, you talked earlier about how your honours project was connected to human power submarines. You said even though that was for an underwater environment, there are a lot of connections you could make between engineering for the oceans and engineering for space. What are some of the similarities that you see there?
Absolutely. I think one thing to highlight is whether you're designing a submarine or a rover or anything else, one of the key aspects of designing something that works together is systems engineering and integration, I would say. And that's what the biggest similarity I think I saw between a human-powered submarine and a rover. It really is all about all your subsystems working in harmony. And we're seeing that here in the Australian Rover Challenge. Sometimes subsystems on one particular rover all work perfectly fine, but then you put them together, you try and get them to work together, and something just doesn't go quite right. And this is just in reality as well, a key critical aspect of getting something to work, or getting a submarine underwater or a rover on the lunar surface. It's just a bunch of teams all working on different subsystems, but really getting all these subsystems to work together in harmony is what's going to ensure success.
I couldn't agree more. This is really some of the most complex systems integration you could possibly get. And reminding everyone that most of these students are undergraduates or at the highest level, potentially a master's student. So, they're doing some of this systems integration for the very first time as part of their student team, which is really fantastic.
There's so much that we see these teams, get exposed to, build skills around when they're competing in a challenge like this. It's really pushing the boundaries of what these students can come together and build, but really building so much skill and capability. And right here, we're really seeing the future space workforce for Australia, but also from other parts of the world. And it is absolutely looking promising.
And rovers really are the future of the space program. Earlier in the week, NASA announced their new priorities for the Artemis program, and rovers were right at the top of that list.
Absolutely, and speaking of rovers and Australia, we also do have, it's such a fitting time to talk about this as well, at the Rover Challenge, Australia's first national lunar rover program. Their first lunar rover called Rover, currently being constructed, and it's going to head to the moon with one of NASA's Artemis missions.
That's right, and they actually received their mission assignment earlier in the week, which is incredibly exciting. It will go to the moon towards the end of the decade, and we had Aniket from the Australian Space Agency here at the desk yesterday giving us an interview about what that's been like being part of the project, and we've certainly had many of the Rover team out here at the Rover Challenge over the last 4 days, so it's been absolutely fantastic to have them here supporting our students and giving them a lot of inspiration about what lies ahead for them as they complete their degrees and head out into their early careers.
And you know what? It's such an exciting time for the Australian space industry. We're seeing so much growth, so many more opportunities. All the action, it's just starting, and especially here in South Australia, we're known as the space state. What a wonderful opportunity, what a wonderful place and location and time to have the Australian Rover Challenge here in Roseworthy, where the weather is looking mild, I think. We're seeing some sun and there's a blanket of clouds. You can try your best to simulate a lunar environment, but the weather is one thing that you cannot control.
Absolutely, and speaking of the weather, we even had some lunar rain the other day that resulted in a pause in the activities out on the surface. That is not something that we want getting into these rovers. Very sensitive electronics here. The last thing we want is some rain getting on that. So it seems Swinburne are still troubleshooting their rover. So in the meantime, Peter's been walking around the workshop and chatting with teams, and I think he's got an interview lined up with Monash Nova Rover. So we're going to hand it to you, Peter.
Hey everyone, we've got the Monash team here with Zach, the team lead. They are the top Australian team at the moment, so tell us how you found this year and what challenges you've come across.
Yeah, the challenge has been exceptional so far this year. We're having a really, really great time. Our rover banks year returns from last year, and so far it's tackled both of the space resources task on the first day and the post-landing task on the second day, both of which we're incredibly proud of our results with. The science team did an excellent job on their space resources payload this year. They extracted water, which was a massive milestone for them. They're super, super pleased with that. We're very proud of them. And then yesterday in post-landing, we debuted our new robotic arm Type N, which is the result of about 2 years of development. Our previous robotic arm had been used for the 5 years before that, so it was well outdated and time for an upgrade. So we're super happy to come in with our new arm and perform as well as we did, scoring 90 out of 100 yesterday. So yeah, really happy with how we've gone so far.
Amazing. Yeah, your team has been smashing it so far and really great to see. I love the personality you've got on your Rover as well. You know, the color pink, it really sticks out. One of the things we were talking about just earlier is that your team is super unique in the sense that you guys do a lot of in-house parts and building your own equipment, things like that. I was talking to some of your team, they're talking about building your own drivetrain, designing your custom PCBs and things like that. One thing that is really cool is that you get to make PCBs that look like minions and things like that, which is really fun. But there's also a competitive advantage of doing that, right? So talk about a bit about what the in-house experience is like, pros and cons of that.
Yeah, there is certainly pros and cons to doing so much of our work in-house. Some of the pros, as far as our team is concerned, we exist to upskill people and to teach them skills they're not going to learn in the classroom. So that in and of itself is the biggest pro that we see with doing in-house work for our electrical systems and also our mechanical systems. Some of the drawbacks that come with that is that sometimes we have to spend a lot of time debugging because our quality assurance is not always on the same level as a multinational corporation whose entire job is to manufacture these. But it also gives us flexibility to design really custom solutions that are exactly suited to the applications we want. So yeah, our entire drivetrain is custom from our drive gearboxes. We design and machine them in-house as 15:1 cycloidals. Our pivot steer and gearboxes are also done completely in-house. That's a 70:1 slew drive. And then all of our motor drivers, all of our core and payload specific electrical systems are done in-house as well. So we design a custom carrier board for the Jetson R Nano, which is our core compute. And then we have modular breakout boards for all of our functionality, whether that's our brushless motor drivers for the drivetrain, whether that's our motor control for each of the payloads. Yeah, we do all that in-house.
Yeah, awesome. Well, thanks again, Zach. Best of luck with the rest of the challenge. I hope that you can get to the top. And yeah, thank you. Back to you guys in commentary.
Thank you, Fida. That was amazing to hear from the Monash Rover. And out on the pitch here, we're seeing more movement from Swinburne University Rover team.
There's huge cheers you could hear just before coming from the audience out here at Roseworthy as Swinburne made their first movements, and congratulations to the team.
We're seeing an applaud from the crowd there. It's been an intense 38 minutes so far. Not a lot of time left. The time crunch is real.
Just less than 2 minutes on the clock, but still, the team have made it out onto the pitch. We heard yesterday they were not confident they would even be able to get out here this morning. So for that to happen, and look at that drive system, they've got 3 out of the 4 wheels, I think, going there, and they've even attached their excavation payload, which you can see on that top camera there. They've gone for a bit of a rake, a forklift. Maybe they'll be able to actuate it.
What an incredible effort from the team this morning, working under such pressure, trying to troubleshoot to get the rover working. And we're seeing some incredible movement at the moment. A minute remaining. The suspense is real. We're seeing some more movement. And there's those live feed cameras that the team inside the mission control are seeing as they operate the rover.
Definitely making progress, and even being able to switch those drive modes from going, translationally, forwards and backwards, to then rotating, that is a challenge in itself. There have been years when I was with Adelaide Rover where it was a massive achievement to get it to rotate, as well as going up and down and left and right.
And that is time. Round of applause for Swinburne University of Technology Rover team. Well done. Immense effort. effort from both the on-field team and the mission control team, trying to get it working and actually getting movement across the pitch.
And that actually concludes Swinburne Rover Team's run in the Australian Rover Challenge. They're now complete for 2026, so I think that deserves another big round of applause.
Well done.
Fantastic job coming out here to Adelaide again. First time as a competitor. I'm sure they've learnt a lot going forward to next year.
Such an incredible effort. In about 5 minutes, stay tuned because we're going to see Uni Melb Rover team onto pitch A to attempt the same task, excavation and construction. So the teams have about 5 minutes to remove the rover, and then Uni Melb should be setting up shortly. And then over on pitch B, we're seeing a new Aspen Rover team removing the rover from the pitch now, wondering what might have gone wrong. Have they called off the task?
Yeah, potentially they just couldn't quite get that autonomous system or even the drive system to start in the non-autonomous phase. Potentially they just couldn't quite get it working. We did see that happen with Aspen earlier in the week, but again, it's a first-time entrant to the Australian Rover Challenge. That does tend to happen on your first run. The communications environment in particular is very different to what they might have experienced in the workshop, longer different distances, buildings in the way, that sort of thing, and learning even to encode those drive motors is a bit of an art in itself. Again, that's not something that's typically taught in an undergraduate degree, so they're doing a lot of research in their own time to perfect those systems.
What an incredible effort coming out here, attempting troubleshooting. You know, they were out on the pitch for about 20-25 minutes.
That's right, and you know, they'll have the rest of today to work on their rover to come back fighting tomorrow for excavation and construction, where they'll be back on at 11:15 a.m. local time. You can see some nice shots of the workshop there. Lots of teams getting set up for the day. Hopefully they got some good sleep last night, but I have a feeling from the sleepy faces we saw this morning in Swinburne, they might have been going for a crunch overnight.
They've definitely done such an incredible job, and like we mentioned before, this was Swinburne University's final performance that we're going to see at the Australian Rover Challenge 2026. Look at that view of the field now. We're getting a wonderful bird's eye shot.
This is the second year running now that we've had the two simultaneous pitches going on pitch A and pitch B. And that really allows us to have as many teams as we can be open to competing in the challenge.
It's really, the simultaneous, pitches operating at the same time, seeing two rover teams completing each task simultaneously is really also helping to facilitate the growth of the challenge and really accommodate for how many teams are really coming out here from all over the world and all around the country to compete in this challenge. It's only getting bigger. This is only the 6th installment of the Australian Rover Challenge, and we're going to see bigger and better competitions, hopefully in future years to come. So there's Swinburne University taking in their rover to the workshop one final time. Again, immensely incredible effort from the team.
They spoke really positively yesterday when we interviewed them about the support they'd been given from their mentors and lecturers at the university. So that's just been fantastic as well to see the support, and I'm sure there are lots of lessons learned, and they'll come back better next year. Now, University Rover team also suffered some setbacks yesterday with their communications subsystem, so it'll be exciting to see how they get on this morning.
All right, so Uni Melb is on standby They should be setting up soon, now that it has ticked over to 9:45 a.m. The time for their task has officially started.
Looks like we can see one of the field team astronauts setting up a paver system. Not every team gets around to tackling this part of excavation construction. It takes quite a bit of extra work to think about how you're going to get your rover to retrieve the pavers to place in a connected path. It does take quite a lot of work to consider, will you use a robotic arm to pick up the pavers? Will you come up with a subsystem that can work for both rock clearing, construction and paver placement?
Cheers from the audience.
Very excited.
The lunar astronaut has set down that system with such precision. And now over to the team in the mission control.
The mission control team, of course, gets 15 minutes before the start time to set up in the base station.
And here we go. Rover is getting set down in front of the ramp. Not wasting a single second here, Uni Melb Rover team. What an incredible design. Very compact and low, and we're seeing a big excavator there at the front. Hopefully we'll see that in action today.
Yeah, of course, the teams usually opt to switch out their primary payloads on board their rovers, so amazing assignment. Is this your payload? I have a feeling it is. Got some thumbs up there. And it's a really exciting feeling when you get to see something that you've worked so hard on over the last 9 to 12 months finally get integrated on the rover. If it's anything like when we were in the team, this full systems integration tends to happen right before coming here to the challenge. So it's always very awesome to see when it's finally on board the rover. Now, hopefully it works. And there we go! Some movement already! Amazing job from the University Rover team from University of Melbourne.
Not wasting a single minute, like we said. So just a reminder, up to 100 points are available for the excavation and construction task. Part of that is the subtask rock clearance, so clearing some rocks from a particular designated area, and these rocks were placed by the judges.
And the teams can elect to complete these tasks in any order. So they've started at the bottom of the ramp, but maybe they'll go for the rock clearing first, or they'll go straight for excavation and construction. Sometimes we've seen teams even go straight for the pavers at the very beginning and test that out.
Seeing some really cool pivoting on the wheels there. Which task will they go for first?
Looks like they've gone for the on a dime steering, so they can steer their rover around a centre point. It's not something that every rover has the ability to do. Look at that, it makes its first treads forward.
Incredible wheel suspension as it climbs over that small bump. Makes its way, looks like it's heading for the rock clearance task.
I think you're right, and yeah, speaking of the suspension, look at the way it's so effortlessly gets over that crater.
That is incredible. We're seeing loud cheers from inside the workshop. We're hearing it all the way from out here. People on the stand looking absolutely proud.
Go Uni Melb! Absolutely crushing it already, and they're only 4 minutes into their task.
We're seeing teamwork and coordination take place inside the mission control team. And there's that live camera feed that they're seeing from their user interface. They've got a camera mounted at the top that they're actually adjusting there. So moving up, down, right, and left to get a better degree of freedom of view.
Yeah, and that's a massive advantage, isn't it? When we were speaking with the teams yesterday, a lot of them talked about how difficult the camera placement is. Sometimes you don't realise you have a blind spot until you're out here on the track, and if you've opted for static camera placement in particular spots, then you're really in a difficult situation. You have to manoeuvre your rover in quite strange ways to be able to get a good view, and even getting getting the depth perception is so hard.
And you know, the live feed and all the feed and information that these teams get from the rover is such a critical aspect of operating a rover remotely, because when we send rovers to the moon or to Mars, that is really all that we're getting. The information that the rover's sending and the live camera feeds. So really the placement of these camera feeds, the communication effort really plays such a critical aspect in getting as much information as you can to understand where is your rover, how is it positioned, what is actually happening on the lunar surface.
Team making their way into the crater. Looks like they might be up for some rock clearing. Let's see if they can get that scoop in action.
Alright, I think they might be going for one of these rocks. They've reversed back a little bit. I'm really, really keen to see this excavation bit in action.
So for the teams to get the points, they'll have to collect those coloured rocks that you can see inside the crater and then deposit them inside a specified gate. If they do that, they get points based on the size of the rocks. We had an absolutely nail-biting finish last year from the Adelaide Rover team, who struggled a lot at the beginning of the task. They were able to get their rover and their scoop working right at the 11th hour, and then they deposited some rocks just seconds before the end of the task. So this is also one of my favourite parts of the Australian Rover Challenge. It just really can get down to the wire. Oh, there's some action there from the scoop.
Here we go. A reminder, there is no requirement to use an end effector or a robotic arm to move these bits. It is also permissible for the rovers to actually just push or rather shove these rocks away or to the designated area, should they choose to do that.
Look at that, those two, the drive system and the scoop system there working in tandem. That is already complicated in itself to code on your system. Like you were saying before, there's two completely different subsystems. They've attached the scoop overnight and they've had to get it working with the rest of the drive system and those core rover systems.
Seeing
two separate controllers as well.
And they're working together with such precision. Looks like they're going for the smaller rock now.
You can see the happiness there on the faces of the team in the base station.
Alright, here we go. It's descending. It's approaching.
Go, go!
What an intense moment. I can feel... Oh. Okay.
Again, talking about depth perception, you know, they're working in essentially a 2D world there in the base station. Very, very hard to see.
Okay, almost in.
Nice view on the cameras there, giving the base station team good visuals.
And
they've got the rock! The very first rock collected of the excavation and construction task.
Well done to the University of Melbourne Rover team.
Absolutely killing it.
Look at those happy faces. They're really, really proud.
And you know, now that they've done this first one, that gives them hopefully a bit of confidence that they can attempt the rest. Look at that. You can see the speed is already picked up there from the team. They're like, we've got these points, but now they have to take it to that gate that you can see on the camera there. Great support here for Uni Melb.
And they're just under 10 minutes into their task, so they've still got about half an hour left.
Plenty of time.
What an incredible effort. They're
Wasting no time.
heading over to the designated area to drop that rock, I guess. We'll see some more action from the excavator. Meanwhile, over on pitch B, we should be expecting a UNSW Rover team at about 10 a.m. local time. So they're going to be attempting the mapping and autonomous task. They've got about 5 minutes to show up, set up the rover, have a go at it. So stay tuned for that part.
Oh, we see some sand getting deposited in that gate. Did the rock
Some
go
movement
with
from the
it?
excavator.
Because I suppose the tricky part here now is that they have to actuate it all the way down to get the rock to actually come loose from the scoop. You can see some cheers, so hopefully they've done it.
And you know, it is a pretty large and deep excavator, so the rock may have fallen all the way inside, and getting it out might be a bit of an issue. Or will they? Absolutely not top notch. What, we're seeing movement again.
Oh, yep, and I think I see a rock inside the start gate there, and I'm sure the base station team is double checking that.
It looks like they've successfully dropped the rock in the designated area.
I think you're right, and if so, that's points secured for Uni Melbourne.
Well done.
Again, what a comeback from yesterday, guys. You're just doing so well.
All right, here we go. Shall we go back and grab another one? Here we go. We're moving across back to the area where the rocks are placed. Do you reckon we could see the excavator pick up multiple rocks this time? I think I would really like to see that.
You read my mind, Shagaf. We saw that from Adelaide last year, who had a similar scoop subsystem, but it can work against them sometimes if they're a little too enthusiastic. Pick up a few rocks, but then drop them on the way, or in going for a second one, they drop the first one they picked up.
It is a risk, that's for sure. Trying to figure out which one they're going for now. Really.
It's also the risk that they bury that rock if they drive over the top of it as well. So we're going to see now if they can get that blue rock. Whoop, whoop.
Okay.
Check that out.
Okay, we're seeing progress. What awesome action.
They've got to be careful not to break the actuators there.
Look at the determination on that controller. Slowly and precisely. Uh-oh.
The suspense is real.
We're getting there. If you've just joined us, we're currently looking at Uni Melbourne Rover team attempting to complete the excavation and construction task. They've already picked up one rock, placed it in the designated area, and now they're going for their second rock. They started at around 9:45 local time, so they're only about 15 minutes into their 40-minute task.
Agonizingly close to getting those rocks. Oh, you can see the tension there with the team.
There's a lot of pain and distress that are visible on the team's faces.
We absolutely feel you. There are some major points for grabs here. So many things that they have to think about in the base station. They don't want to break that scoop.
The pressure is real, that's for sure. All right, ticking over to 10 a.m. 10 a.m. means over on pitch B, the UNSW Rover team has officially started their time or allocated time to complete the autonomous and mapping tasks. Still no show from the team. Could they be potentially troubleshooting in the tent? We'll find out shortly, so stay tuned. Meanwhile, we've got the Uni Melb Rover still attempting to pick up some rocks. All right, we're making progress.
I can see that
Well
they've
done.
got it.
What an awesome effort.
Nice chunky rock there.
You can feel the suspense. Everyone's rooting for this rover. Everyone wants to see the bittersweet moment of success.
You can see just how advantageous those two cameras they've got on the scoop have been for the team. They get such high resolution of what's inside the scoop to know if they've gotten that rock or not. Because obviously, you know, the field of view of those cameras is very narrow. So if they didn't have that pivoting camera on top, it would have been pretty tricky to know if they had the rock, if it was just slightly out of view.
That's absolutely correct. And here we go. The rover's making its way back towards the designated zone with rock number 2. What an awesome effort. Incredible action that we've seen this morning so far from University of Melbourne. Over the crater we go.
And again, they're just 15 minutes into their run, so maybe they'll continue to go for the rocks. Maybe they'll start the excavation component of the task, which requires them to collect regolith from a designated area and dump it into a zone similar to the one where they're trying to deposit the rocks. And the amount that they get, the more points are up for grabs.
Meanwhile, we've got UNSW Rover team bringing out that rover over on pitch B. Oh, they're going on the pitch. Will they be ready to start their task very shortly? Once again, their task time did officially start at 10 o'clock.
Look at that. They're trying to deposit the rock in a different way to before.
Oh, wow.
Nice job.
That's opened up from behind. That is pretty cool.
We saw a similar approach from one of the teams last year and it worked incredibly effective for them. So now that they've tested that depositing method, I have a feeling they're on a bit of a roll, Shagaf.
They're doing so well. And here we are on pitch B. We've got UNSW Rover team. They're getting set up. Will they start their autonomous and mapping task soon? We have not seen yet a rover demonstrate or perform this task so far. This is only the second team to attempt. The first team unfortunately had some issues and they ended up calling the task off. So here we go, UNSW. Will we see some action?
Uni Melb making their way around the crater edge there. Potentially they're doing a bit of scoping using that camera.
I think they're going to go around and try and go for one of the bigger rocks now, potentially.
I have a feeling you're right.
Do we think they can get all those rocks and complete one or both the other tasks in time?
It's a good question. It's already an amazing achievement just to get 2 rocks.
They're just about the halfway mark for their task time, so they've got about 20 minutes left to complete the excavation and construction task. What is their plan? We all watch with suspense, waiting to see some action. Looks like we might be moving away from this task for now. We're potentially going to explore other tasks. Let's find out. Gotta say, lots of happy faces and smiles inside the mission control there.
Looking very smiley for 10 a.m. on a Saturday, I have to say. Hopefully they're caffeinated up. I can see a coffee in the background there, so I'm going to say yes.
Are they potentially heading to complete the paver construction task?
I think you're right. Okay, so it looks like you can see some handles on the edge of that wooden box. They're going to probably try and pick those up using the end of the scoop, where it looks like there's sort of some matching extrusions there.
So the paver task, for those who aren't aware, requires these rovers to pick up and carefully place and align some physical tiles or panels that are transported from Earth. So these teams actually do have the ability to design and construct these pavers and actually place them out. So as you can see, those pavers, they were set up there before the beginning of the task. And the rover must be operated to pick them up and place them and align them. And the teams have set those pavers up for the rover and is now appearing to attempt at the paver construction task.
Now, these individual pavers have to start disconnected, and they can either be on the lander or in a dedicated payload made by the team, and it seems like they've opted for that second option there.
There's a lot of suspense. The team watches with hope.
Whoa! Oh!
Okay.
Amazing. They've got contact.
I'm not sure if this is amazing or not amazing. I'm seeing mixed reactions from the team.
There's a bit of oh.
Okay.
Oh,
okay. Here we go.
Very nice. So the teams can choose to cover any area of the challenge arena in any shape, but 30 points will be awarded for the proportion of a 1.1 metre squared area that is covered.
Round of applause and a cheer from the audience there as the rover looks like it's extracting or pulling out these pavers.
Absolutely losing their minds right now, I'm sure. And the paver construction is often one of the hardest tasks. We've seen teams try and try again to do this paver construction, and for many teams, you know, with the concentration on all the other parts of excavation and construction, this can sometimes be an afterthought. But Uni Melb, for them, it's certainly not. They cannot let that scoop drop. It has to stay connected to those hooks, otherwise they'll have to start all over again getting connected. I understand exactly what that feeling is like. Again, no two-way communication between the base station and the field team, so the poor field team just have to sit there in agony. And an intervention, if required, can only be called by the base station as well. So that really just adds to the emotions of the field team. We've actually got movement over on pitch B as well from RAS UNSW. We're underway in the mapping and autonomy task. Shagaf, I think that rover is operating autonomously.
I believe you are right. The very first attempt and performance we've seen at the autonomous mapping task. What an incredible view.
Yeah, we can see the team is completely hands-off there in the base station. This is indeed an autonomous attempt. So the rover will be trying to head to the identified sites. There we go, so you can see the waypoint there that it's trying to navigate to. Super impressive. They've even got camera feeds streaming as well as a bit of a map.
So you can see there's landmarks on the pitch there. So part of the autonomous mapping and autonomous navigation task is these rovers must autonomously navigate to these landmarks all over the pitch. There's no remote steering in this autonomous task as well, which just adds to the complexity.
So they've already secured points for leaving the start area autonomously, and for the landmark navigation, there is a whopping 30 points up for grabs. They get 6 points for each placard they can traverse to, and content that they can successfully image and relay to the base station judge while in the autonomous phase.
Look at that smooth, precise trek across the pitch. It's doing such a good job.
Yeah, very, very impressive.
A very compact and clean design as well. Really incredible cable management there. Now back to pitch A. Looks like Uni Melb Rover team has moved on from the Paver construction task.
The crowds are out in force here for University of Melbourne. Looks like they're going for excavation.
I think you might be right. Sometimes it really is all about accumulating as many points as you possibly can instead of just attempting at one task and spending too much time, but rather sometimes attempting half or a little bit of each task can actually get you more points than not.
That's right, and these are the trade-offs that the base station team have to make. Just like Formula One, a lot of these challenges are down to strategy. So they'll be trying to extract from the regolith acquisition zone.
And a round of applause from the audience there, as the rover looks like it's picked up some regolith to attempt the regolith excavation and berm construction. So this task requires the rovers to not only excavate that regolith, but they need to transport it to a construction zone and deposit it to form a berm.
And there's 5 points awarded for depositing at least 2,000 centimetres cubed. That is not a small amount, so the team is going to have to work to potentially do a handful of deposits to get those minimum points, and then an additional 25 points will be awarded for depositing larger quantities. And that's a relative function, so it's based on the largest quantity deposited by any team.
Okay, over on pitch B, we're seeing some incredible action from RAS UNSW. Looks like they may be facing some issues. That looks incredibly awesome.
You can see how the chassis design there just being a bit too large. The rover maybe not identifying the object in the way there.
Remember, this is completely autonomous operation, so the team in the base station actually are not remotely operating the rover.
It seems like it hasn't noticed the rock in the way. Just said, I'll have a go at this.
Round of applause from the audience, cheering on the RAS UNSW rover team. Oh. What a view! Here we go. It's really not really going for it.
This
not
is
backing
incredible
down.
stuff. You can see those. Yeah. Let's maybe not continue this. It says.
It's rock versus rover. Who should win?
That's in a pretty precarious position, Shagaf.
I gotta say, I'm loving the action that's coming out of it, Georgia.
This is right on the edge. This could go one of two ways. Because, of course, even if they switch over to non-autonomous, the team has to get out of this situation. If they make one wrong move, it's going to be game over.
Could the rover topple over? We've seen that happen in the competition before.
Absolutely, many times.
Look at that live camera view.
Situational awareness is pretty difficult here.
What is happening?
Not the world's most helpful camera views for the base station team.
I think they might be doing some troubleshooting. Over back to pitch A. Uni Melb.
Oh, nope. They
Okay,
are
we've got
indeed
moving.
coming back.
Oh. I think they may be successfully working around that issue. On the screen there, Uni Melb still attempting the excavation and construction task.
They're going back for round 2 of the regolith acquisition. This is an action-packed morning, Shagaf.
So much has happened here. It's great to see. Uni Melb trying to get as much regolith up as possible, and here we go.
Are they going to be able to get out of this situation? Now that
I have hope. I think they can do it.
Now for the non-autonomous phase, which it looks like they've entered because we've got hands back on the controls, they're going to be doing some exploring of the field, and looks like they're free.
What an incredible effort.
Huge cheers from the crowd out here. What a situation that they got themselves out of. Sure, they did have to enter the non-autonomous phase maybe a little bit earlier than anticipated, but that really could have been game over for them. Or game rover.
Well done.
And in the meantime, we've got another scoop from Uni Melb. That looks like a full tank there of regolith.
That's quite impressive.
Again, they're the first team of the day to not only do the pavers, they've done the paver construction, some rock clearing, some regolith acquisition.
But time is cutting it close, Georgia, now that Uni Melb has only until 10:25 local time. So about 5 minutes remain. How much? Oh, okay. Look at that flawless
very nice.
deposit. That was flawless.
Amazing.
What an awesome excavation system.
Yeah, I have to say, this is definitely one of my favourite tasks to watch.
That is beautifully done.
So smooth from the base station team.
And T-minus 5 minutes on the clock. Uni Melb has done so well so far, but don't go anywhere, because following Uni Melb, we'll have Deakin University Rover team on pitch A to complete the excavation and construction task.
That's right, Shagaf. This is going to go down to the wire for both teams out on the pitch right now. Wherever you are in the world watching this from, stay up late, because you are not going to want to miss this.
Back to pitch B. Here we go. RAS UNSW. They're now moving again successfully.
They are back. So they are now in the exploratory mapping phase. There are 40 points up for grabs for this part of the task. So teams must explore the broader arena beyond the landmarks provided that they had to autonomously navigate to. So there are some bright coloured cubes that they are going to be looking out for, and they need to report the coordinates of those blocks relative to the rover starting area to redeem the points. So this requires them to have a really good situational awareness of the map and also track the rover's coordinates. You can see there they're doing that in that window which has the waypoint finding. You can see they've got their relative X, Y and Z.
Back to pitch A, we've got Uni Melb with time crunch. They've picked up the third scoop. They're now turning to head back to the deposit location. What an incredible effort. They've done such a good job. They've got about 4 minutes or less remaining, but they must be super proud of themselves, as they should be.
Yeah, they've had some real highs and lows this Australian Rover Challenge, and this would be just the highest of the highs for the team.
There we go, heading over to the deposit area. 3 minutes on the clock.
Have they gotten that 2,000 centimetres squared?
And there we go, another successful deposit.
Just flawless action there from the team. Really see the increase in confidence here from the beginning. They're just in the zone now, going and grabbing that regolith.
I think after this task, University of Melbourne might be climbing up that leaderboard. So many points accumulated. They've attempted all 3 main subtasks for the excavation and construction. They've done a few of the rock clearing. They've done some regolith excavation.
Here it is.
Paver construction.
The final countdown.
T-minus 2 minutes and counting.
They need to get 2,000 centimetres cubed to get any points for this hard work. We can hear some chanting now from the crowd of URT. It's well deserved given the incredible effort this morning.
They're going for one more scoop, Georgia, and there's only 1 minute, 30 seconds on the clock.
Here we go, everybody. This is it.
The suspense is
Look
real.
at that suspension lifting the rover up. They are trying as hard as they can to get the regolith.
This is getting intense. It's all happening here, everyone, at the Australian Rover Challenge out in Roseworthy. It doesn't get more action-packed than this. Here we go.
Such a good look at that suspension team, and they have just 1 minute remaining to get it into the regolith acquisition zone.
Will they make it in time?
The countdown is on. The atmosphere is electric out here on the field.
They're not wasting a single second. 45-second mark hits now. Here we go.
Go, go, go.
Look at that effort.
Look at that
effort.
Uni Melb said 30 seconds. That's plenty of time.
And a really loud applaud from the audience.
What
an incredible
a
effort.
finish for the team. 20 seconds remaining. Are they going to go for another one, or if they called it time?
You'd have to be the Flash to go back and excavate some more in 20 seconds. Oh, what an awesome effort.
Amazing job. 3, 2, 1, and that is time up. the Uni Melb Rover team.
So proud of themselves. They're in the base station. High fives, big smiles going around. And out here on the stand, everyone is thrilled.
Incredible job.
What a great job. That was such awesome action to see this morning. What an action-packed morning, and it's not even halfway through the day, Georgia.
That's right. We've seen just 2 teams compete this morning, Shagaf. We've got Deakin, Blue Sad, RMIT, Monash, UTS, QT Royal, and rival today, the excavation and construction. That was such an adrenaline rush this morning, and I can't wait to see what else we're going to watch throughout the rest of the day.
Back here on pitch B, we've got Raz UNSW Rover team.
Absolutely killing it.
They've got about 15 minutes left. So plenty of time. And they had a really good start with their autonomous task this morning. Bit of an obstacle that they've hit, but they've managed to really recover from that, get back on track. What an awesome effort. And don't go anywhere, because on pitch A, we're going to be expecting Deakin University Rover team. Their time will start at 10:30 a.m. local time, and they'll be out here to attempt that excavation and construction task that we've just seen Uni Melb do such an awesome job in. They may have not completed one of the main subtasks fully, but they did attempt and do each subtask partly, and sometimes that's the smarter way to go about it to get you the most amount of points possible.
Absolutely. There were so many strengths there from the team, everything from the way those pavers just so smoothly came out of their self-constructed payload bay, to the rock clearing, to the excavation at the end there. They just really came and conquered that challenge, and we can see the judges are doing volumetric scanning of the berm. Some amazing technology. They're able to get a 3D scan of the berm material to be able to calculate the volume. So very high-tech judging we have here on the field. So getting reset for the next team. Now, it seems like Deakin have also elected to prepare their own paver construction payload. So the team will be getting ready to place that down on the field any moment now. It's Raz UNSW there.
UNSW still completing their mapping and autonomous navigation task. 13 minutes on the clock, and they're doing such an incredible job so far. We were talking earlier about how autonomy is one of the most difficult parts or aspects in the Australian Rover Challenge and in real life when getting systems to work autonomously. Reliability, robustness really comes into play to make sure that these rovers, these systems can really operate autonomously, make decisions on the spot, and recover from that obstacle that they hit earlier as well. To be able to recover from that and continue their task, it's just been incredible to see.
Absolutely. You can see they've made their life really easy for themselves there on the screen, where they had that map and the relative coordinates. So all they have to do is try and locate to the colour cubes and report back exactly what is displayed on the screen. And that will get them the points because it's relative to their rover starting position. And we just saw before that it came up with a finish sign on their GUI, graphical user interface. So we'll watch to see if they've finished their run or they're just doing some swap overs there. Now, Shagaf, you were also part of the Adelaide Rover team during your undergraduate years. Do you have any favourite memories of your time in the team or things that you worked on?
I worked on one of the end effectors for one of the tasks back in 2023, a while ago now. Bit of a painful memory. I don't know if I want to mention this because I worked on that piece and then it didn't actually end up getting used because of, again, communications. That was the culprit. Still is the culprit, number one culprit of operating these rovers in the challenge. So yeah, I was really excited to see it in action. I think we got to test it out after the challenge was over, but that was my contribution, and it was such an incredible time, such an incredible team. I remember just the spirit, the sportsmanship, not just within the team, but between all the other teams as well. Everyone's just helping each other out. Everyone's in the same boat. Everyone's trying to, build these skills, build networks, build these relationships, gain such critical capabilities and skills as part of this competition that they will carry on later in their careers, that I've definitely carried on in my career as well.
Yeah, I completely agree. We've said a lot throughout this challenge that the camaraderie is so strong here, and it's all part of the vision established by the team of the Rover Challenge about. It's not just about the points, it's really about the networking and the friendships that will be formed. We could hear some cheering and whooping from inside the workshop as teams came off the pitch, and that support for everyone is just fantastic. Got the team resetting the field here. Shout out to the amazing volunteers that make all of this happen. Got Deakin waiting on the side there. They've been given the go-ahead. So they're coming out onto the pitch now to place down their Paver payload. Seems like they've gone for a bit of a similar system to what we saw with Uni Melbourne just moments earlier. Big handle that potentially their rover is going to try and grab a hold of.
Looks like they're also setting it in a different... So they get to pick where they set it down. And choosing close proximity to the lander or where the rover will be starting, just to make life that little bit easier. We're seeing as well Raz UNSW rover there, looks like has stopped moving. Is there a potential issue? Are they potentially troubleshooting?
Yeah, that's right, because they have about 8 minutes on the clock. So we did see before that they'd had something on their GUI that said finish, so a little unsure what's going on there.
Well, while we're waiting to see what's happening, and we've also got Deakin University setting up to almost start their task, let's throw over to Fida, who's in the workshop, and we'll get an interview from University of Western Australia.
All right, we've got Hunter here from University of Western Australia. You got the mapping and autonomous task coming up soon. You guys did really well last year, came second, I believe, in the mapping and autonomous. So,
yeah, we came second. We're actually the University of Wollongong, not Western Australia.
Sorry.
But yeah, we came second last year, which we were very happy with. And we found out that the fundamentals are where it matters from that, and we're taking that into this year. Last year we were mostly actually hard-coded, and we just tested. And this year we've increased our autonomous part of it, rather than adding error correction and better path planning. And so we're hoping that should allow us to not hit anything.
Yeah. No, that's really cool. What are some other design changes you've modified from last year? I was talking to Connor, I believe, and he was talking about creating more modular design for repairability, so just making things easier to access. How have you found that helpful for this year?
It has made life much easier in the control scheme of it and design. We've decided every system should be interchangeable from preset interfaces and connectors, one power line, one USB for CAN interfacing, and that allows real quick on-off. Our battery pack is hot swappable, so we can take one out, put the next one in a blink of an eye, and it instantly connects to our system. So it's made iteration much faster.
Yeah, that's really great. And yeah, as someone who's come to the Rover Challenge for another time now, what have you found different or new for this year compared to last year? What were the newer challenges?
Well, I think the biggest challenge everyone's facing at the moment is the telecommunications. We've been reliable on one day and had extreme issues on the next day, so we're trying to sort that out. Outside of that, this being our third year now, making sure that we get the system to get all functionality without getting losses whilst increasing our mechanical and electrical capabilities has been a major step for us. So, yeah.
No, awesome, great. So best of luck. I hope that you guys just smash it out in the mapping and autonomous task later this afternoon. Yeah, I'm sure you guys will do great. All right, back to you guys in the commentary.
Thank you, Fida. And we're seeing some movement now.
From both pitches, actually. We've got UNSW zooming around the course, trying to get in the mapping for the last 5 minutes of their run, and Deakin have just shown some signs of life there on the pitch. There we go. No time wasted.
Look at those little blue wheels. That is adorable. I love the blue theme across the Rover. It looks like a rocker bogie suspension there as well.
Yeah, that's a classic design for Rovers, isn't it? Shigaf, do you want to explain to people what a rocker bogie suspension system actually is?
So a rocker bogie suspension, as you can see here on the screen, it's designed to help the Rover traverse rough terrain without rocking the chassis too much, to avoid tilting or toppling over. There's a special design as well, or critical design in the wheels as well, the shape of the wheels, that could help prevent the Rover getting stuck in the sand or the lunar regolith. Now, I'm not sure what's just happened over here.
I think we might be seeing a technical issue here with the robotic arm. So the robotic arm would be controlled by a series of motors that control the joints, and potentially there's an issue with the encoding there. I know we've had this problem before where if one of the motors drops out, the whole arm will just fall to the ground, as we've just seen there. Yeah, we can see they're looking at the motors.
Could they troubleshoot this and get back on track? They've only just started their task.
I think they'll be able to recover, but it just depends what's gone wrong. If it's a power issue with the motors, that's going to be quite difficult for the team. If it's a connection issue, however, it's a little bit more recoverable.
Meanwhile, over on pitch B, we're still seeing some action from UNSW Rover team. They've only got about 3 minutes remaining.
Yeah, they've honestly had a really great run. Like, they gave a great attempt at autonomous. You know, if it wasn't for that rock, I have a feeling they would have gotten around to more of those waypoints, and they've really made the most of their non-autonomous time. Oh, and Deakin have got their arm back again. Amazing stuff.
Great troubleshooting and working under pressure. Here we go.
Wow,
we're seeing action from the arm.
That was pretty touch and go for a minute there.
They're attempting the Paver construction part of the excavation and construction task. So once again, for those who are just joining, we've got Deakin University on the screen at the moment on pitch A, attempting the excavation and construction task.
Oh, this is going to be tough. You can see the hook that they've got on the end of that end effector there. So I can imagine they're trying to get that lined up with the orange handle. Again, depth perception so difficult here. You can see they've just got those two cameras that they're working with.
Can be quite restraining. And the reminder that these pavers are designed by the teams and placed on the pitch before the start of this task. And the Rovers must pick them up, place them down and align them to construct a paver system on the moon.
Yeah, and they're trying to cover a 1.1 metre squared area. Nice 360 rotation from the end effector there. That's also something that's pretty difficult to do. Because obviously you need wires that attach that end effector all the way up through the robotic arm link. You don't want them getting twisted around and then snapping or coming loose, because it could kill the entire arm.
Looks like they're going from over rather than from under. They've got looks like a bit of a hook shape there, and they're trying to pick up the paver from that handle. We can see some cheers from inside the workshop, or rather we can hear the cheers from out here.
We're hearing the calls of URT, some big celebrations tonight. Oh,
there we go.
They're up and away with the paver placement.
Well done.
They're going to have to connect the pavers together, though. Has this maybe not quite gone to plan?
It's only 10 minutes into their task. Back to pitch B, it seems RAS UNSW's rover has stopped moving, but it is now 10:40, so that is the end of their autonomous and mapping task. So a round of applause there for RAS UNSW team. Incredible effort, particularly that one moment where it really got stuck in that large rock. Very intense. They managed to recover and continue the task.
That's right. They got the autonomous system working, so that's a huge achievement. And they'll be back on the pitch tomorrow at 12 p.m. local time for the excavation and construction task.
And don't go anywhere, because on pitch B we're going to be expecting Adelaide Rover team. In about 5 minutes, they're going to be attempting the autonomous and mapping navigation task.
In the meantime, Deakin is giving us plenty of action out on the field. I reckon they're making their way over to the excavation regolith zone.
Again, making use of their time, attempting each task, even if it's not fully complete, accumulating or trying to accumulate as many points as they possibly can.
Now you can see they've gone for a completely different design here with the regolith excavation. Rather than the scoop that we saw from URT, they've opted for the clamshell approach. This makes a lot of sense. They'll be able to collect the regolith and then snap that end effector shut to make sure the regolith doesn't spill out as they make their way over to the acquisition zone. But I wonder how this is going to work with the rocks. And actually, it seems like they've changed direction and they are going for the rocks now because they're pretty bulky. So
it's really interesting to see the different types of end effectors that the different teams have custom built, designed and manufactured, and the different solutions that they come up with. So many innovations and creative ways we've seen people attempt all these tasks in the Australian Rover Challenge. That rover arm does look a little bumpy to me. I don't know about you, Georgia, but I'm a little worried about the sturdiness of the robotic arm.
yeah, I do agree. This is one of the highly challenging aspects of the rover, is getting a reliable robotic arm. We talked yesterday about the PID tuning that's usually required on these to reduce that sort of jerky movement that we get. And they've opted for, I'm pretty sure those are some carbon fibre links. The sort of black tubing there. It's a good option because it's lightweight and high structural integrity. But it does mean that you have to go for quite a rigid design.
Still some awesome action so far in their excavation and construction task. Well, we'll see that end effector in action. They've approached some rocks. They have not picked up a rock successfully thus far.
Yeah, we've actually not seen that end effector open yet.
We're really keen to see that in action.
Hopefully that motor is working.
Here we go.
All right, nice.
Wow. Wonderful. Oh, okay. How wide can it open up? And it's going for another rock again.
Said, how about no?
I think it doesn't like that rock. Maybe it's going for a smaller one.
Or maybe they're using a camera on the side to line up and then they'll swing back. Oh no, actually I think they're going for that yellow one just in front there. Yeah. I mean, it's a bit of a flatter top, so potentially that is a rock that they can fit inside that clamshell.
All right, trying to get the precise positioning here. We want to do it once, so we want to do it right.
You can see they've made great use of 3D printing here. That's definitely a 3D printed end effector.
Here we go. Closing that clamp.
Oh,
picking up that rock, and
wow.
There's cheer from the base station.
Yeah, nice work, Deakin.
What an incredible view.
Easy work of that rock collection.
This task is no match for Deakin Rover team.
Can they keep a hold of it though? If the motor, for whatever reason, Power's off. The end effector might open back up again.
Here they go, over the crater, towards the deposit zone. Only 15 minutes into their task and they're doing such an incredible job so far. All right, we're getting ready to deposit.
They're gearing up, mentally preparing. It looks like that rover is getting into position there.
The crowd watches in suspense, and there we go.
Too easy for Deakin Rover team.
Well done.
I'll have some points. Thank you very much, they say.
Now it is also 10:45, which means the time has, or the available time has started for the Adelaide Rover team to attempt the mapping and autonomous task. We have not seen them out here yet. They may be doing some last-minute troubleshooting, tweaking, preparing to complete the task. Oh, look at that. We're reversing back into the crater.
Oop.
Wow, that was smooth.
Very nice. Great shortcut there.
All right, and while we're waiting for Deakin University to pick up these rocks, let's throw back to Fida in the workshop for an interview with the rival rover team.
All right, we've got the rival robotics team here with me today. Why don't you briefly introduce yourselves and what you do on the team?
Okay. Hi everyone, my name is TV. I'm from the rival team. I am as the electrical staff, and I'm studying electrical engineering.
Okay, my name is Syawal. I'm from rival team and I am head of electrical. I am studying electrical automation engineering.
Okay, hello everyone. My name is Dharma from rival team. I'm from mechanical division and also as a team leader of rival team. And I'm studying materials and engineering.
Awesome. Nice to meet you all. They've come all the way from Indonesia. First rover challenge, right? Awesome. First of all, how are you finding Australia?
Okay, first about the Australia, we got info about Australian First Challenge for last year. So we excited to join to compete in here. So we for last year until now we doing research to can compete in here. So yeah, right there.
Great. Yeah, we were talking about how it's a bit chilly, it's a bit colder than what you're used to. But yeah, last year was actually quite warm, so there is a bit of a change in weather, but I'm sure that plays in part with how you design and modify your rover as well. You've got the excavation challenge coming up soon. What are the preparation you guys are doing for that?
Maybe for the preparation for the excavation construction task, we just change our end effector from gripper to the scoop so that we can lift some rocks, some sand, and also for the paver construction. We also developed our arm so our driver can do the task better. So yeah, we just practice to make our performance better.
Great. And last question, it's your first time here. Last few days, I'm sure you've learned a lot. What has been the biggest learning from the last few days? What have you found by seeing the other teams and things like that? What has been the biggest learning from this challenge so far?
Yeah, I think in this competition we learn how another team in another country work together, and we interact with they, so we can. Yeah, I study like that.
Oh, that's okay. Do you have any other lessons you want to share?
Yeah, maybe for the terrain, because we practice in Indonesia in flat terrain, but in here we actually doing in sandy terrain, and it's kind of a little bit problem, but we have to doing adaptation. So yeah, we learn a lot.
Yeah, well, look, we'd love to see you come back next year as well. I'm sure there's a lot of new ideas that you've already thought of that you'd like to bring to the next one. So, yeah, definitely would love to have you back. And yeah, thanks for coming around. Back to you guys in commentary.
Alrighty, thank you, Feeder. And while we were talking with Rival, we saw some more action here from Deakin Rover team. They successfully collected another rock and they were able to deposit it into the zone. So incredible effort there from the team. Now we're back to some nail-biting action where they're going for rock number 3.
Here we go, opening the clamp. Positioning with precision. Okay. Now they've just gone into the halfway point of their available time to complete this task. So they've got about 20 minutes left. Plenty of time. Will they potentially go and attempt the other subtasks as well? Stay tuned to find out.
Coming up in just 10 minutes' time at 11 a.m, we'll also be having an interview with Miss Hiroko Asakura, who is the Global Alliance Specialist from iSpace, who are one of the sponsors here of the Australian Rover Challenge and sponsor of the Space Resources Task. We're really excited to chat with her soon, so make sure you're watching at 11 a.m.
Some views in the base station there. Someone's got a paper taped to them, but I can't figure out what it says. I think they've labelled themselves as something. The rover has not moved for a few seconds now. Will they successfully pick up rock number 3? They've done such a good job so far. Just a reminder, we should be expecting Adelaide Rover team potentially any minute now. I'm not sure if Adelaide Rover team will be coming up shortly or not over on pitch B where the...
check out the message. So, hi, Oliver. We've heard that's the nephew of the team member there in the base station. Shout out to Oliver, wherever you are in the world watching this live stream.
That is quite wholesome. And just shows that how many people have been connected through this community, people from around the country and around the world, and what a global stage we're presenting here at the Australian Rover Challenge all the way down in Roseworthy, South Australia. Some excited members in the workshop area.
Huge celebrations there from URT. We are so proud of you guys. They did such a fantastic job. I'm sure they'll be celebrating tonight, but hopefully not too much because they are the last team on tomorrow, rounding out the end of the Australian Rover Challenge at 2:45 p.m. for Mapping on Autonomy. I can't believe tomorrow is the last day. It's coming to an end so fast.
That's right, and there will also be an awards ceremony amongst other events happening, so definitely stay tuned.
That's right, so we'll have a bit of a break in the live stream tomorrow, but then we will come back for the closing ceremony and awards, so that will be something really special to be a part of. So if you're watching from home, make sure you don't tune off at the end tomorrow because we will be coming back later.
Oh, I think we may have potentially collected a rock. Some round of applause there. Okay. Looks like good news. Right, we're moving over to the deposit zone. We can see those two rocks that Deakin University Rover team has previously placed, and they're going to place their third. There we go. That is awesome. Great amount of points accumulated and just under 15 minutes remaining for their task.
Are they going to get time for the excavation? That's the question I've got on my mind. You know, they've done a bit of the paver placement. They've gone for 3 of the rocks.
Will they attempt it at all? You know, considering how much capacity that clamp has as well. Could it hold as much regolith as we think it could? The previous team definitely had a large excavation bit.
You can see a really nice view of that rocker bogie differential working there. You could see just how confidently it traversed over the edge of the crater, keeping that chassis nice and level.
We also can see the Adelaide Rover team has come out with their gorgeous purple Rover there. The available time did already start at 10:45 a.m. local time, so they've eaten about 11 minutes into the task, but still plenty of time to collect some points. Hopefully they'll get set up soon. Deakin University Rover team, I think, is just going to focus on that rock clearance task here, since they've done such a good job with it. And that's smart as well, really just sticking with your strengths. If you're really good at a task and that can get you the most amount of points possible, sometimes it's good to just stay there and get all of that done.
Looks like they had a little bit of a connection drop out there. I just saw them reconnecting to the robotic arm. Might have affected the last couple of seconds there. We can see, oh, there we go, yeah.
Uh-oh.
The robotic arm has just gone limp, like we saw at the beginning of the challenge. I have a feeling that means it's powered off.
They've got 12 minutes remaining though, Georgia. We're really keen to see them recover from this and continue that task. Oh, there we go.
There we go, back again.
Quick recovery. On the spot thinking, problem solving.
Go, Deakin. Now their rover is called Borealis, which you can see printed on the front part of their rover. We might get a view of that as they come back around. I really love how all of the teams give their rovers a name that's something pretty meaningful to the team. Oh, still having issues with that robotic arm.
There's Adelaide Rover team with their purple rover. They're set up on the sidelines.
Now their rover's called Spyro, acknowledging the cool purple colour scheme, which is also celebrating the launch of Adelaide University. You can see it aligns really nicely with the AU logo on the banner there.
Adelaide Rover team only has about 25 minutes remaining to complete the mapping and autonomous task on pitch B. Meanwhile, on pitch A, we've got Deakin University Rover team potentially recovered from that disconnection to the robotic arm. 10 minutes on the clock. It's getting intense.
They've come so far, this task, that it would be such a shame to not be able to get just one more rock. And the time has now ticked over to 11 a.m. and we have Miss Hiroko Asakura here in the commentary box. Now, she is the Global Alliance Specialist of iSpace Incorporated. First of all, Hiroko, it is fantastic to have you back here in Australia. How have you found the challenge, and welcome?
Thank you very much. Well, I'm really happy to come back here this year too, and I'm really enjoying watching this competition. And yeah, the challenge is like Australian Rover Challenge provides a tremendous value for students aiming to enter the space industry. And space missions require not only technical knowledge, but also teamwork and also the ability to solve problems under the constraints. So it is a real demonstration of these real-world conditions.
I couldn't agree more, and it's fantastic to have iSpace here again in 2026. You've been a supporter of the competition since it began in 2021, and it's grown so much since the start. So I wanted to ask, there was some very exciting news from iSpace yesterday with the announcement of your new Ultra lander. So this new lander draws on elements of both the Apex 1.0 and Series 3 landers developed in Japan and the US. Could you tell us more about this new lander and its capabilities?
Sure. So the new Ultra lander derives its name from the Latin word ultra, meaning beyond.
Okay.
So building upon the lander model Resilience, which was used for iSpace 2 previous lunar missions. So Ultra is based on the current Series 3 lander, currently in development. And by combining those features of the Apex 1 of the US, then currently under the development by iSpace US, and the new model is expected to deliver even higher quality with several hundred kilogram payload capability. So it's a total integration of those two technologies.
That's amazing, and it's wonderful to hear the importance of the name behind your lunar landers as well, just like the rovers out here on the pitch. So the Ultra lander was only the first part of the announcement with iSpace updating its mission schedule. Could you tell us more about that?
Sure. So our next moon landing mission is scheduled for launch in 2028. And the destination is as the lunar South Pole area.
Okay, that's a very important part of the moon.
Yes, really important. And as a commercial lunar transportation service provider, I'm really happy to share with you that we are flying with customers, including the Taiwan Space Agency, with their vector magnetometer and ultraviolet telescope, and also with the Institute of Science of Tokyo with their lunar orbit satellite. So I'm really excited to have them there.
That's some very exciting international collaboration there. So you've already got payloads lined up for this new lander. That's very exciting. Over the 4 days of this challenge, we get to see a number of different rovers undertake a range of tasks, either by themselves or with help from some smaller supporting rovers. If we look to the moon, how is iSpace thinking about the future of lunar surface operations?
Yes, I really think that they provide a vital logistical backbone that supports and underpins the future, the lunar surface architecture itself, the whole picture.
Yeah.
And for example, it's full of variety actually. So from Japan, so they're now developing a manned pressurized rover for the human presence on the moon surface.
Yes,
sure. And also for the robotics rover. So as one of the example, I would like to introduce our future vision of the rover, which is called the Magpie. Magpie is a European-led lunar rover mission funded by the European Space Agency, the Small Missions for Exploration initiative, and spearheaded by iSpace Europe. So it will be the first in situ European rover mission to prospect for lunar polar resources, and combining advanced instruments, European engineering heritage, and European consortium experts to map, measure, and understand the moon's most valuable resources. So those kind of various technology of the rovers and the size and the functions really means a lot.
Absolutely, and it sounds like the mission that Magpie is going to undertake, very nice name by the way, is very similar to what some of the rovers are doing here in the Space Resources Challenge. They're prospecting and looking for really important resources on the lunar surface.
Yes, and also especially for the lunar South Pole, it is extremely important.
Absolutely. We think that there is water in the lunar South Pole. For those who don't know, there are permanently shadowed regions there where the temperatures get cold enough for frozen ice regolith. And so it's a really important area to explore and has not yet been properly explored by rovers. So this is groundbreaking stuff. And my final question is, do you have any final words of encouragement for all of the teams here today? They're tackling some of the very same challenges iSpace is addressing with their own lunar missions. What would you like to say to the teams?
Well, I would like to just say that the challenges you're tackling today are just you said, and fundamentally the same as those we were facing in our real lunar missions at iSpace. So, but your experience will be very valuable for your future. So I really look forward to your challenge to the missions.
That's super exciting. I mean, I can see your passion there about watching the teams do, I guess, almost a practice run for what is happening in real life. Thank you so much for your time this morning, Kuroko. It was fantastic to hear you have at the desk, and enjoy the rest of the Rover Challenge and your time in Australia.
Thank you very much.
Thank you.
All right, switching back to the pitch. Deakin University Rover team has now picked up another rock. Now, there is a time crunch because they've only got about less than 3 minutes to complete the excavation and construction task. So you can see the team in the base station there working really hard. There's a lot of pressure at the moment. And meanwhile, we have not seen the Adelaide Rover team set up yet. They have come out on the side of the pitch there, but it seems they're still troubleshooting or testing potentially. This is unfortunately eating into their time to complete the autonomous and navigation task. So the Adelaide Rover team only has about 17 minutes left to complete that task. All right, less than 2 minutes remaining. We're going to deposit what looks like the 4th rock that Deakin University team, or Deakin Rover team rather, has picked up. Here we go. Rover arm is fully operational, flexible movement. Woo-hoo! And there we go. Round of applause there. Well done.
We had a let's go from Deakin River. 1 minute and a half remaining.
They're going for one more rock. Can they do it in 1 minute and 20 seconds? Time is on the clock. We've got an I Love Blue sat from the crowd there.
They are, of course, coming up right after Deakin, so they must be very excited to watch that run. Now, reflecting on Deakin's run this morning, they have overcome some difficulties with their arm to really make the most of this remaining time.
I don't know about you, Georgia, but I'm getting really, really intense now. Under a minute, and they're still trying to go for one more rock.
I'm getting pretty stressed out, Shagaf.
We keep seeing some rigid movements. Very discreet from the robotic arm.
That's a big rock too. There are some big points up for grabs if they can get a hold of this one. Because the number of points scales with the size of the rock.
Team at the base station looks very, very determined.
Ooh,
they're not wasting any seconds.
Some hands on the controller there. They're going to be able to get it. Oh, the arm is going down.
I think we've only got about a few seconds left. And that is time up, unfortunately. As it clocks over to 11:10.
That is time up for Deakin Rover team. Well done. Fantastic effort there. Again, leaps and bounds on what they were able to accomplish last year.
Team looks really proud of themselves, as they should be. That's a total of 4 rocks that they've picked up and deposited successfully. They also managed to pull out one of the panels, potentially accumulating some points for the paver construction task. Awesome work to the Deakin Rover team. Don't go anywhere in about 5 minutes. We'll be waiting to see BlueSat Rover team out here on the same pitch to complete the same task, excavation and construction. It's been an action-packed morning so far, and it's only getting better. Here we go. Back to pitch B. Adelaide Rover team still on the sidelines. Still troubleshooting, still testing. Will we see them attempt the autonomous and navigation task, or rather the autonomous and mapping task? Unfortunately, they only have about 14 minutes to get set up and attempt. Here we go, there's a team at the base station.
Looks like they're getting something set up there.
Could it be communications? Could it be the motors? Could it be the robotic arm? No, there is no robotic arm for this task. This is the autonomous task, after all. Another round of applause there from the crowd as the Deakin Rover team transports their rover back into the workshop area. They are beaming with pride, and they should be so proud of themselves.
They have emerged victorious from this task. They can hold their heads high, even though they maybe didn't quite get to some of those bigger rocks. It was a very, very impressive job.
Hopefully you guys are able to get...
So we've got Deakin walking off over here now. We might try and see if we can get Feeder, who's our roving reporter, to grab them as they come back. They want to have a chat about their last run of the challenge. Shigaf, it's just been non-stop this morning, from Deakin to Uni Melbourne, Swinburne's attempt after their setbacks. It's just been fantastic to see the perseverance here from the teams.
It's been amazing, and the excavation and construction task, is a unique challenge in itself. There's a lot of robotic arm movements. You have to be precise, you have to be accurate, you have to be sturdy and rigid. You want to be picking up things, you want to be dropping off things, moving things around. It can get very, very challenging, and we've really seen these rovers get tested this morning. And we're not finished just yet as well. We do have BlueSat Rover team to start in about 2 minutes, so hopefully they're ready. Hopefully they're coming out soon to pitch A to get started on the excavation and construction task.
Speaking about testing their rovers, the teams have had a unique opportunity this year to qualify for a new competition called International Lunabotics. Now, Lunabotics focuses more on the excavation side of the rover challenge, collecting regolith inside a different style of regolith pit. The regolith there is a simulant that is used in real-life rover testing that is quite different. It's very grey, it's very fine regolith, and it requires a different chamber setup. So the teams have been using the Adelaide University Xterra's crater facility, which was only constructed towards last year. It's a brand new facility for testing rovers under accurate lighting conditions and accurate environmental conditions, including a gravity offset, which is very exciting. So the teams can nominate to compete in that task at the end of yesterday, today and tomorrow. And if they qualify successfully in that event, they'll have the opportunity to go all the way to Florida to compete in the international competition.
And there's some views from inside the workshop again. Deakin Rover team, so thrilled. Hugs, high fives, smiles all around. All right, here we go. Back to pitch A. We have BlueSat Rover team.
So great to see the smiles on those faces there. It's really, really well deserved from the team. Coming back out again, I'm sure, to watch the other teams compete today and support them.
What an incredible journey so far.
Absolutely, and it doesn't stop there with BlueSat already out on the pitch.
There we go.
We've got that two-way comms there.
Now, correct me if I'm wrong, Georgia, but we saw BlueSat out here last year, but they didn't get to actually compete in the challenge. Were they just a demonstration last year?
Yeah, well, they ran into a few issues last year getting their rover up and running, and they certainly learnt a lot, and it's been fantastic because this year they had a phenomenal run in the post-landing task.
We also have the Adelaide Rover team here, only with 8 minutes ticking on their clock. Looks like they might be ready to go. Even with such limited time left, they're making the most of it. They're almost ready to go. Looks like they're about to start the task. Can they get as many points as they can with 8 minutes and counting?
Yeah, we spoke with the team earlier in the week and they were really excited because they had actually developed an autonomous payload that they were ready to test. So, oh gosh, I really hope they got that systems integration happening.
All right, 2 rovers, 2 pitches. Let's see some action. Over here, BlueSat Rover team. Originally placed the rover on the lander, now down the ramp. Communicating with the base team, setting things up.
Looks like they've also gone for the scoop design for their excavation payload. Similarly to University of Melbourne.
The teams are now walking off the pitch, indicating they might be ready to call the start of the excavation construction task. And there's that BlueSat team inside the mission control base.
And in case they couldn't hear that, the BlueSat field team was chanting in support for the base station. Great moment of teamwork here from Deakin.
Such a good effort. This is what it's about, you know, teamwork. Well done.
No, because we were way too high.
We've got Feeder here. Wonder if he'll be able to chat to one of them in just a moment.
All right, movement from the Adelaide Rover team on pitch B and from BlueSat.
Whoa!
Well, we've definitely seen movement, and it's happened at the same time. What more could we ask for?
I agree, Shagaf. There's no other way I'd want to spend my Saturday, I'm telling you that.
For everyone else that's joining in the live stream, we currently have Adelaide Rover team on pitch B. They just started their autonomous and mapping task, even though they've got limited time to complete it. And then on pitch A, we have BlueSat Rover team. Just kicking off their excavation and construction task. Action-packed, happening right here in Roseworthy, South Australia. Here we go. Look at that rover go.
Looks like a crab. It's just absolutely flying along the pitch. If we ever had a rover drag race competition, Adelaide would be in strong contention.
They're definitely speedy, that's for sure. They're not wasting any time with only 5 minutes left for this task.
Be interesting to see from the base station. I have a feeling this is non-autonomous, but you never know. So Feeder's ready there with Deakin. We're going to throw over to him while we wait to see the next moves from Adelaide and BlueSat.
All right, we're on.
All right, so we've got the Deakin University. I think the whole team is here.
Yeah.
So congrats, first of all. Amazing work.
Thank you.
So yeah, talk us through what went down and what worked in that excavation challenge.
I guess our biggest development since our post-landing task was our video feed.
obviously in that task we just could not operate the rover. All our systems were working fine, but we just did not have the control that we needed to be able to do much. So we're a bit disappointed, but these guys worked.
More than made up for
they
it.
worked so hard to fix that feed, and then out there today it was so much easier to control. Like those rocks we did so well on. We just had a couple of issues with the CAN bus there, which we had to keep resetting, but these guys managed to fix it up, and we managed to get pretty much everything we wanted to achieve. So couldn't be prouder of these guys. That's
amazing. I think, pulling some late nights, I'm sure. But we see it was all worth it, right? At the end, it was great to see. Talk us through, you were here last year as well, right? So what were the learnings that you took on from last time, and what did you implement for this year? How was that whole cycle like?
So our biggest challenge for our development last year was that we just have never seen the track before. So I guess there's only so much you can learn from the videos, but once we got here, we really got a feel for what we needed to develop and work on. And so I guess that was just our camera use and adding on the arm as well. So last year we couldn't really interact much. We only had a camera and drivetrain, but we've added on the arm this year, which we unfortunately didn't get to showcase the other day, but I'm so happy that we got to showcase it today. So
No, it looked great. It was awesome. And you guys, your team, you have such a good morale, such good energies. What do you do to keep it going? Like, how do you hype yourselves up?
Say what you want to say. I just like to joke around. We're here to have a fun time and work as a team. And when a team really can work together, communicate with each other, and feel comfortable around each other, we communicate better and we work better as a team when we're not scared to say our own ideas and debate about things. But there's not really a debate because we have a lot of trust in each other. And that's really what makes our team great, because we have a lot of trust in each other and our ideas come together really well.
Well said. Yeah, awesome work.
What was that?
I think having open feedback, things like that make a big difference. Congrats guys. Look, I'll leave you to it. I'll leave you to your celebrations. Congrats again.
Thank you.
Back to you guys.
Thank you.
Awesome stuff there with Feeder and the Deakin Rover team. Again, trust is a must when you're working with such complex systems and integration here. And great to hear as well, they literally had a broken robotic arm earlier in the week, which they managed to fix and bring to the challenge, and it sure paid off. And look at that from Blue Sat. We've got Adelaide over there on pitch B, but over on pitch A, Blue Sat are making contact with a pretty chunky rock. Look at the face on that scoop there at the front.
I was going to say, that is so creative.
Loving the personality of these rovers during the challenge.
It employed a similar excavation bit to what Uni Melb, was it?
That's right. And speaking of creativity, Uni Melbourne's rover was called Gordon from Thomas the Tank Engine because their previous iterations had a Thomas the Tank Engine mascot. So loving that.
Cheer from the audience there. Here we go. We saw some action, but it seems to be standing still at the moment.
Yeah, we heard from Deakin that they had some issues with the CAN bus, and that is responsible for making the connection from the onboard computers to the actuation. If any of those wires come loose, it can be a proper disaster.
Some movement from Adelaide Rover team back on pitch B. A reminder, Adelaide Rover team only has now less than 2 minutes to get as many points as they can for the autonomous and mapping task.
It's still unclear if they're in the autonomous or the non-autonomous mode. But either way, they've definitely made some ground on the field today.
They've had some issues, but they've persevered. They've come out, they've tested, they've troubleshooted. There's that graphic user interface on the screen there. That's what the base station is currently seeing.
Yeah, I have a feeling this is non-autonomous mode. I think they've got a human pilot.
It looks like they might be stuck in the lunar regolith.
I have a feeling you're right. They've got a few glitches happening there with their core drive. Great camera feeds, though. Countdown is on. Less than 20 seconds now.
Have they called it? Lots of stress, lots of pressure, 10 seconds remaining. But what an incredible effort. Coming out and still attempting, even with less than 10 minutes, Let's have a round of applause for Adelaide Rover team. That is their time to complete the autonomous and mapping navigation task. Such an incredible effort.
Yeah, just fantastic work. You know, they could have chosen to pack up today, you know, try and come back for excavation and construction, but I'm sure they would have learned a lot still from testing the drive system out there on the field.
Well done. All right, so movement over on pitch A. BlueSat Rover team still attempting to pick up a rock and deposit in the deposit area or the designated area.
Loving the face on that scoop there.
It is quite creative. BlueSat Rover team is only about 10 minutes into their task, so for a total of 40 minutes, they do have about half an hour remaining.
Could this be the first? They just need to lift that scoop up, which they're doing slowly but surely. Nice work, BlueSat. But of course, it's not over yet. They actually need to take it into the specified zone behind them if they want to get the points.
What an awesome effort. Look at that pivot. There they go. Turning around.
Wow. Oh, nice. Again, the suspension system at work there, keeping everything nice and easy.
There's that BlueSat team looking so proud.
They must just be over the moon after their attempts last year and where they are now.
They should be proud of themselves. Again, recognizing the months and sometimes years that goes into getting these rovers out here, getting them functional, getting them working together.
Just conquering that crater edge there.
Approaching the designated area and moving that excavation end effector. Look at that.
Down it goes.
Loud
Can they get the
cheers
rock
from the audience.
free? And they've done it.
Such an awesome job from BlueSat Rover team.
Some big cheers there from the audience watching.
The base station looks determined. They want to get more points out of this, and they still have time to do so.
That's right. I feel like for a lot of these teams, that first rock is the hardest. And once they get started, they get into the rhythm.
Keep the momentum up. Meanwhile, over on pitch B, we're expecting University of Queensland Space Rover team. They're just set up on the side, they're chilling, they're good to go. Their task doesn't start until in about 2 minutes' time. And they're going to be attempting the autonomous mapping and navigation task.
I reckon BlueSat might start a trend here, Shagav. Faces on rovers.
I'm a big fan of it, I have to say.
Well, I think looking forward, it's something important. You know, if we're going to have humans and rovers working alongside each other on another planet or another celestial body, I'd want a rover that has a name and a face. It's looking with beady eyes at that rock, and there they go! Rock number 2!
Go BlueSat. I believe they've just picked up the biggest rock we've seen today so far.
That's right. That is a huge number of points up for grabs here.
The team's so energetic, buzzing with pride. Such an incredible effort. Loud cheers from the stand. It's flawless switching from the different drive modes.
Absolutely.
Between turning and transversing forward. That is just incredible.
It looks like, oh, there we go, they can strafe as well.
That's amazing.
Yeah, that's really useful for this precision required to line up inside the zone.
Here we go, deposit number 2. Large pink rock incoming.
Nice
and
work.
they've done it again. So much energy out here. We love to see it.
And they've still got plenty of time. They are just 15 minutes into their run.
There's that face again. I just can't get enough of it. I wonder if the face has a name.
I agree. Does the blue side rover have a name? Aesthetically. Nice.
Wow.
What does it mean?
Could we have someone come over and explain it to us? We're really, really keen to find out.
The team is deliberating.
Sending a representation spokesperson. Hello.
Come on over.
Lots of cheers from the audience there. Now, while your rover's picking up a rock, could you tell us what your name is and what your role in the team is?
My name's Greg. I'm one of the mechanical members on the team. But yeah, Asterope is a star in the constellation Pleiades, which is, as you know, maybe it's bright blue. And Asterope is actually the dimmest of the stars. It's the Seven Sisters. And we're hoping every year we're going to get a little bit brighter.
Oh, that is beautiful. That is just amazing. Thank you so much.
And before you go, I know your team is competing right now, but how are you guys feeling? You must be ecstatic.
Yeah. I think we're all quite happy with the rover. We had some of our software members working up late last night, and they've got the control working really nice now. I think it's showing with the rocks, so everybody's quite ecstatic. You'll hear the cheers on the sideline. And yeah.
Well done. Round of applause again. Thank you so much for joining us.
Thank you so much. Very impromptu interview there. Thanks to our camera team for helping us to set that up as well.
There we go. Number 3. Wow. That's number 3, isn't it?
That sure is.
That is so good. Blue Sat Rover team on a roll here, not wasting a single minute. That looks awesome.
And I love that metaphor too, each year getting a little bit brighter.
I love that they chose the star that's the dimmest in the constellation. Really just a representation that you don't need to start from somewhere that's already bright. You don't need to already have a lot to make a start on something and really build something absolutely incredible. So that is such a meaningful name. I'm a big fan.
That's right. The team's got a goal and they've certainly accomplished it this year. We're excited to see what they're going to do next. Ooh. Close, but not quite.
That excavation bit, turning with precision. What a wonderful job they've done so far. And in the meantime, we're still waiting on UQ Space Rover team. Their time has officially started as of 3 minutes ago. There we go.
Whoa.
Blue Sat.
Just making sure they've definitely got a hold of that rock.
It's just one rock after the other. I think they might be hitting the record so far for how many rocks a rover has collected and deposited.
You're right. They're almost going for a perfect score for this task. And again, plenty of time. They've only just ticked over halfway through their time in the challenge, and haven't they made good use of it? Really efficient. But can they get out of this situation? Did they celebrate too soon?
It's all about troubleshooting, problem solving, teamwork under pressure.
And no, look at that! Just holding on for dear life.
What an incredible sight.
But Shagaf, they've got to get it over the crater.
It does look like it's in a very interesting position.
This is going to be tense. That rock is holding on for dear life.
Oh no, I don't want it to drop. I'm really getting... I'm so scared right now. This is really suspenseful. Slowly but carefully, they make the turn.
Again, the suspension.
The team cheering them on.
Suspension critical here to keeping that chassis level. You don't want any vibrations or bumps to knock off that rock.
Look at that. Just look at that. Here we go. And another one in the bag. Secured.
Nice. Great job from BlueSat.
Such an incredible effort. I'm getting a bit emotional for them. This is really nice to see. I'm so proud of how far this team has come. All right, back to pitch B. We're actually seeing UQ's Space Rover team setting up. They're getting ready, placing that rover as precisely as they possibly can. Now they do have some time left. They've only eaten about 6 minutes into their time. So 33 minutes left, and they will start to attempt the mapping and autonomous task. So again, as you can see there on the screen, 100 points are in total available for this task. Some of them marked there on the screen, 5 points just to leave the start area completely autonomously. And then there's a few landmark and mapping tasks that can really grab them some valuable points. They haven't called the official start of the task yet, so they've still got communications with the base team, setting up, testing, making sure everything is top-notch, good to go. Once they call that official start to the task, all two-way communication will be cut off between the field team and the base station team, really simulating what it's like to remotely operate a rover, whether it be on the lunar surface or on the Martian surface.
Bit of a fun fact about UQ, it's the 5th iteration of their rover, so they're one of the more veteran teams in there. BlueSat goes with another rock.
Look at them go.
I have a feeling this is the... Whoa, are they going to go 2 for 2? They could. They are.
Oh!
The first multi-rock collection of the challenge if they do. Whoa, they're nearly there.
Look at that action. Oh my God.
Oh, check that out.
Oh my God.
That's a pretty big load.
That is a first in the Australian Rover Challenge 2026.
2 in 1, but they've got to keep it in.
Oh, wow.
You can see it's spilling out on the side, the sand there.
2 for 2. I can't believe I'm watching this happen.
Super efficient. BlueSat really owning this task. All right, here we go.
The suspense is real. Oh, this is too easy for them, Georgia. This is too easy for them. Piece of cake. Dropping those 2 rocks there.
Number 1.
Oh,
and they have it.
Oh, incredible. And the crowd goes wild.
You can hear the cheers there from BlueSat and co.
They'll definitely be celebrating tonight, that's for sure. And their time is not even over. Still about 15 minutes on the clock for BlueSat Rover team.
Every single one of those rocks, I have a feeling, are in the zone.
Did they have any rocks left or are they finished?
I think they're finished because they're heading straight over to the excavation zone.
Oh, look at that. Oh, this is so good. BlueSat Rover team now heading to complete another task.
And of course, it's not over yet. While they might have gotten all the rocks, they've nothing yet in the regolith acquisition zone. They need 2,000 centimetres cubed if they want to get 5 points. And the points stack up for all of the additional volume that they're able to obtain. We're hearing the cheer squad is repositioning.
The supporting team is moving around the pitch to go get a closer look of their wonderful rover now heading to the next task. So once again, 100 points up for grabs for this excavation and construction task. One of those subtasks is the rock clearance, which the BlueSat Rover team has completely and successfully achieved, and the first rover team to do so today so far. Now it looks like it's heading to potentially attempt the regolith excavation and berm construction. So this involves the rover picking up some regolith from a designated zone and depositing in a designated zone as much as they possibly can to achieve those points.
Slight pause here.
14, or rather 13 minutes on the clock and counting. Plenty of time for BlueSat.
That's right, they'll finish at 11:55 a.m. local time.
For those of you who've just joined us today on the live stream, welcome to the 6th instalment of the Australian Rover Challenge. It is now the 3rd day. We've just ticked over the halfway mark of the challenge. And we've seen an action-packed morning, such incredible views from so many rovers, completing both the excavation and the construction task, as well as the mapping and autonomous task. At the moment, we've got BlueSat Rover team on pitch A. They're completing the excavation and construction task. And over on pitch B, we have the Adelaide now, the UQ Space Rover team. They're still setting up and troubleshooting, potentially having some issues that they're trying to get resolved to start their task. So we haven't seen any movement yet, but stay tuned. Hopefully we'll see some action over there.
Ooh, and BlueSat look like they've just gone a little more than they bargained for, heading out of the regolith acquisition zone.
That's not good. Some laughter from the cheer squad here.
They have got a regolith scoop in hand. Now they're going to have to deposit it inside this zone.
I think they're trying to reverse into it and then deposit. So again, those poles that you see, those red poles, are actually to designate or to mark that deposit zone. So they must deposit that regolith inside that area. All right, here we go.
Looks like they're just on the edge there.
Wow, look at that.
Nice work from BlueSat. Looks like to me they've made it inside the zone.
They're heading back for some more. They're not stopping here, and they've got about 13 minutes on the clock. No, more like 10 minutes now.
That's an interesting approach. So they're driving into the side of the crater and then just driving back out. Not really having to do much actuation there on the scoop.
That's quite smart, I would say. A very interesting approach to excavating some regolith and depositing that regolith. Very efficient. There they go with their second deposit. Oh, they've done so well. Smooth, efficient, accurate. They've really made the most of their time, and what more could you ask for? 10 minutes is plenty. They are getting point after point.
We can get a good look now about their strategy here, just in that bottom left corner.
That's incredible.
Yeah, so they're doing a slight actuation, but driving into the cliff is really helping them. Great view
Look
there.
at that close-up. Oh,
yeah.
wow.
Lots of regolith. This might be their biggest scoop yet.
I think so far, BlueSat has probably accumulated the most points in all the teams that have completed so far. But we're not done yet. After BlueSat, we'll be seeing RMIT Rover team right here on pitch A to complete the same task. And after that, we will be going on a short break for lunch, and then we'll be coming back with more action for the day with Monash, UTS, QUT, Roar, and Rival all attempting the same excavation and construction task.
That's right, and it can't be forgotten too that this year there is a new efficiency multiplier. So on top of the 100 points available for each task, there are an additional 25 that rewards teams for designing compact, lightweight and efficient rovers. And these are some of the constraints that we do have to work with in real life on space missions. You know, there's only so much space available on a rocket, and time is money, and space components can be heavy and expensive. So for the teams that work around these constraints, they will pick up some extra points.
And another scoop over there from BlueSat. Rover team, look at that go.
Fabulous work.
This is just too easy. Such a proud moment as we tick over to just less than 10 minutes remaining for their task now. I have a feeling they're going to celebrate after this.
I couldn't agree more, Shagaf. And it's worth mentioning too that as well as the prizes available for getting the most points, there are also prizes up for grabs for different values of the Rover Challenge. Best newcomer, most improved, and I have a strong feeling that BlueSat have shown a big improvement from last year. Some cheers over there from UQ Space as the rover gets underway for mapping and autonomy, making their way away from the start gate.
Look at it go, zooming pretty fast, stopping, then going again, then stopping again. Will they get the points they need from this task to climb up that leaderboard? 18 minutes so far into their task. They do have until 12:10 p.m. local time. So about 21 minutes to go. They've started the task. Plenty of time to get as many points as possible from UQ Space Rover team. This is also the last Rover team before the break that's going to attempt the mapping and autonomous task. Big energy here on the sidelines. I don't know about you, but I think BlueSat is still going really well. How many scoops have they done now? I'm quite impressed.
I think this is maybe number 4.
Wow, look at that go. They're really trying to get as much in one scoop as possible. What an incredible effort.
Now speaking about prizes, some of the others that might be awarded this year are for Best Team Culture and display of camaraderie throughout the event. Also community spirit, demonstrating our challenge values, and I think we've seen that a lot from the teams this year. So much community spirit here. The space community is very tight-knit in Australia, and it's fantastic to see that amongst the students here.
Another round of applause. There's a team there in the base working hard. They're proud of what they've achieved so far, but they're not stopping there. With only 5 minutes left, they're getting as much points, as many points as they possibly can. And look at that big scoop there.
That's a bit of a greedy scoop.
I'm not going to lie, I think BlueSat Rover team has currently set the highest record for how much they've excavated and deposited in terms of lunar regolith and in terms of the lunar rocks that we've seen as well. So will we see another team top BlueSat Rover team in this task? Stay tuned after the break to find out. And even before the break, we actually have RMIT Rover team. They'll be coming on right after BlueSat.
They're just getting so efficient at this now, aren't they? They might have tested the limits of the actuation there. They can't quite angle it to get sort of level with the wheels. It's going to be tricky to get that last bit of regolith out. Or shake it loose, perhaps. And they look like they have done exactly that.
Such awesome work from BlueSat Rover team.
Yeah, they've really just been able to rinse and repeat here in the remaining time. This is going to come in handy for them as they do the International Lunabotics qualifier.
This is just going to show the system reliability, the robustness as well. Getting something that's working over and over, not just once, not twice, but really doing the repetitive task and getting the most out of it.
Yeah, such a great view of the linear actuator there, helping that scoop do its job.
Now, just as less than 2 minutes remain for BlueSat Rover team. They've done so well so far, and they're still going. They are not stopping. They're making use of every last second possible.
They've absolutely got a formula here. You know, it seems to be scoop, reverse, strafe, adjust, deposit, repeat. It's really playing to their advantage here.
Another one in the bag, and less than 1 minute remaining. They're going again for another scoop, I think.
2 more.
Oh, wow.
Guys, that's ambitious. All right, here we go. BlueSat, they've set themselves a target. They want 2 scoops before time's up.
Remember, 11:55 a.m. is the official end for their task, so will they do it in time? Here we go. Getting intense. There's number 1 on the way. Slowly but carefully depositing that regolith. And
down it goes.
Well done. Are they going to go for one more? Here we go. I don't know if there's time. Oh boy.
Wonder if we can get that timer up on the screen. Oh, it appears they might be done. No, that looks like a celebratory burnout there.
That is beautiful.
3, 2, 1, and it's time up for BlueSat Rover team.
BlueSat Rover team. So much cheer from the sidelines there.
Absolutely ecstatic celebrations.
Well done. You should be proud of yourselves.
I think they can't believe what they've just achieved. The team's doing a power readout now before we get ready for RMIT.
That's right. So in about 5 minutes, RMIT's time for the task will start. So we will need, BlueSat Rover team will need to finalize, pack up, take the rover back, celebrate amongst the team. And back to UQ Space Rover team on pitch B. There's still no motion. We did see some movement earlier. The rover seemed to have moved and stopped a few times, but so far in the past 5 or so minutes, nothing has happened. Now, UQ Space does have until 12:10 p.m. So just about 14 minutes remain for them to complete the autonomous and mapping task. Pressure inside that base station there. Could it be a communications issue? That's usually the culprit.
BlueSat heading back into the workshop there. Job well done for everyone, right on lunchtime. And actually, Shagaf, that also was the end of BlueSat's time in the Australian Rover Challenge for 2026. What a finish!
That is an incredible finish, I have to say. Such a great effort. And they'll definitely be celebrating now, enjoying the rest of the competition, the rest of what Adelaide, South Australia has to offer, and really should be so proud of themselves compared to how they performed last year versus this year. So much improvement and progress in just 12 months. Usually that's not easy to do. And you know what? It's also important to recognize and remember that these are all student teams designing and building and coming out and competing in the Australian Rover Challenge. They're all young adults looking to just build some skills, some capabilities, make some friends and do something they're really passionate about. And that is so incredible to see.
So movement back there from UQ Space. Making its way around. Looking at the controls there, I want to say that they're in non-autonomous mode. It just seems a little too human, the decision making there.
There's that live camera feed from UQ Space Rover team.
Now, the teams have to develop their own communication system, control system, and an interface that shows all of this information at once. So it's really interesting to see the different approaches the teams have. I mean, UQ have opted for one full screen, all of their streams at once, and probably having telemetry on another one. And even designing that from scratch is such a challenge. You have to have knowledge in website development, and even getting the data stream working is another whole challenge. Yeah, we can see the active control there from the team members, meaning they're probably in non-autonomous mode, so they'll be trying to do the mapping part of the task. Heading around to some coloured cubes, relaying the coordinates back to the judges as a reminder there. So they're in that 40 points phase.
There's 100 points available for this task, the mapping and autonomous task. Again, presented and sponsored by Boeing. As the time has ticked over to 12 o'clock, we are now expecting RMIT Rover team to set up and attempt the excavation and construction task. And there they are. They've picked up the rover. I believe they're about to bring it onto pitch A to start their task.
That's right, we'll have the astronauts just resetting the field out there. They'll be underway shortly.
UQ space with some movement. Not wasting any time. Making the most of the remaining 10 minutes. There's that team with the controller there in the base station. Hard at work, lots of pressure, lots of problem solving on the spot. The time crunch is real for UQ Space Rover team.
Yeah, that's right. They're just into their final 10 minutes now. 8.5 minutes remaining.
After the break, we will be seeing 3 more teams attempt the mapping and autonomous task. These teams are University of Wollongong, Legendary Rover Team, and Siri Rover Team.
That's right. You taking a pause there. Shigaf, as someone who's been to a number of these rover challenges now, how is 2026 shaping up compared to previous years?
To be honest, it has been much more exciting and much more action-packed. We've seen so much more capability coming out of these student-built and designed rovers, which has just brought so much opportunity, not just for really awesome entertainment, but just for a demonstration of the hard work and effort that has gone into these rovers. Of course, hard work and effort has gone into all the rovers in the previous years, but unfortunately, things that might go wrong in the last minute, communications dropping out, means the teams might not always get a chance to demonstrate what their rover is capable of. This year, I think we've seen mostly more demonstrations of capability of these rovers, and it has been really awesome to see. Even if they haven't been able to accumulate all the points for a particular task, just being able to demonstrate these systems, to actually put them to use and test them out on a global stage must be a good feeling after months and months of hard work and effort.
I completely agree. The bar just keeps getting raised year on year on year. I think we barely see rovers these days that are just a chassis with wheels, you know. In the years past, we'd often have teams that were debuting at the challenge that wouldn't be able to get much more together than a frame and a bunch of wires, but now we're seeing full rover systems debuting every year, and that's just really exciting to see. There's a lot of knowledge sharing that happens between the teams, and commercial off-the-shelf components are becoming more accessible, particularly in the field of robotics, and you can see the impact that that's having here at the challenge.
There's some loud cheers for the Blue Star Rover team in the workshop there. Everyone looks so, so happy. Well done to the team. Well done. What an incredible effort.
Again, where would you rather be in your Saturday than the excitement that's happening here?
If you haven't come out here yet, it's not too late.
All right, so we've got the Blue Sat team here. Amazing work again. So, you know, it all went successfully. Excavation task, nailed it. Talk us through what led to that success.
Well, I can say for sure it was through the efforts of literally everyone here. I mean, everyone has put in such hard yards over the last year, even 2 years. We've been going at this rover for, me personally, 2.5 years. And at the very least, it was a 2 a.m. sleep last night. So we've had a lot of long nights, lots of, sweat and tears. Maybe not blood, but definitely sweat and tears go into this robot. So we're all ecstatic at the performance today. It was very awesome.
Amazing. Look,
awesome.
Really great work. I think, it showed out there that how much work you had put in. The late nights, it's tough, but I bet it builds the camaraderie within the team. Yeah,
absolutely.
Something I wanted to ask about. You've got a lovely face on your scoop.
Yeah.
Tell us a bit about the inspiration behind that.
Look, I think we got to ask the artist herself about the face. This is we've got an artist over here. Look, I think it's important that everything we build must have a personality, all right? If it's going around, it's running around that rover, running around that field, that smirk, that's us. When we see that success, that's us. And at the end of the day, that's the last thing the rocks see before they get deposited. And that means something for sure.
Amazing work. Look, talking about from last year, I was talking to some of your teammates, and they were saying that a lot of this is new, right?
Absolutely.
So you've revamped a lot of it. How was that process? I'm sure that would have been quite a challenge to get everything ready on time, right?
Yeah. So our approach from last year was to make something that was really easily expandable upon. And so this rover is very much a ship of Theseus in that almost all of the chassis is reused from last year with minor changes. But then beyond that, we've got all new drive systems, fully CNC'd steering, basically everything from the chassis down was revamped, and then all of our modules, our excavator and our arm from previously, it's all brand new. And I guess that process was, not to mention the elec, oh my lord, fully rebuilt custom elec boards, everything from scratch ourselves. That process was long and grueling, but wow, has it paid off. We've had such minimal issues. I mean, on the field, you would have seen it today. Basically, everything just ran perfectly. And, you compare that to last year, we had troubles driving, we had boards blowing up on the day of comp, and it's just been a completely different experience this year. Super reliable this year. I want to give a huge shout out to Elec team. They've done an absolutely brilliant job. So many late nights, and getting all the spares ready for comp was a big thing. We've had Evan at the soldering station non-stop for probably a week and a bit at this point. I'm sure he's a bit sick of soldering for the time being, so he might get a little break before we get into upgrades for next year. But definitely a full new spirit to the rover, and it's just done so well at comp. I couldn't have asked for a better performance, to be honest. Yeah.
Look, really great work, guys. I'll leave that with you. Congrats again. Awesome. Look, I hope you guys celebrate hard. Yeah, this is well earned. Well earned. All right, back to you guys.
Awesome. Thank you so much.
Awesome to hear from the BlueSat Rover team. But back to pitch A, we currently have the RMIT Rover team has already started their task. They've successfully moved and actuated that excavator, and it looks like they might be going ahead to attempt the Paver construction subtask. Similar to some of the previous designs we've seen, attached to that excavator bit is some hooks at the end that can help with grabbing those pavers and pulling them out.
It was great to hear from BlueSat before. They have an artist in their team. We spoke a bit yesterday about the crossovers between science, technology and the arts, and how all of those skills are so invaluable to a field like space. We really need lots of different actors working together, and artists are just as important in that process. having a bit of personality to the rovers as well just really adds so much.
RMIT Rover team trying to get the precision and accuracy to attempt the Paver construction subtask. Now that it's also ticked over to 12:10 p.m. local time, unfortunately that marks the end of UQ space time for the autonomous and mapping task. So round of applause for UQ space. Incredible effort. We did see some movement from them earlier, but at the moment it does seem to be stationary. They're going to be packing that rover away soon, hopefully. We won't see another team on pitch B for the mapping and autonomous task, but rather after the break, we'll be coming back with University of Wollongong for that pitch.
That's right, and they'll be on at 2 p.m. local time. RMIT is also the final team for excavation and construction.
There's those points on the screen. As a reminder, 100 points available for this excavation and construction task, presented and sponsored by Caterpillar.
And a reminder too that Caterpillar have a tent next to the grandstand, so if you want to be part of their simulation experience that they have set up and also enter the Lego competition that they've got going, head on over and chat to the team. And that is one paver that they've managed to wiggle free from the holder there. The pavers have to start disconnected, so they weren't able to pull them out all in one go.
And for those who've just joined us on the live stream, once again, we have RMIT Rover team on pitch A at the moment, attempting the excavation and construction task. Before them came 4 Rover teams, which did an incredible job, particularly BlueSat Rover team. Rewind and watch that again. I know I will be tonight. It was an incredible effort. But after RMIT's attempt at this task, we will be going away for a break. And we will be returning at around 1:45 p.m., which marks the start for the time for Monash Rover team to complete the task, followed by UTS, QUT, Roar, and Rival. And then over on pitch B for the mapping and autonomous task, there is no current rover, but after the break, we will be having University of Wollongong, Legendary Rover team, and Siri as well. And that's the lineup that we're expecting for this afternoon. It's been an incredible action-packed morning so far. We've seen all kinds of different actions here on the pitch. So make sure to stay tuned for the afternoon and watch what happens next. And we'll have an updated leaderboard at the end of the day as well to see how today's scores, how today's performances and demonstrations have affected the leaderboard.
RMIT making their way over to what I think is going to be some regolith acquisition. Again, very different approach here, much larger wheels than other teams. We've got a thinner tread trading off for some larger spokes that would help to provide some good stability, holding the weight of the Rover chassis. Very, very big scoop mechanism at the front, but it's much further away from the main body, allowing them to do exactly what I think they're about to, positioning themselves on the edge of that crater and reaching in. And I think that's actually a camera inside the scoop.
That is incredible camera placement, very clean and flush there within the scoop itself.
A little bit of duct tape holding it together though, but again, it wouldn't be a Rover challenge without it. So we're on scoop cam in the top right-hand corner. hopefully we'll get to see it in action. We're going to watch for a minute to see if RMIT make this.
Again, this is RMIT Rover team attempting the excavation and construction task. We think they are attempting to potentially excavate some regolith, and then they need to move over to the deposit or the designated deposit area and deposit that regolith. So we're seeing some actuation on the arm there and some interesting wheel movement as well, trying to get on top of that crater.
We can hear some interesting sounds coming from the pitch. They've got a series of linear actuators, which is a device that allows, I guess, pushing and pulling of components in one line, so one direction. See, they've got a linear actuator there. They can go forwards and backwards, and another one that allows it to go up and down. So those two will have to coordinate together to allow that scooping action.
Okay, here we go.
Some movement there.
Still attempting to pick up some regolith. RMIT Rover team needs to troubleshoot and make sure they get this right. Now, while this is happening, we do have an interview lined up in the workshop tent. So we're going to throw over to Fida and see what's going on over there.
Animals Anonymous. So Queenie right here is a little quokka. Please, Emily, tell us a bit about quokkas.
Yeah, so quokkas are usually found in Western Australia. So most of them are on Rottnest Island. We're very lucky to have her in our care. She's not native to SA, but there are species of wallabies. We've got big back feet for hopping and a beautiful little pouch for our joeys.
Yeah, they're super, super cute. We were talking about the tail earlier. So tell us about what they use the tails for, because they've got a really long tail, don't they?
Yeah, their tail's really cool. So it's actually used to store fat. So in times where food's scarce or there's a drought, they can actually store up some energy in there, which is great.
Yeah, they're super, super cute. And yeah, so you work for Animals Anonymous. Please tell us a bit about what their mission is. What do you guys do?
Yeah, so at Animals Anonymous, we work with native Australian wildlife. We're very lucky to have a range of species, birds, marsupials and reptiles, and we do native wildlife education. So we travel around to different facilities and teach kids and adults alike about our animals and how they can help conserve the environment, the natural environment.
Yeah, that awesome mission, really cool animals. If you're around, come say hi, pat them a little bit. This one's definitely super, super cute, so don't miss out. I'm sure some of the overseas teams have never seen animals like these, so I think that's super, super exciting. Yeah, thanks, Emily.
Thank you so
Amazing.
much.
Back to you guys.
Thanks, Vida, for that interview. That was a very, very adorable interview, I have to say.
What a cute little quokka. And certainly we've seen the inspiration from some of those Australian native animals in the teams. The University of Wollongong's rover is called Kanga. Its marsupial rover is called Kangaroo. And of course, looking at the Australian lunar rover, it's called Rover. Of course, playing on the word kangaroo. So it's amazing to see that national spirit there.
That's right, and Rover was actually named by the Australian public themselves. So the Australian Space Agency held a public naming competition for their first ever lunar rover, and that was back in 2023. And the name that was voted by the Australian public is Rover.
It's a great name, isn't it? It seems pretty perfect. If Australia was going to build a lunar rover, we should definitely call it Rover.
Rover the Rover.
And for anyone here at Roseworthy, the teams will be able to get to chat with Animals Anonymous, who've come out for quite a number of our Australian Rover challenges ever since we opened up to international teams, and it's really a fantastic way for them to get the full Australian experience. They're already out here in the country up at Roseworthy, which is about an hour's drive from the city of Adelaide. They're amongst the gum trees and the native wildlife. They can get hands-on with them with Animals Anonymous.
Once again, we're seeing RMIT Rover team. They've just ticked over to their halfway mark. So about 20 minutes remain for them to complete the excavation and construction task. Now, we haven't seen any collection of regolith thus far, but we are seeing what looks like really good effort and incredible attempt to try and pick up some regolith to get as many points as they can in the remaining time. RMIT Rover team joined their first Australian Rover Challenge was back in 2022. So this marks 2021?
Yeah.
Oh, Georgia says 2021, and she was part of the 2021 Rover Challenge, so I will take your word for it.
Yeah, they were one of 3 debut teams. We had Monash Nova Rover, Adelaide Rover team, and RMIT. And they did take a hiatus for a year or two to redevelop their core systems. They made a fantastic comeback.
You've just joined us. Once again, RMIT Rover team is on pitch A, completing the excavation and construction task. They've been so far trying to attempt to excavate some regolith. We're not sure, but we think that an intervention may have been called. So a reminder that the teams can call an intervention, which allows them to have two-way communication with the between the field team and the base station team, and also allows them, as you can see on the screen now, to actually go onto the pitch and readjust or position the rover as required. And that's what they're doing at the moment. So it seems like they've been having a few issues with the position of the rover, and they've just now picked it up to move it over to a more convenient location for them to complete the task. Now, an intervention is allowed, but it does incur a penalty, which reduces how many points they can actually receive for this task. After RMIT concludes this task at around 12:40 p.m. local time, we'll be taking a lunch break, but don't go anywhere, because we'll be coming back at 1:45 p.m. to see Monash Rover team on pitch A, and we'll also be seeing University of Wollongong on pitch B.
Okay, now, if a quokka wasn't enough for the audience on the cuteness scale, we hear that Feeder is back with the cute little birds while RMIT tackle their intervention. We're going to cross over to you, Feeder, and your furry friend.
Looks like there's a slight technical problem. We're going to look into that and come back right to you with that bird. We really want to hear about it.
I think that might have been a tawny frogmouth. Oh, super, super cute little bird.
It did look adorable, so I really do want to hear about it. In the meantime, intervention is over and RMIT has some movement. They're now back at attempting to pick up some regolith.
It seems to have paid off for them. They got moving pretty shortly after repositioning. So they will take a bit of a penalty cut for calling that intervention, but again, this is pretty standard in the Rover Challenge and is often useful for the teams. They have made contact with the regolith. Of course, to be able to get the points, they need to then deposit it into the regolith acquisition zone, and they have to get at least 2,000 centimetres cubed to receive 5 points.
But they've picked up some regolith. This is progress. They're now moving back potentially to deposit the regolith they've picked up. Looks like they're also using the same strategy that we saw BlueSat Rover team use, which is not doing too much pivoting or turning, but rather driving forward into the side of the crater to pick up regolith and then just reversing back into the deposit zone. And there we go, a deposit made in the deposit zone, and a round of applause on the sidelines there as RMIT makes their first deposit. Still time on the clock, 15 minutes remain for RMIT Rover team.
Yeah, that's a great achievement already. Once they've made that first deposit, just like we saw with BlueSat, they're already coming back for more.
How much regolith can they pick up and deposit? Will it be enough points to make it worth their time?
We're going to watch carefully here to see if RMIT can get their next scoop in the zone, and they're so effortlessly reversing back in.
There we go. At this stage, they know what they're doing. Too easy for RMIT University Rover team. There's that second deposit they've made. Well done. Now, as RMIT gets closer and closer to the finish line for this task, we're going to throw back to Fida with the bird. We still haven't heard about that bird, so I'm really keen to hear from you, Fida.
All right, yeah, we're back again with TJ and Marley. Marley is a tawny frogmouth. So please tell us a bit about them.
So this here is a beautiful bird, really known for his camouflage. Now, even though they're quite hard to spot in the wild, they are one of the most widely distributed birds in the country. But you can definitely see why you have such a hard time in spotting him. He looks like he's made out of wood. He's very deceptive in that way, though, because he feels really, really soft. He's got beautiful soft feathers. But tawny frogmouths are an amazing animal that we have in our backyards. They pretty much clear up a lot of the rodent species that we have and a lot of the nasty insects that we're not too keen on having our backyards full of as well. So.
Yeah, it's awesome. Like even up close, I think it looks like a piece of bark. So it's very impressive how it has the ability to camouflage so well. One of the other things I noticed as you're moving it around is its head just stays still. Looks like a gyroscope almost. It's quite impressive.
Get some pretty funky dance moves out of him sometimes. He's a bit distracted at the moment. He's looking at something over there.
Yeah, and we were just talking about how, they have this look, makes them look quite big and ominous in some ways, but they're actually very light and agile. So, a lot of it is feathers and bones. So I guess it's like maybe an intimidation thing that they do.
Yeah, they do get a bit of a bad name because they've got that permanent grumpy face, but they don't really mean to be. They're used to living in conditions that are a lot lower light than right now, so that's why he's a little bit squinty. At night time, he will open those eyes really big and wide, and he can take in a lot of those low light conditions a heck of a lot better than we can. So he's definitely situated to that nocturnal lifestyle.
Yeah, really, really cool. Thanks for sharing.
No worries.
We'll throw it back to you.
Amazing. More native Australian wildlife there. And speaking about that sort of gyroscopic movement that Peter mentioned, we've seen a few bio-inspired systems here at the Australian Rover Challenge, and certainly we've had some cameras doing much of the same movement, that sort of periscope action, to be able to get a 360-degree view of their surroundings. So it's interesting how that is used in wildlife as well.
Absolutely. And, biomimicry has had such a huge impact on engineering and technology that we use every day, and that we use to explore space as well. We've looked at wildlife for inspiration, and it's become such a huge field to look at the way that, you know, the way the whales swim in the ocean, look at the way the birds fly, even look at the way that forest animals leap and walk, and that's helped us in innovating technology and having a bigger impact.
That's right, it's more than just humans that we've looked to. I know that there are a number of robots that are being developed that have a very humanoid-like appearance, but we saw the other day that UNSW brought along a robotic dog, and that had limbs that were able to move with such high degrees of freedom. It looked so realistic for something that was just metallic wires and electronics.
Absolutely, and it's these kinds of robotics and rovers that have that high degree of freedom that can actually come really in handy when it comes to establishing a presence on another planet or on the moon, having humans and robots work side by side, but also having these robots with such high capability is really critical. Now, RMIT University Melbourne is on a roll at the moment, currently picking up regolith and dropping it. They've done this already a fair few times, 9 minutes on the clock, and they're just getting as much regolith as they possibly can with the time left.
Yeah, they're definitely getting into the groove now. They've got a similar system to what Blue Side did, just sort of driving into that crater ridge, scooping and depositing. Now, this is the excavation and construction task, and you might be thinking to yourself, well, how can we actually use this lunar regolith for construction? You know, it looks like sand, it's very finely grained. What can we do with that? The materials that the lunar regolith, at least those top layers, are made up of is extremely diverse, and actually includes some metal oxides. And there's research that's being conducted into how this can be used to make lunar bricks. Some of this research has actually been done at Adelaide University. We can use laser sintering as well on the top layers of the lunar regolith and potentially create paths out of that as well. So it's a very, very versatile material, and of course we saw over the last 2 days when you get frozen ice-cemented regolith, you can potentially extract water from that as well. So you can see how it really leads the way to being able to establish a continuous human presence if you've got all of those things necessary to sustain life. Within water, we've got hydrogen and oxygen. With the lunar soil, we've got the ability to generate lunar bricks or other ways of creating habitats that don't require bringing those resources from Earth. And that's really the key to these missions, is we want to use what's available. We don't want to be bringing anything from Earth.
That's right, and that's what we call in-situ resource utilisation. And here in Adelaide, there's a lot of research being done into that, like you mentioned, Georgia. Adelaide University actually houses the Andy Thomas Centre for Space Resources, and a really big focus for them is looking into how we can utilise space resources on the moon or beyond without having to launch so much material from Earth to be able to do the things that we want to do. And speaking of in-situ resources utilisation, the Australian lunar rover that's currently being built, Rover, its purpose is actually going to be extracting oxygen from the lunar regolith. And this is quite critical, not only because oxygen is great for us to breathe in as we try to establish a long-term human presence, but also can be used as fuel.
That's right. if you're launching from the moon to head on to a planet like Mars, the delta V requirements are much lower to do that path than to take the journey from Earth. You're not battling an atmosphere, first of all, and also the gravity is 1/6 of what it is on Earth, so it's much easier to overcome those gravitational forces and escape the moon's orbit and head on a pathway to Mars. And we can see there up on the screen, it appears RMIT have had a communications dropout, something that has been a bit of a theme this challenge, highlighting the complexities of using a radio frequency system over Wi-Fi. So we're hearing from the judges that the team has 3D printed the gearboxes. You might be able to see them in orange, sort of in the back there. And they've unfortunately worn out. So that rover is no longer moving like they hoped it would. So that actually calls time on RMIT's attempt for the excavation and construction task. They've pushed their rover to the limit. You can see still the cheers there from the team. You know, they still got the job done. They were able to deposit the regolith. They were able to pull out some pavers. They should be really happy with that. And I'm sure they'll take the learnings of the 3D printed gearboxes there for use for next year.
That's right, as they pack up and get ready to set that rover back down in the workshop. And the round of applause out here on the pitch. What an incredible effort from RMIT. Even with those that issue with the gearboxes, it was only about 5 minutes left. So they did make most of the time that they could make most of. They did deposit some regolith. They troubleshooted. They called an intervention earlier, but they got things working, and it has been so good to see that action. And what an action-packed morning once again. Ever since the start of the morning, we've seen rover team after rover team come out, demonstrate incredible teamwork, incredible effort to get the rovers working to complete both the excavation and the construction task, as well as the autonomous and mapping task.
And that's right, and with the end of RMIT's run for the morning, that means we're on lunch break now. So thank you very much for joining us for the start of day 3 of the Australian Rover Challenge. And remember, do not go anywhere, keep that live stream up, and we will be back live at 1:45 p.m. local time. Thanks for coming out today, and we'll see you back shortly.
What if the next space race took off from our state? What if Whyalla powered the world with clean green hydrogen? What if 2 of the state's leading universities came together to create a global university for the future? Welcome to Adelaide University, a defining mark in our state's story of firsts.
is a nation of creators, aviators, protectors and innovators. From aviation's first light to the dawn of the jet age and beyond, at Boeing, we're building the future together here in Australia. Inspiring those in pursuit of new frontiers, connecting, protecting and exploring our region and the world. Home to the broadest aerospace portfolio in Australian industry, powered by talented, dedicated and diverse teammates. Delivering manufacturing excellence, building composite aircraft parts for the world's most efficient airplanes, using advanced robotics, materials and digital technologies. Never compromising on safety or quality, always focused on sustainability. Solving tomorrow's problems today with Australia's leading researchers, scientists and universities. Developing new military platforms and communications networks and helping ensure they are always mission ready. Keeping customers airborne by providing the services they require. We stand shoulder to shoulder with Australians during natural disasters, on the front line and in peacetime. We support veterans and our community, and we nurture the next generation of aviators to excite, to be bold. Boeing Australia. Made in Australia by Australians for the world.
change is the only constant. The question is, who is leading it and why? Because purpose is everything. It's the bold ambition needed to take on the multi-generational challenges before us. It's the creation of a contemporary and accessible education ecosystem to drive greater social cohesion and prosperity. It's reimagining partnered research of focus at scale to become an engine for growth. Adelaide University is Australia's new university for the future, designed to empower individuals to be the best they can be. With more than 180 years of collective experience and achievement, Adelaide University will leverage the capabilities and resources of its foundation institutions to launch bright futures and breakthroughs. We're transforming teaching and learning by co-designing degrees with future employers. Our students will be equipped with an entrepreneurial mindset and will be ready to take on an AI world. Ethical leaders who do what is right over what is easy. Adelaide University is establishing South Australia as a centre for progress and innovation. As a group of 8 university, we're combining the investment and infrastructure needed to accelerate future-making research that is nation-critical and globally relevant across defence and national security, creative and culture, food, agriculture and wine, personal and societal health, and sustainable green transition. From society to seas to space, we're partnering with industry, communities and regions to create impact that transcends borders and time. As an exemplar for excellence and equity, we bring together the esteemed and enterprising to prepare a diverse next-generation workforce that's adaptable and ready to respond to an ever-evolving world. To provide a nation-leading student experience that unlocks individual potential and passions. To connect an inspiring global community of over 400,000 alumni. To contribute an estimated $4.7 billion a year to our national economy. And to deliver value across the full chain, from research translation to commercialisation. Adelaide University is a force for positive change. Together, we'll shape what's next for a better Australia and a better world. Change is the only constant. The question is, who is leading it and why? Because purpose is everything. It's the bold ambition needed to take on the multi-generational challenges before us. It's the creation of a contemporary and accessible education ecosystem to drive greater social cohesion and prosperity. It's reimagining partnered research of focus at scale to become an engine for growth. Adelaide University is Australia's new university for the future, designed to empower individuals to be the best they can be. With more than 180 years of collective experience and achievement, Adelaide University will leverage the capabilities and resources of its foundation institutions to launch bright futures and breakthroughs. We're transforming teaching and learning by co-designing degrees with future employers. Our students will be equipped with an entrepreneurial mindset and will be ready to take on an AI world. Ethical leaders who do what is right over what is easy. Adelaide University is establishing South Australia as a centre for progress and innovation. As a group of 8 university, we're combining the investment and infrastructure needed to accelerate future-making research that is nation-critical and globally relevant across defence and national security, creative and culture, food, agriculture and wine, personal and societal health, and sustainable green transition. From society to seas to space. We're partnering with industry, communities and regions to create impact that transcends borders and time. As an exemplar for excellence and equity, we bring together the esteemed and enterprising to prepare a diverse next-generation workforce that's adaptable and ready to respond to an ever-evolving world. To provide a nation-leading student experience that unlocks individual potential and passions. To connect an inspiring global community of over 400,000 alumni. To contribute an estimated $4.7 billion a year to our national economy. And to deliver value across the full chain, from research translation to commercialisation. Adelaide University is a force for positive change. Together, we'll shape what's next for a better Australia and a better world.
Australia is a nation of creators, aviators, protectors and innovators. From aviation's first light to the dawn of the jet age and beyond, at Boeing, we're building the future together here in Australia. Inspiring those in pursuit of new frontiers, connecting, protecting and exploring our region and the world. Home to the broadest aerospace portfolio in Australian industry, powered by talented, dedicated and diverse teammates. Delivering manufacturing excellence, building composite aircraft parts for the world's most efficient airplanes, using advanced robotics, materials and digital technologies. Never compromising on safety or quality, always focused on sustainability. Solving tomorrow's problems today. with Australia's leading researchers, scientists and universities, developing new military platforms and communications networks, and helping ensure they are always mission ready. Keeping customers airborne by providing the services they require. We stand shoulder to shoulder with Australians during natural disasters, on the front line and in peacetime. We support veterans and our community, and we nurture the next generation of aviators to excite, to be bold. Boeing Australia. Made in Australia by Australians for the world.
space race took off from our state? What if Whyalla powered the world with clean, green hydrogen? What if two of the state's leading universities came together to create a global university for the future? Welcome to Adelaide University, a defining mark in our state's story of firsts.
big welcome back to the afternoon session of Day 3 of the Australian Rover Challenge 2026. We're coming to you live from Roseworthy Campus, part of Adelaide University here in South Australia, Australia. Now, before we get started with the teams on the pitch for excavation, construction and mapping and autonomy, we have some footage here from an event that took place last night inside the Exteriors Crater Lab, also part of the testing facility here out of Roseworthy.
Yep. So this one here is meant to be an example of the lunar what is it called?
Lunabotics.
Lunabotics, that's it.
We've got a Lunabotics-like environment here, and that is a competition that's held in the US, and it focuses on the excavation part, really, of the excavation and construction tasks that we've seen throughout the day. So it gives teams a chance to test out the rovers in another lunar-like environment. It pretty well replicates that challenge, so it's great for them to have this opportunity to test their rovers. So what we're going to see for the next couple of minutes is a time lapse of the teams who nominated to test their rovers in this facility just after yesterday. So this is hot off the press, this footage.
And as you can see, they move much quicker through these challenges here. Focus around these is a lot more about being a good construction-related equipment rather than the more careful challenges that we have in the Rover Challenge. So it's just about getting dirt from one place to another as quick as possible.
Exactly, they're focusing just on one task here. So the aim is to take the lunar regolith from an excavation zone and dump it into a berm construction zone. And the team is trying to get the highest volume of material in the berm zone as possible. So very similar to what we saw today in the excavation and construction task. And you might have noticed here that this lunar regolith looks quite different to what we saw outside. Now, the aim of the Exteriors Crater Lab, the regolith in here, is to simulate accurate lighting conditions, mimicking what you would see on the lunar south pole. Now, when Miss Horoko Asakura was here earlier in the morning, she spoke about how the lunar south pole is a real area of interest for future missions to the moon. We think that there is ice-cemented regolith inside the permanently shadowed regions on the South Pole. Now, permanently shadowed regions, or PSRs, are basically craters, and they're permanently shadowed because of the lighting conditions on the moon. They never see the sunlight reflecting inside the crater, so they're permanently in the shadow. And what that means is because they're not receiving any sunlight inside, they get to very, very cold conditions, allowing the regolith to freeze over. And that's where we think that water will be located inside the frozen regolith. So again, you might be thinking, what other tasks have we seen this week where teams have had to extract frozen regolith? And that's another reason why we have that space resources task.
Yeah, it's a big area of interest at the moment, this shadowed areas and trying to get things like water out of them. So definitely a cool challenge. And I think being able to model after a challenge like the Lunabotics, I think is a great opportunity for teams to test their mettle and see how they can fare against a challenge like that.
Yeah, that's exactly right. And something that was quite cool last year was the Australian team from the Australian Rover Challenge who was able to excavate the most amount of regolith. Some cheers there as Monash Nova Rover gets ready for excavation and construction. But last year, so the top performing Australian team in the excavation and construction task here at the Australian Rover Challenge were invited to give a demonstration in Florida in the United States as part of the Lunabotics Challenge last year. So they also got to do a similar task to this, and they did a fantastic job. That was Queensland University of Technology who were invited, and they were able to undertake this excavation task all the way over in the US.
Yeah, so you can see the pedigree we bring to these tournaments, some really high quality engineering work that goes on. So yeah, if any of the teams are interested, definitely sign up and give this challenge a go.
Yeah, it's another great way to test their rovers, really. Going between the two different environments, outdoors versus indoors. You know, the environment outside of the Rover Challenge is very much focused on recreating the feel of the lunar terrain and having those topology differences, while this indoors one is a bit more focused on having accurate lighting conditions. It's a different coarseness to the grain, different colours, and this facility is used for testing real-life rovers as well, just like the outdoors one. So that's also incredibly exciting for teams to be going in such a similar environment.
Yeah, I find it quite interesting that we have so many different kinds of simulants to show different aspects of lunar environments. Some are focused more around the actual feel and the traversal side. Some are more on the lighting, and each of them have to be sourced differently. And yeah, it's quite interesting that way.
Yeah, you make a really great point there. The lunar regolith is a tricky beast. So the moon itself has been impacted by micrometeorites and bits of debris over millions of years, and it's resulted in quite a complex composition on the surface. It's full of sort of glass shards, sulfur and a volcanic rock, iron. And that composition means that it's pretty hard to recreate with just one type of simulant. It's also electrostatic, so if you disturb the sort of top layers of the regolith, it will rise about 1 to 2 meters in the air and then attract itself to any kind of potential difference that there is. And usually, if you've got a rover on the lunar surface, it will be your rover components that dust will get stuck in.
I guess that's why there's such a big emphasis on excavation and civil construction rover equipment, so that we can build over that initial surface, so that future vehicles and things like that can actually traverse without constantly having to worry about maintenance and, you know, every part being damaged.
Absolutely right. And of course, if you're able to sort of calm down that electrostatic nature, like we were saying earlier, there might be ways that we can use laser sintering to create pathways on the lunar surface and avoid disturbing that dust, then that will really improve the effectiveness and the success of future operations on the lunar surface. Quite cool to watch the teams in this time lapse here. They've all had pretty good success getting that regolith into the collection zone.
You can see there's some rocks around the edges, so you have to be quite careful with how you get around, but I'm guessing if you get a good path, you can kind of rinse and repeat that path pretty well.
Yeah, just like what we saw this morning when teams get in the rhythm with their control system there, the dual control required of their chosen scoop mechanism and the drive controls. URT, of course, is the team we see on the live stream here, or the highlights video here. They're incredibly successful this morning in excavation and construction.
Yeah, I was talking to them earlier, actually, and they're talking about their unique suspension, which was quite fascinating. So they're one of the unique teams that built their own full suspension system.
Ah, did they? Yeah. That's super cool. And so that was the end of our highlights from that event in the Exteriors Cradle Lab. Very cool to see teams being able to access so many different facilities here at Roseworthy. It's all part of research done by the Andy Thomas Centre for Space Resources, which is part of Adelaide University. If we look at on the pictures, we can see Monash have set up their Paver bay. So teams were able to have the pavers either as a separate payload or on board their rover as part of the excavation and construction task. So far today, I think we've seen every single team has had an external paver bay. Probably reduce the complexity of not having to have that on board their rover.
Yeah, there's definitely an element of modularity to consider. You know, these things, they have to chop and change based on the task. And I think definitely makes it a big difference when you can take a part off and put it back on very quickly and easily. Definitely talking to the other teams this morning, it sounded like having things easily accessible and easy to take on and off was a big factor in getting everything ready in time and not have to fidget with it for too long, you know.
And I think that's something that teams have learned actually over the years of the Rover Challenge too, because I know certainly when we started, we did not have modular payload bays. So if anything went wrong, we were just taking off the top layer of the chassis, and then it was a mess inside. You were just working through cable soup. And I remember one year, you know, we had just 1 or 2 CAN wires come loose from the CAN bus. We can hear Monash Nova over there cheering as their team comes out onto the track. We had 1 or 2 wires come loose, and that completely made us lose communications with our drive system. So it's really important to consider that modularity.
That's it. Yeah, it's just makes life so much easier. Fixing one part doesn't mean everything has to be turned off, or, you know, not everything will go wrong just because one thing breaks.
Exactly. So you can see there, they've just lowered their antenna mast. The teams are required to stay within a pretty hard dimension limit, volume of about 1.6 meters cubed. And so they're lowering that mast to stay within the required dimensions before the challenge begins.
I really love this rover. The pink color is such a stunning, it really stands out from the rest of them.
Yeah, it's pretty fantastic as well. And Monash Nova Rover get pretty heavily involved in STEM outreach.
That's it.
And there we go, we see that mast come up. They are ready to begin. Yeah, and the pink rover is all part of their STEM outreach program, which is great to see as well from the teams.
Yeah, it's great that, you know, they're doing this for a good cause.
Seems we've got yet another scoop design from Monash Nova Rover. We've got an open top scoop. We saw from Deakin University just before the break. They went for a bit of a clamshell design. And I think what we see in the back might be a Paver actuation system. Looks like a bit of a forklift. Heading slowly but surely over for the Paver construction part of the task. Teams are able to complete the subtasks of excavation and construction in any order. I like that they've got some themed tiles here as well.
So it's all getting it nice and aligned before you go for it. You don't want to be off center. They lined up the one axis first and now moving across to the center of the payload.
Yeah, that's something quite cool we've seen from the teams today, is making use of translational drive, like forward and backwards, and then also strafing, sort of going sideways in that crab-like drive mode. It's really helped them to be efficient with aligning things like this.
Yeah, teams definitely say that strafing ability makes such a difference.
Yeah, I can just imagine, because otherwise you would have to completely rotate around and move 90 degrees.
Worrying about one axis at a time definitely saves them having to think about too many things at once.
Yeah, we actually spoke yesterday about the cognitive overload that you can experience in the base station if you don't separate your systems like that. And particularly here, you know, they've got the scoop system, they've got this forklift, the front, the drive. Those are all systems that need to be operated by a human in the base station. That already alone is quite complex. You can see there, just the cable soup they've got on that table.
Yeah, you definitely want to separate a separation of your concerns, make everything as simple and straightforward as possible. And this starts from the initial design steps, you know, and this is why system design is so important from the beginning, having a good plan on how you're going to separate everything.
Yeah, and speaking about a plan, usually in the base station, the team splits in two. You've got your technical operators and then the sort of strategists who are directing the technical operators, so they don't have to bear so much of that brunt of decision making if they are trained on a job, and then they can have the operators telling them, like, you know, we're going to abandon this task and start on something else.
Yeah, so much communication. I think it's so important to have clear messaging throughout the whole team. Otherwise, yeah, it's so easy to misconstrue what's going on.
Yeah, and I mean, we've seen this in space missions in real life as well, where sometimes a miscommunication. There was a famous example where a crash landing happened on Mars because, you know, one team was working in Imperial units and the other team was working in SI units. So that can have a huge effect on a mission. So you want to avoid that as much as possible.
Slow and steady, but definitely making good progress right here.
See the base station team discussing in there where they might be headed to next.
The strategist, as you said.
Indeed. So with the Paver system, they're required to cover an area of 1.1 metres squared. The pavers have to start disconnected, and then the idea is that one by one you pick up a paver and place it in sequence. They must be attached, like connected together, but it doesn't necessarily have to be one straight line. It's interesting to see the approach here. They've carried this payload quite a way from where it was initially placed by the team. And quite a lot of precision will be required if they do get around to taking the pavers out of that bay. They consider connected if there is a light tug on any paver.
So they've just placed it down now.
Now, the maximum allowable gap between the edges of any two connected pavers cannot exceed 1 centimetre. That's quite a lot of precision required here, and they have to be contiguous.
Very small margins here to work with.
The teams can also choose to cover any area of the challenge arena in any shape with their pavers, so it's still a little bit curious as to why they carried it so far.
You can see it slowly sliding out from the bottom there.
Oh, I think it's all right.
I think we should
All right?
protect it
Yeah.
anyway. Oh, I should have put it through.
Go over the wire or?
The team is now 10 minutes into their attempt of the excavation and construction task, which means that in just 5 minutes' time, University of Wollongong will be competing in the mapping and autonomy task. Right on cue, they've come out onto pitch B. They'll get started just shortly.
They were a really good team, actually. Last year, I think they scored the second most points for this challenge, so
Wow.
definitely watch out for them.
Yeah, they want to watch. In feeder, we also saw the appearance of Roo again from the University of Wollongong, their marsupial rover. It's very, very cute.
Yes, yes. They like to have a bit of fun. It's really cute to see.
Monash are making their way over to, it looks like that debris zone. So one of the other parts of this task is that the rover is required to clear debris from an area. Imagining a situation where you would be undergoing site preparation before you start constructing your lunar habitat.
It's been interesting to see what sort of controllers people use to operate their rovers. You can see they've got the joysticks, I guess.
Yeah, I think this is one of my favourite control systems I've seen from the teams. It's pretty industrial.
You see things from people using PlayStation controllers to keyboards to, proper joysticks as well.
Yeah, you always know it's quite challenging when a team is furiously typing command line. It means that something's probably gone wrong with one of their more handheld controllers. The last thing you want is to be manually typing in the coordinates of how much you want to step forwards or backwards.
Definitely not.
You can map that all to a button input instead.
Looks like they've switched to a controller now.
Yeah, I think you're right. I wonder if that's going to actuate the scoop. Nice colour coordinated controller there too.
Yes. Yeah, you forget sometimes how many different systems are just in one rover, all working together.
Yeah, that's right. And this particular task is definitely one of the most demanding for that. The post-landing task, that's usually teams opt for a robotic arm because you need that manipulation on the processing plant, the modular hose connection. But for excavation and construction, there's already two major tasks in the title. The construction requires precision and manipulation of the rocks. The excavation side requires, the most amount of volume per unit time. And then the paver placement, that's yet another added complexity. And we saw that teams actually opted to try and combine all three with their scoop by having hooks on the end, which could then grapple onto a handle to begin their paver placement. But Monash have opted for two separate payloads here.
It always goes back to that modularity. How easily can you move things along, and whether it is optimal to maybe have two separate parts or have one part do everything.
Yeah, and also just trying to reduce the overall mass of your rover as well, because teams are awarded for efficiency. There's a new efficiency multiplier this year for having something that's more compact and lightweight.
I'm going to go for another attempt at that blue rock again.
I don't know about you, Feeder, but looking at that scoop from side on, it kind of reminds me of a dog.
Does a little bit, doesn't it?
I don't know if anyone's a fan of Doctor Who, but it kind of looks exactly like Canine.
I haven't watched too much Doctor Who, unfortunately.
Well, I think for me it's that I assume that's a camera on the top there that looks like a little ear.
Definitely.
I wonder if this is on purpose, especially because of that transparent perspex that's on top. I like it. Great view of all of the different rocks there. 8 cameras in total. Really great for the team's situational awareness.
There you go, successful.
That would be Monash's first catch of the day. But a of course, to receive the points, they've got to deposit it into that specified zone, which they're making their way over to now.
It's always impressive seeing this rotation motion where they sync all the tyres together.
Yeah, that synchronization wouldn't be easy, would it? I don't have as much experience in the encoders as I do with some of the other subsystems.
Someone definitely sat on their computer for hours getting that right.
Amazing job there from Monash. This year's rover is called Banksia. They have a theme of naming their rovers after native Australian flowers. Some of their previous ones include the name Waratah. And they've also competed internationally as well. They've been part of the University Rover Challenge held in Utah over in the United States.
It's actually quite interesting. I was talking to the team earlier today, and their rover is actually one of the bigger ones out of all the teams, and that is because, I think they just dropped it. Oh, that's unfortunate. But as I was saying, they had the same rover for the two tournaments, and the requirements are slightly different.
Ah, I see.
So for this tournament, the size and weight have multipliers, which they don't at the University Rover Challenge. So, the limitations of designing one rover for two tournaments.
Yeah, that is quite difficult, isn't it? And from memory, the University Rover Challenge is nothing like the Australian Rover Challenge, and covers some longer distances rather than more complexity in tasks like this. So certainly designing something for both would be a bit of a challenge. So we saw just before, they almost lost the rock, but managed to recollect it.
Now just about getting it back to the deposit site.
Wonder if they're trying to go for a second rock there. I think they might be.
2 for 1.
Efficiency is key. Time is, of course, money, especially in space operations. Careful manoeuvring required there, and it seems they've got the 2 rocks.
That was some clever last-minute thinking to get both rocks in one go.
That's right. Monash, of course, are, at least when we last checked this morning, they were leading the competition, so they are the ones to beat.
Yep, I think the last update, Legendary was just above them.
Oh, interesting.
Yeah, but they are the leading Australian team, which is great to see. I think Legendary is meant to be on later today as well, which will be interesting.
Yeah, that's right. They'll be coming up at 2:45 p.m. local time on the Mapping and Autonomous task.
They're one of our overseas team from Poland?
Yeah, that's right.
That's another successful deposit. Looks a lot more relaxed in the base station now.
Yeah, very cool, calm and collected. Something that's needed during high pressure situations. It's definitely something that they look for in astronauts is, can you keep your cool when you're handling multiple different tasks at once?
I'm sure many of these guys here would love to be an astronaut someday.
I have a feeling you might be right. It's interesting to see their approach. Some teams have opted for speed with their rover. Monash seem to have opted for precision today. So while we're watching the deliberation here from Monash, we're going to head over to the workshop where Shagaf has been roving around, and she's got an interview lined up with Adelaide Rover team. Shagaf, how are you going?
All right, we're here with the Adelaide Rover team. So I've got with me one of the project lead of the team. So introduce your name and tell us a little bit about your role.
Sure. So yeah, my name is Kunal Kaur. I'm the project director of the Adelaide Rover team. And at the moment, as you can see behind me, the team is currently working really hard to set ourselves up for the Lunar Robotics Challenge tonight, as well as for the excavation and construction task tomorrow.
Awesome. So you guys have one more task to complete tomorrow. How's the preparation going? Take us a little bit behind the scenes.
Sure. So I think we can step a little bit in and have a look. So at the moment, the team's working hard just to wire up the scoop itself. So we've kind of had to downsize this year, even though it is quite a big scoop. Some teams have mentioned it is kind of like a shovel, but it will be much more efficient, I assure you. But yeah, they're just finally wiring up the motor controllers to our main system here, and then we'll be doing a lot more testing tonight outside, and hopefully we'll see the bad boy go during the Lunar Robotics Challenge.
That sounds awesome. And we were talking earlier about the kind of team sportsmanship and team culture that we're seeing at the challenge today. Can you talk a little bit about that as well?
Yeah, of course. So I guess this cycle, we've been all about the vibes, right? We got music pumping, everyone smiling, cheering on, and of course, with the Kazakhstani team just out there, we've been sharing food. Like, they've given us a bit of chocolate, we've given them some of our cans, just sharing food, having fun, laughing, and on top of that, just vibing out with like QUT, Roar, UQ Space, helping them out, them giving us a slab of Tim Tams, as well as all the other teams like RMIT, Deakin, Swinburne. It's been great.
That sounds amazing. And remind us, what time are you on tomorrow so people don't miss it?
So tomorrow we'll be at 1:45. So see us there.
1:45. You heard it here first. Adelaide Rover team. Back to you guys.
Thank you, Shagaf and Adelaide Rover team. It's so nice to see the sharing of food, keeping everyone sustained back there in the workshop. These are long, long days. The workshop site opens early in the morning and shuts definitely after sundown, and teams are here from the crack of dawn to the very end of the day. Now, we've called an intervention with Monash Nova Rover. Just before we cut to Shagaf, the back right wheel stopped working, so it was sort of dragging itself along as the rover tried to get out of the collection zone here. So we've sent our astronauts, we've deployed them onto the lunar surface to do some repairs. As you can see, they've opened up the two-way communication there, speaking over the walkie-talkie. Now they're going to be doing some problem solving on the fly here. Base station team waiting patiently. And it's actually the base station that has to call the intervention, so that can sometimes be tough because the field team can obviously see quite easily what's going on with the rover, particularly if it's a hardware issue. But the base station might not, especially depending on the placement of their cameras, if they even have any camera feeds. Sometimes in the past they haven't realised, that there's an issue because they can't see the problem.
Really just shows the difficulties of doing a lunar-like challenge or any sort of separation where all you have is the sensors you put on your system, and sometimes that might not even be enough. You need to have some intuition, and the 360 view of seeing something in person sometimes makes a big difference as well.
Yeah, you make a really good point there about intuition. You know, cameras give you a visual indication of what's going on, but if you can't see everything, you might be relying on other telemetry coming through. Maybe it's power levels, maybe it's the percentage applied to the different wheels of your drive system to know whether it's stuck on a rock, for example.
Yeah, things like this, testing is so critical. You gotta know what problems can come so that during the challenge itself, you know that when you get those patterns, that means, you know, your wheel's stuck or whatever else it may be.
Yeah, and it's really hard to simulate these kinds of issues as well. Like, you can do stress testing on different terrain, you can drive over rocks, you can do long-range testing of the communication systems, but there's always going to be something a little unexpected when you're on a competition-ready environment like this. A lot of the teams take their rovers to the beach. We've got another friendly pet here. I want to say that's a python. Another Australian animal.
Yes, this is your cue. If you're not a big fan of snakes, look away.
I'm going to show my international friends this. They always ask me about the animals in Australia, whether they're dangerous or not. I say, you know.
We get a bad rep, I think.
Yeah, I think we do. Australia's very safe. You can see right here, the animal's anonymous instructor is holding that snake.
It seems super friendly.
Yeah, just saying hello to our Rover team members there.
I always thought they'd feel more rough, but they're actually quite smooth.
Oh, really? Did you get to say hello to this snake earlier?
Not today, but they were actually here last year and got to pet them. I'll definitely be making my way around and saying hi to them at some point.
Yeah, it's been great to have Animals Anonymous here the last few iterations of the Rover Challenge. Really bringing the best of Australia here for our international teams.
Yeah, I think the Indonesian team was quite excited to see some of the new animals they've never seen before.
And there's a strong chance too, being how up at Roseworthy, they may just come across kangaroos in the wild as well.
Yeah, definitely. It doesn't help the stigma of us riding kangaroos to school.
That's true. They could be here on campus, so it would actually make a lot of sense.
So it looks like the repairs are still ongoing. They might be detaching that wheel at the moment.
Yeah, now this is quite interesting. It's very much like a car, isn't it? They've got a jack there that they're using to prop up the rover and remove the wheel. I really like that. Oh, and it seems they're clearing out. They're running off, so...
All right. It seems to be all back to functional order.
Yeah. We're going to find out if they've got that right wheel working again.
So it's now up to the base station to start the task again from here?
Yeah, that's right. And in the meantime, University of Wollongong is still waiting. They're about 15 minutes into their run for mapping and autonomy, so still plenty of time remaining. They haven't yet left the start gate.
That's the tricky thing with software. You never know what part is causing issues.
As a software engineer, have you had struggles with this type of thing before?
Oh, definitely. I think debugging is one of the most challenging and the critical parts of software engineering. You got to know where and when problems arise, and that's half the skill. You know, writing code definitely is important, but with AI is coming through more and more these days, that's not really what is the defining characteristic. I think the main thing is when something does go wrong, you know where to look and you can find it quickly.
I was actually going to ask you about that, how AI has affected your daily job, but I guess you just answered it. So you still need that human intuition there with the debugging. Like, if the AI doesn't know exactly the implementation of your code, you know it's just writing something that you've told it to do. That makes sense that that's still important.
Yes, that's exactly right. it's become even more important with AI. You know, in the past it was still important because debugging is a day-to-day thing in software and even hardware. But yeah, with AI slop, as some people call it, we do have to be more aware of what it is writing out and being actually able to intuitively understand what we want out of our software.
Yeah, that makes sense. You still need a very good grasp of coding to be able to understand whether it's what you want. It's Monash. Seems like they've successfully done a tyre repair. Great job from the team.
It's great to see that synchronized rotation back at it.
Yeah, it's very smooth, isn't it? Something they've perfected over many, many years of rover development. It's getting close to a decade for Monash Nova Rover. They are definitely one of the veteran teams here, not just for the Australian Rover Challenge, but also for their time in the University Rover Challenge. Great for some of the younger teams to learn from as well. I know certainly when I was in the Adelaide Rover team and it was some of our early years, we learnt a lot from the way that Monash designed theirs. Particularly on the software side, that's something that's really, really complicated when you're just starting out.
Yeah, designing control systems for things like this is a big challenge, especially when there's so many systems involved. I was talking to some of the teams and they're talking about how software is one of the last things that they approached because of the fact that all the hardware has to be working before people can write the software. All the design decisions have to be made about every other part before you write the software part. So usually they're on tighter deadlines and people just say, oh, it's just a couple of lines of code, right? But it's a little bit more complicated than that.
Yeah, that's super interesting how the timelines just get blown out because if the hardware gets delayed or like you said, they haven't even made decisions on what it's going to look like yet. Also the interfacing there with the types of microcontrollers or other computers you're using, they would all have their unique challenges to go. And a lot of the teams use ROS. Do you have any experience with ROS?
A little bit. I think a lot of when we were doing our honours projects and things like that, a lot of our teams were using ROS. So ROS is the robotic operating system, essentially a really easy way to program robotic functions. But yeah, I'm sure a lot of the teams are very familiar with it and have to use it for day-to-day functions.
Yeah, ROS is something that's pretty critical to a lot of these systems functioning, but especially if you're an undergraduate, it's something that's either taught in specialised courses right at the end of your degree, or for some people, not at all. So
it's actually something, you really don't come across unless you go out of your way looking for it, which is unfortunate, but it's good, like challenges like this force you to learn about these things that within industry is actually quite common.
Yeah, it's amazing how prevalent ROS is. It comes up all the time, especially in space companies, of course. And it's great that they get that experience here.
I can see them pulling out the bottom pallet there.
Yeah. Look at that interlocking system that they've got.
Yeah. Oh. Just as we were talking
not
about quite. All right. Looks like they're going for another go at it. See if they can lower it enough to latch on.
Some team rallying going on there.
It is quite low, that bottom pallet, so it's going to be tricky to get the actual latch mechanism low enough to hook back on.
Yeah, you could kind of see the intention behind the design though when they pulled out that first tile, how as the other ones sort of stacked down, they then latched onto each other with the 3D printed interlocking part. That was pretty interesting. I don't think I've seen something like that before.
Yeah, it's quite creative.
I have a feeling they've abandoned that, so they're sort of sampling all of the tasks today, aren't they? A little bit of the pavers, a little bit of the rocks. Are they going to finish off with some regolith? I have a feeling they are.
Yeah, when you are on a time crunch, you just got to make the most of that time, right? So something's not working for too long. Someone has to make that decision eventually of, hey, maybe let's move on to something else now.
Yeah, that's exactly right. So we've heard from the judges that as part of the strategy for the team in the base station, they actually had a flowchart for what to do in case something goes wrong. And it went down to the granularity of a case, like one of our wheels has failed, this is what we're going to do next. So they're not just picking randomly what task to complete. There's actually a specified scenario for the situation, and that really mimics real life. We know from human or crewed missions like Artemis 2, which is coming up, they have these backup scenarios for every possible combination you could imagine of something going wrong. And the teams have to work in the simulator to recover from the situations or play them out.
It really shows the planning that goes behind, and really great planning from the Monash team here to have contingency plans on contingency plans just in case something does happen. And yeah, all of it is intentional and purposeful so that, again, they make the most out of that time, the slot that they have. I think, like we can see on the screen now, there's just about 2.5 minutes left now for them to wrap the task up.
Yeah, the time has really flown by quickly, hasn't it?
Yeah, it's quite tough, and having to do repairs and things in between. They really got to be as efficient as possible with every task.
There they go, the final 2 minutes on the clock. Maybe they can go for a second scoop, but this could be the one and only.
And that's one done. Like you were saying before, Georgia, their team is more focused around that precision rather than speed, so this will be a tricky challenge, but I'm sure they've got another contingency in place to handle this.
That's right. 1 minute 30 remaining. Are they going to get that final scoop? Getting ready, positioning it. Nice use of those dual joysticks there.
We're running dash strips right now. We say lower front bucket.
Just trying to get to that optimal position to get as much dirt in as possible.
Yeah, there's a bit of a trade-off here because if they want the points, they need 2,000 centimetres cubed in volume.
Just under a minute now, making their way back. Should be able to get that deposited.
Yeah, assuming nothing goes wrong now, they'll be making a dash for the finish line.
Here they go, last 20 seconds.
Just making it. 5 seconds to go. Well done, Monash Nova Rover.
Made use of every second there.
Sure, there would have been a big adrenaline rush in the base station there, getting that just in the nick of time.
Great work, team, coordinating under pressure like that. It's always tough when there's a clock right next to you counting down the seconds.
Yeah, and hearing us in the commentary booth.
Yeah, we probably don't help.
Monash will be back for mapping and autonomy first thing tomorrow morning at 9:15 on the dot, and that will conclude their run at the 2026 Australian Rover Challenge. If you're just joining us, we've seen our first two teams compete in the afternoon block with plenty more to come. So we've heard that Shagaf has got an interview lined up with the University of New South Wales, Canberra, and we're going to cross to you live now, Shagaf.
All right, I'm here with UNSW Canberra Rover team, two of their team members. So tell me your names and what your roles are.
So I'm Quinn, I'm the science team lead.
I'm Akshat, I'm the software team lead.
Awesome, and we've seen such an intense performance from you guys this morning at the autonomous and mapping task. We saw movement, but then we saw abrupt stopping, and it was just so suspenseful. Can you tell us, behind the scenes, what was going on? What was happening?
So we had a bit of issue trying to set it up at the beginning, but once we got that up, the autonomous part was working all fine, but the little rocks and the hills kind of threw the Z drift off. So where the rover thought it was compared to where it was on the ground was off a bit. And so it kind of just ran straight into a rock, which it couldn't clear. So we had to stop the autonomous and go manual control. But after that, it was all fine. And we just had to manually map the whole area. And just after that, it was all pretty good.
Awesome. Well, I'm so glad you guys got to recover and got to have some points. Now, tomorrow you've got your final task, the excavation and construction task. What are you doing to prepare for that?
So I'm driving it, so basically getting a lot of good reps in, using the scoop outside to pick up stuff. Yeah, just kind of seeing camera angles and what works best for being able to see the scoop and stuff like that. Yeah, just a lot of drills running it through.
Awesome. And what time, remind me, are you guys on tomorrow for the excavation and construction task?
That is a great question.
That's quite disappointing, I would say. Well, looks like you just have to tune into the live stream all day to find out when UNSW Canberra is going to be completing the excavation and construction task. And that's it from us. Back to you guys.
Alrighty, well, hopefully RAS UNSW checks their timetable for tomorrow. They don't want to miss their chance to do excavation and construction. We can tell them that they are on at 12 p.m. tomorrow. And in the meantime, we've got Wollongong on the move. This is their main rover, Kanga.
It looks like they are doing the autonomous task at the moment.
Yeah, we were debating here in the commentary box. We have a feeling they're in autonomy mode just because of the precision of the movements of the rover. The way it sort of seems to drive forward, stop, turn, and then drive again. We could be wrong. Yes, so that's hands off in the base station. This is definitely autonomous. You can see, how it gets to sort of the edge of the field and then it stops and rotates.
Yeah, it seems they've figured out their bug and got it running, which is great to see.
Yeah, that's fantastic. And like you were saying, they were really strong in the autonomy section last year, so I'm sure they'll be keen to make a mark on this task again.
Yeah, so you can see what the computer can see there.
Yeah, it's quite cool, isn't it? So basically the autonomous system is trying to go to these waymarks, those funky looking symbols on the field there.
That doesn't look so good. I think we might have gotten mistuck.
Yeah, I'm sure the base station team is getting a good view of this at the moment. Yep, and they've called an intervention to stop that.
So I was talking to the University of Wollongong team. They're talking about their autonomous system is based on state machines. So the way state machines basically work is that you have various states with different functions. So there could be like a maneuver state, there could be a stop state, a spin state, and each of them get triggered by certain events. So that's a great way to create autonomy without needing to have a full ML model or neural network. You just write algorithms that run on different conditional statements.
Okay, and it's interesting to see the teams implementing things like that. Looking at a Wollongong, I think they had to hit the E-stop on the rover. We're just going to have a look. Because if that E-stop is hit, that would mark the end of their attempt at the task. But they are taking it back to the start gate, so potentially... No, I can see the stop has been reset there, so they're going to have a go of the non-autonomous part of the task.
That is really unfortunate. It only takes one small edge case for the whole thing to go haywire.
Yeah, so what is an edge case for people who might not be familiar?
So when you're writing any sort of software, you try to consider for anything that could happen, but usually there's a few major possible scenarios that you write the code for, and there's millions of probabilities. There might be so many variables at play, and if there's one specific scenario with very specific conditions that are met, that's usually what we call an edge case. And you can try your best to test out every edge case, but there can be so many, and it sounds like this is one of those really rare cases where something the team maybe hadn't fully considered, maybe the way the camera was looking, it can be the climate today, it is a bit more overcast.
Yeah,
things
the
like
lighting
that.
conditions.
Everything like that can play a factor.
Yeah, it's really interesting because we also had a similar issue this morning where one of the teams got stuck. I'm pretty sure it was UNSW got stuck on a rock because of the object detection there didn't quite go as planned. And over here on excavation and construction, we have our next team. This is University of Technology Sydney, the Rocky the Rover. Now this is already phenomenal because Rocky the Rover did not get off and away yesterday. They also had issues the day before. So it's amazing to see that they've not only gotten away out of the start gate, but they've got a brand new payload and they've collected a rock.
Yeah, it's very interesting. Their payload system, it's almost like a scoop with a clamp at the top and the regular sort of scooping mechanism at the bottom.
Yeah, you can see how this is taking inspiration from a traditional digger design that we would use for terrestrial construction.
It's hanging on just by a thread right there.
They're really not messing around, are they? They are taking that risk, heading over to the collection zone there. And the really impressive thing about this rover is that it has active suspension. I'm pretty sure this is something that the team tried out last year as well. So we will hopefully be able to see this in action when they deposit the rock. Active suspension is very cool because it means they have linear actuators connecting the chassis to the drive system, and that's what allows it to be able to translate up and down.
There you go. They
Nice.
managed to get that fully deposited, even though it's hanging on just by a thread.
First rock in. You can get a nice look there. So you can see the linear actuators attached to the chassis.
Yeah, suspension on a terrain like this is so critical. There's so many different ups and downs you got to traverse through.
Yeah, over the years we've seen many a rover get bogged in the lunar regolith. And so active suspension is a nice way to be able to overcome that issue. Got University of Wollongong here. They are on the move again. I have a feeling that spinning thing at the top there might be LiDAR.
Yes, I believe they were talking about LiDAR sensors when I spoke with them. I think that's part of their mapping task.
LiDAR being laser infrared ranging and detection, something like that.
Yeah, close enough.
Detection and ranging.
But yeah, the basic idea behind LiDAR is depth detection. So it allows you to understand how far things are from the rover. Definitely a critical tool when you're trying to do things like mapping.
Yeah, and because it's not using a camera in the visible spectrum, that makes LiDAR an optimal choice for challenging lighting conditions. And also nighttime operations.
All right, here we go for another. That's a big one.
Wow, nice job from Rocky the Rover. Really impressive stuff from this team. They had some issues yesterday, and it's so clear that they've overcome those challenges overnight.
Yeah, this team really loves to live by the edge here.
Yeah, quite literally. Wow, oh my gosh. That was a centimetre too far back. That would have been a disaster. I think that looks like plastic perspex on the top there with those claws.
Yeah, and good thing they're shaped like hooks. That's probably what kept those rocks from falling out while they were moving it.
Yeah, definitely agree. You can see how that's going to be quite useful for excavation later on, because they can flip that claw sort of right back around to make it clear for picking up all of the regolith.
Looks like we're lining up for that blue rock now. Front wheel's completely off the ground here.
There it goes. The stepper motors.
You can see that active suspension in action right there.
Yeah, that was glorious. Such a robust system they've got here. Huge concentration there in the base station. They would be really trying to maximise points today. They just wiggle, 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 and that rock has come free.
Solid work from the team there.
They're doing this in really record timing as well.
Yeah, that top perspex definitely makes a big difference. Once it's in, it's not falling out.
Yeah, I completely agree. And it also means that they can filter out the regolith as well. That can shake free to leave just the rock behind. Just like that.
Just like that.
I love the personality of these rovers.
Yeah, it's been great to see all the teams bring such a liveliness to their rovers. Definitely makes each one have a unique character. Oh.
Yeah, I agree. This is so much like a claw machine, isn't it?
Yeah, if you've played those before, you know how hard they are. But I'm sure these guys have designed it so that it's as easy as possible to grab these rocks.
Now we have just 1 minute on the clock for the University of Wollongong. Actually, less than that. We're counting down the last 35 seconds. They've jumped into... That looks like it might be the non-autonomous mode. So they'll be trying to go around to the coloured cubes, like what you can see in the background there, reporting the coordinates back to the base station. But the extra challenge is that the coordinates have to be relative to the rover's starting position, meaning that they have to, I guess, set an origin point or a ground truth at the very beginning and then map the coordinates relative to that. And there's time up for University of Wollongong. It's a fantastic effort by the team there, demonstrating their autonomous system. Even that getting in place is fantastic. You can see they're really happy there.
You see they were doing a little celebratory spin with their rover there.
I'll give it another go to Mara, of course.
One of the fascinating things you might have noticed in that rotation was that you don't necessarily need to turn the wheels to turn. You can actually change the amount of power you drive the various wheels to get the rover to turn around as well. So it just shows how many different ways you can skin the cat.
University of Wollongong will be back up tomorrow at 9 a.m. for excavation and construction. Plenty to learn from today's attempt. Still a really great display of their autonomous system. Next up on the pitch will be legendary Rover team at 2:45 p.m. local time.
Yeah, watch out for them. They're leading the leaderboard at the moment. So.
Yeah, that's right. The current front runners. Rocky the Rover is just crushing this debris clearing challenge. Again, such a far cry from yesterday. But they didn't even get much around the pitch.
Just shows the hours these guys put in between each session. I'm sure there's a lot of late nights they pull.
Yeah, 100%. I know I've heard a few people mention the words 2 a.m. in our interviews today.
It's a normal bedtime, it seems like, during these tournaments.
That's right. Here we go. You can see the confidence in their operations.
Maybe a bit too confident.
A little bit too much there on the confidence.
But great work, nonetheless, depositing another rock. It's been a solid set of rocks there now.
Yeah. It's interesting too, you can see they've sort of got this pulley system on the left-hand side to be able to rotate that claw all the way back around.
Mm.
I imagine that provides a bit of stability as well in that top part of the frame.
Yeah, definitely would be something to do with weight distribution, not to have the motor directly connected to that part.
Yeah, that makes a lot of sense. There we go, the big chunky rock there for some chunky points. Yeah, real appreciation for the complexity of this task. They're kind of relying entirely on that bottom left camera to know where they are and whether they've collected the rock or not.
Amazing work again.
Yeah, brilliant work from Rocky the Rover.
It's definitely one of the more quicker moving rovers, for sure.
Yeah.
There you go, that shimmy again.
Let's get rid of all that sand and on to the next task. Now, back to pitch B. Just under 1 minute remaining before they start. Oh, nope, time has now started for legendary Rover team over on pitch B. As our leading team, I'm assuming they're going to make an autonomous attempt first this morning. You can see they've got a bit of a depth sensing camera on the front there. So they'll be setting things up, and then when they call the start time, it will be hands off the controls.
Let's hope it's only just setting things up and not making any last-minute changes there.
Yeah, hopefully not merging any branches.
Let's hope not.
And Vida, this is your first day out at the 2026 Rover Challenge. How have you found the atmosphere? You know, you spent the morning in the workshop, and what was that like walking around and visiting the teams?
It's really great. You know, these guys are super clever, super smart, really nice to talk to. It's always exciting to go see what these guys get up to. And yeah, this year's group is amazing. You know, they've been coming up with crazy ideas. The problem solving, especially on the fly, you know, something goes wrong, they have to figure it out on the spot. It's quite impressive to see how quickly they can figure things out and how every single team member is so well across the whole system and are able to make decisions so quickly. Yeah, I love coming down. It's so awesome. And just getting talked to other engineering students and seeing their aspirations and ideas. Something that's really unique is that a lot of them talk about these skills that they gain from the Rover Challenge that they don't get out of normal university courses. So that's always really cool to see that they are getting invaluable knowledge from doing a project like this. And not just that, like learning to work in a team, interdisciplinary team, learning to plan a year-long project, as well as the camaraderie and making lifelong friends. Some of these guys, they've all said that these guys are my closest friends now, which is really great to hear.
That's fantastic stuff. And speaking of success, UTS have just deposited their first batch of regolith in the regolith acquisition zone. Amazing effort by the team. It's so nice to hear the friendships that form out of these teams as well, you know. It is a high-pressure environment, it's a long development cycle, but it's great that there's so much shared passion here. And that extends across the teams as well, who seem to all hang out with each other in their spare time after the competition.
Yeah, it's super important. I think even just to work well as a team, you need to have some level of understanding of each other, and that helps you so much more, being more productive, understanding what each other are trying to do. So it's great to see everyone getting along and making an attempt not only within their teams, but talking to other teams as well. Because at the end of the day, this challenge is about collaboration, right?
Yeah, I couldn't agree more. Amazing stuff from Rocky. Over on pitch B, we have movement from University legendary Rover team.
I'm not too sure, but they seem a little stuck.
Yeah, so you can see the edges of the start gate there. They've just made it out. Yeah, hands off in the base station, so they'll be watching this autonomous attempt.
Sometimes you just needed to trigger one specific case and things fly into motion, like we were talking about edge cases earlier.
The Rover's a little bit nervous, please. I'm not ready to leave yet.
Yeah, I think the team's waiting to see if there is any opportunity to get some more movement here. It is tricky to maneuver in sandy conditions, you know, compared to tarmac or anything like that.
It's incredibly hard, and I think it was Rival who was saying earlier, they just didn't have any terrain that was similar enough for them to test on. A lot of the teams, they do like to go down to the beach to test their Rover, but, you know, if that's not exactly close to you, then you might have to stick with grass. Or tarmac, as you said. Whoop. Wow, isn't that impressive?
Wow.
So this is completely autonomous. They were just able to get themselves out of that situation.
And this is what I was talking about earlier. Sometimes you just need some condition to be met, and then the system will go into a new state, and maybe the torque will increase or something like that. That to get it out of that situation there.
Interesting. So maybe it detected that one of the wheels was moving by itself for too long or something like that.
Yeah, there's so many conditions you can set. You can set it based on time. Say if a wheel hasn't moved for a certain amount of time, or if only one of them is moving. Things like that are usually some determinants used to change states and things like that.
You had some nice visuals there from the legendary Rover. The two eyes.
You can see fully hands-off on the base station there, letting the computer do its thing. And you can see
check
there.
that out. So it's identified that waypoint.
Mm-hmm. So you can do things like computer vision as one possible way to identify things, essentially just training in a model to recognize images, training it through showing it lots of data, usually labeled data, saying this is what a station looks like, and you send 1,000 of them and it eventually understands, right, this is what a station is.
That's really interesting. And these look like very unique symbols that has to be able to identify too. That sort of black and white pattern looks a little bit like a QR code, I guess.
Yeah.
Is that deliberate, do you think, to make it easier for the rover to identify that it's so distinct?
Definitely. That's a big part of how, like QR codes in general, was that they're easily identifiable for computers. And that's, I'm guessing, a big part of why these signs look kind of like QR codes, is for a computer's eye, it's a much easier target to see.
And something that's quite cool too is these types of symbols are actually stuck on the outside of spacecraft like the ISS to help with autonomous rendezvous and docking in orbit. So that's a pretty cool application of what the teams are doing down here on the rover pitch. It's actually used to help spacecraft align. It's an intense task for a human to be able to do otherwise.
Just shows how a lot of these challenges are modeled after real-life operations and missions that people in space actually have to do.
Meanwhile, over on pitch A, Rocky the rover is going for its life, heading towards the regolith acquisition zone and back. The team has just had incredible success this afternoon.
They've really smashed this one, haven't they?
Yeah, they really have. And they were only 23 minutes into their time as well, out of a total 40 minutes. There's a total of 30 points up for grabs for this particular section of the task, so it's definitely worth them investing the time into. 5 points are awarded for depositing at least 2,000 centimetres cubed, and then up to an additional 25 points awarded for depositing larger quantities. And this is a function of the largest quantity deposited by any team.
Yeah, this is very impressive. They look like they're battling one of the bollards at the moment.
Do you think they're up for a game of javelin this afternoon? I think he said, I'm a bit tired of this whole regolith acquisition thing. Let me just see if I can throw this pole as far as I can.
Really
maybe to go jousting with the legendary rover. They might have to maneuver themselves a little bit to get free of that. Now, this would be an edge case that I don't think the team would have quite considered.
Oh, 100%. I think this is the con, I guess, of having hook Perspex on top of the scoop. Yeah. There's always, with any design choice, there's trade-offs you make, and I guess this trade-off was not something they had envisioned.
It's pretty unfortunate that it's the exact diameter of the pole.
Mm.
It's really not made it easy for them.
It's coming along for the ride.
Okay, we better watch out here in the commentary booth. That rover is coming straight for us. Have they got it? No.
Almost.
Gosh. There we go. Great job from Rocky the rover there. A bit of excitement. Some really great creative problem solving there. I'm sure that is the last thing that they expected to see happen to their rover after all the other challenges they've had this week.
This is exactly that on-the-fly problem solving that we were talking about earlier.
That's right. They wasted no time getting free of that.
Just a quick side quest.
Exactly.
And they've still got plenty of time to get this through. You can see that shimmy again to get all the dirt off.
Yeah, it's an incredibly responsive system, isn't it, to be able to switch those two wheels so quickly.
I'm guessing they must have mapped that already to a movement. They just press a button and it does the whole shimmy motion. Can't imagine they would have to rapidly press directional buttons to get it to shimmy like that.
Yeah, that's a good insight because that would be quite tricky to do just with the thumb or pressing a button. It does appear to seem like the same movement each time too.
Yeah, I'm sure that's part of like reducing the complexity of the whole system as a whole, is to create very similar motions, map them all to one button, so then you just know that that movement happens when you press the button. There you go, there's that shimmy once again.
Super effective scooping work here. It's great that they also have a camera inside their scoop. Make sure that they know that they've deposited a rock or some regolith.
And that's quite unique, I think, from the other teams.
Looks like they've even got a spirit level there on the top of their scoop.
Yeah.
I think that's something that I haven't seen before.
I think that's more with like building it rather than using it on the mission itself, since it'd be quite hard to see from the camera.
Yeah. Now, while Rocky the Rover heads into its final stretch, we're going to throw back to Shagaf in the workshop, who's got an interview with RMIT.
Task today and then tomorrow. All right, so I'm here with the team from, remind me who you are again?
RMIT Rover team.
RMIT Rover team. So, what are your names and what do you do on the team?
So I'm Shabazz. I'm the team lead of the RMIT Rover team.
I'm Kalen. I'm the systems engineering lead of RMIT Rover team.
Wonderful. Those are really high roles in the team, so you guys must have a lot of responsibility. Now, today you attempted the excavation and construction task. How do you feel about that? How did it go?
Honestly, I was happy with it. We were dealing with some control issues the day before, the first 2 days. Most of them were sorted out, so we were able to actually attempt the task and do what we were hoping to do today, which was pretty good.
Look, the excavation task is a very, very taxing task to do with the rover. It puts a lot of weight on the front. There's a lot of mass you have to move. Our rover did actually manage to handle this very, very well. There were some issues with the gearboxes, but we made these gearboxes ourselves, so we were kind of expecting that this might be an issue. We have brought spares. We're putting new ones on right now so that we'll be able to run for autonomy tomorrow.
Amazing. Now, you were telling me earlier that you've completely redesigned your rover from the one that you used last year. In fact, you said that you actually, from just after the last year's competition, you got working to design a completely new rover. What was the motivation behind this? Why did you feel like you needed a completely new design?
We actually have built this entire thing in 7 months. The reason for the new design was because the previous design had many issues, and we are actually a pretty fresh team. The entire team sort of cycled over at the end of last year. So we figured instead of trying to figure out and then improve something old, we might as well just make something new. And we have a very capable team, so we were confident that we could do it. Now all that's left is just improving this one for next year.
With the release of the new rules as well, we have a lot of improvements with our efficiency over a lot of the other teams. They are running legacy systems which have a lot of machined aluminium, whereas we have had the opportunity to try stuff like carbon fibre and composite materials.
Yeah. Amazing. Well done, guys. Well, this looks awesome. And tomorrow you're on for the last task, the autonomous and mapping task. What time was that?
It is at 2 p.m. tomorrow, so look out for that.
Yeah, 2 p.m. RMIT University here. They're climbing the leaderboard. They're doing so well this year. Fresh design. So be there tomorrow to tune in. Back to you guys.
Well, thanks to Shagaf. Amazing that, RMIT have had to come back completely from scratch, and they've really made great headways into the challenge this year. They'll be finishing off with mapping and autonomy at about 2 o'clock tomorrow, so you can tune in to see their run then. Now we're back to legendary Rover team. Peter, I think this is still an autonomous attempt from what it looks like.
I think so too. Yeah, look at that. Hands. Oh, actually.
Oh, no.
The hands are on the controller there.
Just very precise movement from the team, actually. So they will be heading around to the coloured cubes, reporting back their location.
It's been interesting to see the different design of wheels people have taken for this challenge.
Yeah, and I think Legendary in particular have quite a unique design there. You can see those gearboxes are really nice and neat in the white boxes. And then the wheel axle is quite a unique geometry as well. Sort of that U bracket shape, C bracket. Means that the wires are all very free. So when it rotates around, they're not going to snap.
And again, all of that is designed to traverse this sort of terrain with a lot of loose material. You need spaces for rocks and other regoliths to move around.
Yeah, and they've really taken off. They had quite a large robotic arm, which has been removed. Obviously trying to go for the efficiency multiplier points by just keeping their rover to the absolute core system, which is just the autonomous payload.
Yeah, and just another advantage of that modular design philosophy. Talking to a lot of the teams, it's been quite interesting to see how much 3D printing gets done with a lot of these projects. It really shows how much that sort of technology helps with that rapid prototyping process.
Yeah, I completely agree with that. I remember back in 2021 when we first competed, I was like astounded when I saw that Monash had bought their own 3D printers over from Victoria, and I thought, how on earth did you disassemble that and reset that up again in your workshop? But of course, now that has become incredibly accessible, even just over the last 5 years, we see basically every team has their own 3D printer out in the workshop. And there are some that have their own enclosures now, which controls the temperature of the print and also the vibrations, allowing really stable, smooth prints.
Yeah, it's really great. You don't have to have every single spare part ready to go. You can print stuff out on the fly. If something breaks, you can print it off straight away. And yeah, like you said, they've become more accessible and more portable as well. They're much smaller these days, much quicker as well. You can get stuff printed that used to take a couple of hours in minutes now.
Yeah, I completely agree with that. And the wheels is one of the parts that benefits a lot from that. When we first started 3D printing our wheels, they would take days to print, and the chance of failure was pretty high because we were dealing with a material called TPU, or thermoplastic polyurethane, which is a material that's kind of like rubber, and it is deformable in the axis where you're in contact with the regoliths. So you can see here, as the legendary rover comes around, the bottom of the wheel is ever so slightly compressed, allowing good surface traction, while I guess the sort of axis that's 90 degrees to that is really strong, where they've got that sort of lotus shape, and that allows structural rigidity as it moves along.
Yeah, and I'm sure that more hollow structure of the wheel allows for that compression and giving more surface area at the bottom.
Yeah, that's exactly right. And when you do printing with that material, the temperature has to be really tightly controlled because it's sort of that rubbery texture. It's a bit harder to print than the harder plastic. So the enclosure hobby level printers have really helped with that printing process.
It's another synchronized rotation there.
Back over at pitch A, Rocky the Rover is still going on the excavation and construction task.
There's a big mound now.
They're heading into their final 3 to 4 minutes of the task today.
This is, I would say, a big success for the team.
Huge success. They're all watching very closely out here on the field, and you can see that they've just really become comfortable. Check out that active suspension there as it steadies itself. It looks so human, doesn't it, when it has that active suspension? It's sort of, bending the knees to be able to steady itself, to get the sand. It's just like what we would do if we were trying to lift a heavy object. But they've really become comfortable with this process, back and forth from the acquisition zone to the regolith.
And that's a massive mound now.
Yeah, they've just really nailed that shaking action there. Of course, only the regolith within those poles will be counted, so they want to make sure that as that mound grows, they don't actually end up outside the zone.
I wonder how they'll judge that with one of the cones missing.
Now, after this run, we'll be already halfway through the excavation and construction teams in the afternoon. UTS will be followed by QUT Raw and Rival. And I'm really interested to see how QUT is going to go, because obviously the excavation part of this task is one of their strong suits when they had the opportunity to demonstrate at Lunabotics last year. So I'm sure they've been looking forward to going through this task today. Legendary are just heading into the halfway point for their task in mapping on autonomy now.
It seems like they have some very precise controls they're placing on there.
Yeah, I definitely agree. They've really, apart from that hiccup that they had earlier, they've really recovered from that early end to the autonomous phase.
Thumbs up. Everything is all good.
So they would be doing probably some careful coordinates gathering now.
As you can see here, these guys have opted for an Xbox controller as their main controlling mechanism, so it just shows that, commercial off-the-shelf products are something that you do have used a lot, especially to save costs and material limitations and things like that.
Yeah, definitely. And again, that's something that's only been available in the last handful of years. Particularly on the gaming controller side, I feel like previously joysticks were what you had to default to, which were a bit harder to map.
Yeah, commercial controllers didn't used to be as easily programmable, so it's definitely come a long way, especially integrating with ROS, as we were talking about earlier. It looks like they're wrapped up. UTS is finished now.
Yeah, that looks like time up for Rocky the Rover. Fantastic work from the team there. Really, really fantastic job on excavation instruction. It can't be understated, actually, how much they've improved from yesterday. Just a massive comeback.
Yeah, really amazing work. It just shows, some days are worse than others, and you just have to pick yourself up and get ready for the next day, and you might have a really successful day just like today.
That's exactly right. And you can see here under the hood of the Rover, they're doing a power level reading there, all part of the new efficiency multiplier for this year.
You can just see the wire jungle that goes underneath a Rover, the amount of cables and systems they have to connect together for this one Rover to move around. It's very impressive.
Yeah, like you were saying about the modularity before, cable management is another really big aspect of these Rovers. If you've got a tangle of wires, it's going to be really impossible to do problem solving on the fly. From one Rover to the next, in goes UTS, and out comes QT. Now, this one will be quite exciting, Feeder, because yesterday I saw, I think one of the team members is holding it, a marsupial rover or a scout rover to go alongside their primary rover.
Oh, yes, a mini rover, you could almost say.
Exactly, a mini rover. They're required to start as a singular system, and then the miniature rover can get deployed at some point during the task. So I have a feeling we're going to see that. It was zooming around the workshop yesterday. So I'm very keen to see that in action. You can see there, UTS, lots of happy faces there in the workshop. Legendary still traversing around the surface there.
Looks so calm and collected.
Yeah, I think that's been the theme of this afternoon so far. Cool, calm and collected. UTS just so effortlessly getting rid of that jousting moment that they had back there.
Yeah, I think that's a big part of space missions, right? Having a cool, calm, collected attitude. There's so many things going on, especially under pressure in high danger scenarios. You got to have people who can stay nice and calm and make sound decisions.
That's right, and they undergo so much training as well to be really well prepared for the tasks, not only in space but also what they're doing here as well. All of the teams usually elect a base station operator, a robotic arm specialist or a payload specialist, and they'll focus on just controlling that one aspect for quite a length of time before the challenge. You can see that computer vision at work there.
You can see how this one is saying ID2, so it's able to identify each of the different QR-like codes as different entities, which is quite clever.
It's just trying to get over that crater ridge, isn't it? I think I can.
There we go.
And it's into the crater.
So a task like this, you just need the one main operator, right, for the motion. There's no excavation, there's no arm required to maneuver. So all you really need is someone to drive the actual wheels.
Yeah, that's right. And the coordinates that they report they have to get with an accuracy of about 300 millimetres, so 30 centimetres. That's not much in the grand scheme of things when you consider how big this field is.
Something like a depth sensor definitely comes into handy when you're trying to do that sort of stuff. Seems like something's gone on. Team doesn't look as happy as before.
So after the autonomous task, teams are also required to give a presentation. This is based on the data collected by the rover during the task. So they'll have to address their design and justifications of the autonomous landmark navigation. Also talking about the advantages and the limitations of the design. Then they also have to talk about a discussion of the choice of an autonomous or a non-autonomous system, the navigation component that they used, and also the details and visualizations of the map that they've collected of the arena. So it's really great that the teams will have to justify their design thinking. It's really mimicking what you would have in real life. When you do these systems engineering design reviews, you often have to present to your fellow teammates and also a panel of experts. Usually they give you a good grilling on your design justifications, and that can be quite stressful, but it's also a nice opportunity to take a step back and go, well, okay, how did we end up in this position? You know, what trade-offs did we make? Have we missed anything in the process to selecting this design?
Yeah, systems like this are so complex. It's hard for one person to think of everything. It's a great opportunity for everyone to share their knowledge, what they know, put their own input out there. Yeah, for systems as complex as this, it really helps doing those design reviews, following good systems engineering principles. That's part of the product pipeline, you know, and especially when you want to build things quickly, it's really important to have things really planned out.
TUT, we're all waiting in the wings there. We're coming on any minute now.
So where is this mini rover that you spoke of? Is that hidden in there somewhere?
Yeah, so you can see it attached just underneath the chassis.
Ah, yes.
See there's two wheels poking out.
Ah, yes, yes, yes. I wonder...
I was going to say they've also opted for an external Paver system, which you can see one of the team members holding. So, I mean, so far we haven't seen a single team with an onboard Paver placement system, and this would be a breakaway from previous years where we usually had a little bit of a mix of both. I imagine the efficiency multipliers probably come into effect here with these decisions.
Yeah, that would make a lot of sense. I feel like it is a lot more efficient to have that separate. Yeah, I wonder what design and systems engineering went behind making a mini rover.
Yeah, the teams would have to be really confident in their core system if they wanted to then take on the challenge of developing another rover.
I'm sure the coolness factor had some play in that.
I know it certainly would for me. Legendary are in the final 5 minutes of their attempt of the mapping and autonomous task as well.
I think they may be a bit stuck there.
Yeah, it seems like they haven't moved on from that second waymark, have they? Oh, that's so cute. Is that a team mascot, I think? I'd feel pretty cool, calm and collected if I had him cheering me on in the base station.
We all need a rubber ducky here and there, you know.
Yeah, well, speaking of that, I think last year University of Wollongong had a duck on the side of their rover, so they have featured in the competition before.
Sometimes little distractions like that are great for having eureka moments, something you
Oh, the
to help you
mascot's
take your mind
taking
off things.
control of the rover. Giving us the sign that they've potentially packed it in. And they'll be preparing now for the presentation that they're giving shortly afterwards.
Looks like the mini rover is out of the big rover now for the excavation task.
Oh my gosh, that's really cute.
There it is.
I wish I knew the name of the mini rover. Maybe we can get Shagaf to chat with the team when they finish their run.
Definitely.
Okay, the name of the mini rover is Kibisis. Be great to find out where that name has come from.
We need the origin story.
Because of course their main rover is called Perseus, which I think was the same as last year, so it's probably a strong hint that they've kept a lot of the same core systems, and that's not a very nice way to treat your friend. Got dropped off and then kicked over.
You know, in the animal kingdom, there are some animals that leave their kids off to fend for themselves. Maybe this is one of those cases.
Yeah, it's a bit of a dog-eat-dog world out here on the track. Well, I hope they can go back to retrieve it. I feel awful. Stuck in the worst possible place on its side.
It's like a turtle upside down.
Okay, so we've got word from the commentary team that Kibisis is the knapsack used by Medusa to put Perseus's head in. That's
So Medusa's head, Perseus uses it to put Medusa's head into the knapsack.
That's some really intricate naming that from the team. That's certainly not something that I would have known off the top of my head.
Very well thought out.
Very nice mythology reference there.
Yeah, Greek mythology seems to be a very popular naming convention in a lot of scientific machines and things like that.
Yeah, that's very true. I mean, of course, we have the Artemis missions being the sister of Apollo in Greek mythology. It's definitely been a running theme.
Exactly right. I think a lot of these scientists are Greek nerds underneath.
And also, they've lifted the hood of the legendary rover, so that signalled the end of their run, and they'll be doing the power reading there. Great job from Legendary.
So it looks like they're note-taking everything that went down, likely for that presentation that you were speaking about earlier.
Yeah, they'll be getting all of their notes together to deliver that not too long afterwards. And we see some interesting dance moves going on in Pitch A from Kibisis. This is quite innovative. Wow! Oh, look at that!
That's incredible.
Oh, we missed it on the cameras, but Kibisis was twirling itself around, gaining some angular momentum there. That was very clever from the base station team. I wonder if they'd tested that beforehand, if they'd put it on its side, whether it was able to tip itself over. And sure enough, that's exactly what happened.
I was just about to say, well, I wonder if that's part of their decision trio of possible scenarios that could have happened.
That's right. But it's off and away. Now, it's interesting, they seem to have taken a design that's pretty similar to a payload from JAXA's slim lunar lander called SORA-Q. And that was a tiny payload developed by a toy company, actually. And it had a tail not too dissimilar to that it gave it stability for its two wheels to navigate through the lunar regolith.
It's very similar to how a kangaroo would use its tail to sort of stabilise itself as well.
Yeah, that's very true, actually. So dragging itself along at the end there. Yeah, you can see the way they're able to flip it around to go through the terrain. I'm sure whoever's driving that, though, would get a bit motion sick every time that camera rotates around 180 degrees. I like the GoPro on one of the base station team's heads. Yeah, you can see the drive system there where one wheel goes forward, the other one goes backwards, so it can kind of like a shimmy itself along in the sand.
Yeah, there'd be definitely some control systems designed around how that payload moves around so that it can balance itself as it moves.
Yeah, because it's quite an interesting point you make about how it's able to so freely flip that tail from one side to the other.
Yeah, control systems is all about controlling the movement of any piece, so coming from a voltage or torque amount, how you figure out, okay, I want it to exactly go here or move in this profile. The same thing we use in aircraft, actually. So think of a fighter jet. That needs to move quick and fast. It doesn't matter if it's a bit jerky versus a commercial plane, which can go nice and smooth, but it doesn't have to go to that exact angle straight away, but as long as it's not too jerky, it's fine.
Yeah, it's interesting. So while QUT are deliberating there, we're going to jump back to Shigar from the workshop who's got an interview with UTS and their phenomenal run with Rocky the Rover.
Hey everyone, I'm here with University Technology Sydney. So, we're going to speak to two of the lovely team members. Tell me your names and your role, please.
So I'm Fergus Hudson, I'm the team lead.
And I'm Liam Hogarth, I'm part of the Thomas team.
Wonderful. So, you just attempted the excavation and construction task out there. How do you feel? It looked like an awesome performance.
Yeah, it was really good. We sort of intentionally didn't do the pavers, so we spent a lot of time excavating. The rock grabber, our little rock scoop worked really, really well. So we're really, really happy, yeah. It's fantastic. We've had a few comms issues in the first couple of days, so it's fantastic to show our efforts sort of off to the competition. Yeah.
And well done. You guys all should be really, really proud of yourselves, and you look really happy, and we're happy for you. Now, tomorrow is your last task. It's the autonomous and mapping task. How do we feel? Are we prepared?
Oh, we're feeling all right. We're a bit of in a back foot now. Unfortunately, we weren't as prepared coming into this, so we're going to really scrounge something together. But we're confident we can get something working with some cube detections going well, some AR tags. We're really kind of looking at an all right place, I reckon.
Amazing. And remind me, how many years have you guys been competing in the Australian Rover Challenge? Do you know? Since 2022? Okay, so a solid 4 years now. Well done. You guys have done an amazing job. Once again, congratulations, and you should definitely be proud of yourselves. We'll see you tomorrow, 10 a.m. They'll be on the pitch for the autonomous and mapping task. Back to you.
Oh, it's fantastic to see the perseverance from Rocky the Rover there. They were saying they'd had a few communications issues throughout the week and now they're back, and hopefully this gives them a really good platform to build on to come back for mapping and autonomy tomorrow and really finish on a high here at the Australian Rover Challenge.
Yes, I'm sure you learn a lot from each and every single day, and there's learnings you can take across each thing. Even we were just talking about understanding the RF frequency knowledge, having to figure out comms is not something that might be forefront of your mind when you're doing a rover challenge, so it's something that I'm sure teams are a lot more aware of now.
Yeah, that's right. And speaking of problems, it seems like QUT-RAW have called an intervention. Just sort of checking the status of their main rover Perseus there. Is this also a communications dropout we've experienced? Seems like we've lost the little rover and the big rover.
Yeah, I wonder what the communication between the two rovers and how that works as well.
Yeah, because I think when I saw the Kibisis running around the workshop yesterday, it did have a little antenna on board. But yeah, it would have to be on a different channel to the main rover to not interfere with each other, which would be pretty complicated for the team to figure out.
Yeah, I wonder if it's the smaller rover actually gets signals from the main rover potentially.
Yeah, that's also true, because they've also got two different antennas. They've got a thin sort of monopole antenna on the small one and a big dome antenna, I think, what I can see there on the back of Perseus. Oh, we've got some movement there. Might have fixed whatever was the problem for the team.
So you can see there was a bit of communication between the base station just to figure out what's going on.
Yeah, they had a very confident start, so it'd be really great to see them recover and continue on with the rest of their run.
Seems at the moment it's not too hands-on in base station just yet. I think they're still trying to figure a few things out.
Yeah, they are just over 15 minutes into their attempt too. Still plenty of time. They do want to get over this hurdle as quickly as they can. It's been amazing that these rovers have lasted such a long length of the competition.
Yeah, it's quite impressive how durable and robust these systems have to be, and they've managed to design them to handle all of these things. And also modular, you know, having to do so many different kinds of tasks as well. Yeah, all around, this rover challenge demands a lot from these engineers, so they have to get very, very creative, but also be able to handle so many different scenarios.
Yeah, that's exactly right. They have to be able to design something that can last 4 whole days, which is really a lot when you see how much these rovers get put to the test on the track.
It really makes you appreciate the real-life space systems that engineers design and how they have to last months, years on end and not break down.
Yeah, you think about missions like Voyager 1 and Voyager 2, which have been around since the late 1970s, heading into their 5th decade of operation, and they're still going. They've been on the verge of shutting down for a while now, but they keep getting revived.
Yeah, it's so impressive.
I like the motto on the back there of the rover, "Space is dirty." In this situation, it definitely is. We also tend to use the tagline, "Space is hard."
Definitely.
Really sums up the complexities.
Yeah, the usual assumptions you can make on Earth all get thrown out the window.
Yeah, for sure. As soon as you leave Earth, everything goes out the window of what you know. It's really all about extreme environment engineering. But that's what makes it so fun.
There's so many great inventions that have come out of technology and innovation in space. A lot of the NASA early missions have led to many of the technologies we use day to day now.
Yeah, that's right. We call these spin-offs when it comes from space technology and it's used here in daily life. team deliberating there over the radio. Space materials have ended up in some unlikely locations as well. If we're talking spin-offs, there was the Olympics, the Summer Olympics in Paris a few years ago, and the Australian swimming team actually used a coating that's normally used on satellites to repel water. It was a hydrophobic coating inside the swimsuit.
Yeah, I think I heard about that. Yeah, it's impressive, and I think sometimes you do have to think a bit out of the box about potential applications of these technologies. But it just shows how a lot of this innovation can be used in so many different applications. So, it's not just the space use cases, which is in itself amazing, but just how these sort of situations can apply to so many scenarios. But yeah, you can see here how figuring out what the problem is half the challenge.
Yeah, that's exactly right. The diagnosing, Monash was saying that they had this really intricate flowchart about all the possible scenarios, but sometimes you are going to get those cases of things you just weren't expecting, or maybe you've never even come across before, or learning things about your system for the first time is all part of the process of being here.
Yeah, and you can see how the teams that have been around a bit longer, done a few more years, they've had those learnings and put them towards that next generation of rovers.
Yeah, that's precisely right. And that experience all gets shared as well, which is fantastic to see. But it is always tough when you're watching a team out there and you can tell that they just want to get up and going and back again. Speaking about spin-offs as well, in the case of rovers, we might see even spin-outs, which is when you go the opposite way and technology that has been developed on Earth can be used in space, and rovers are certainly one of them. Australia has some really powerful knowledge in remote operations. We're a very big country, a lot of land to manage. We actually operate about 80% of the world's autonomous trucks. We use it in mining operations. And so you can imagine we've got a very similar setup here where you have a mission control centre that's hundreds, if not thousands of kilometres away from a site, and the trucks are being monitored by humans, either semi-autonomously or fully autonomously. They're operated in a mission control. And so these are the kind of skills that we've been able to take directly onto missions like Rover, which is so exciting.
Yeah, it's really awesome being able to bring technology from one context to another, whether that's from space back into commercial or industry or the other way around. And I think, Australia has some really unique tech out there because of the scale at which we have to operate. And like we were talking about earlier, construction and excavation are things that are going to become very important as we proceed with the Artemis missions. And so definitely going to be useful to take that knowledge and technology.
Yeah, and for people who aren't as familiar with the Artemis missions, they're basically like Apollo 2.0. Like we were saying earlier, Artemis is the sister to Apollo in Greek mythology. That was the kind of the pinnacle of the space race in the 1960s, and now we're back bigger than ever. So Artemis 2 is set to launch in early April, no earlier than, and it will be a crew of 4 astronauts going around the moon on a 10-day mission, the furthest that humans have ever been.
Definitely an exciting time to be around the space industry.
We have movement again from QUT Raw. Great troubleshooting there by the team. They're back in action. They still have 15 minutes remaining, which is plenty of time. As we've said today, this task in particular really does go down to the wire. I think that's one of the things that makes it so exciting. You can see the joy and mixed relief on their faces there as they get underway with the rest of the task.
Yeah, it's so satisfying when everything just comes together.
Going back to the Artemis missions, kind of the main goal of these in the near term is to establish a continuous human presence on the moon, and one of the tasks is going to be setting up a research station on the lunar south pole. So you can imagine excavation and construction is going to play a very big role in setting up that site for a base. They're really wasting no time, are they, Peter?
I like this strategy where the clearance of the rover itself is high enough that they can actually just drive through the deposit area and drop the regolith right in the middle and drive right over it.
Yeah, it's super efficient, isn't it? You can see now that they've overcome those issues that they had before. I think it might have been communications or something like that. They're just really going for it now with that regolith collection. Something that they're all too familiar with.
Looks like another jousting session was just about to start.
I think we could keep a count now of the number of teams that have knocked this pole over the course of the challenge.
Let's hope that doesn't get too much in the way as they proceed.
Oh, Cabissus is showing signs of life. Oh, this poor rover has really been put to the test today. Just need to flip it to the other side with that weighted tail there. Crazy, in about 3 minutes they've done at least 3 runs.
Like we were discussing earlier, the QT team's excavation system was quite efficient actually when they did the demonstration at the Lunar Robotics.
Yeah, that's right. This is definitely their territory. They're probably quite excited now that they get the chance to show it off.
This is one of those spin out. Is that when industry goes to space? Yeah.
Yeah.
Moments where they've modeled a lot of theirs around on-Earth excavation equipment and how efficient they are and using them for this use case here.
Yeah, that's right. Yeah, and you can see just how much more efficient it is too when they get that sort of jaw open up and the regolith is able to deposit rather than turning it down and having it all shake out.
Yeah, it looks like there's a gap in the bottom that can open and close. So they close it up when they take the regolith and then they slide it open to let the dirt out.
Oop, is this going to be a rescue mission to the mini rover? Nope, not today.
But look how fast they move.
Yeah, they've really amped the torque up now. Whoa.
Oh.
Maybe not. Whoa. Not too quick, guys.
Good thing they've got some good suspension on there.
Yeah, that's right. Return of the rocker bogie differential there, I think. You can see it at the back there, levelling out the chassis. Gosh, less than 10 minutes remaining. They're really going to have to go fast if they want to get these rocks. Check out the way that it's just able to directly collect the rocks by opening up over the top and then closing. So I guess like a clamshell and a scoop all in one. Oh, and they've got it. Orange rock straight in the bag, but they can't lose it on their way to the collection zone. So they're going to have to really make sure they keep the force from the clam there. Nice work. Some
there. I think it's so creative using that same mechanism that they used to deposit the dirt to actually grab onto those rocks there. Great use of the existing tools that they've got in lots of different use cases. Yeah, look at that, opening up.
Yeah, this is really the crunch time now. They're going to finish at 3:55 local time.
They're going for that big rock now. See if this same method works here. Oh, it made it look easy.
No rock too big for this rover. Oh, they're just hanging onto it there, going over the crater edge.
Yeah, a few teams now keeping it right on the edge there. Big drop.
Very nicely done. Okay, heading into the final minutes now. They're going to get those smaller rocks. They're going to go for a 2-in-1 like we've seen with other teams as well, or will they just try and get as many as they can, going back and forth?
I think it's trickier with this mechanism to do that 2-in-1 compared to other scoopers just because it squeezes underneath.
Yeah, that's a good point.
Looks like they've got that one really on the edge. Oh, maybe they will go for that 2-for-1. Maybe they'll drop it. There you go.
Yeah, yeah, really clever strategy there from the team.
You really have to get those two nice and lined up so that you can grab them both in one scoop.
Yeah, really great visuals there from the camera in the bottom left. Oh, but they're not quite there. Oh, it's agonizingly close, isn't it? Is this going to work for them? Oh, this is really like playing one of those arcade games now. The one where it pushes the chocolate right towards the edge.
You think you've got it, and then last moment it just slides out.
Again, depth perception so critical here.
Ooh, I think we got him. All right, nice.
Wow. Slow and steady, guys. They're going to have to take this all the way to the collection zone.
I don't think they do slow and steady.
I think you're right about that. Oh, but I guess the way that the two rocks are wedged together, this might play to their advantage.
And they must place a decent amount of clamping force on that. To really make sure it doesn't fall off.
That's true. Very high clamping force would be needed. Release. Release. They're just keeping us all in suspense here, aren't they?
As you can see on the time there, 4 minutes 30 remaining.
Oh, this would be incredibly unfortunate if they've suddenly... Nope.
So we've got movement. It's just the release mechanism, I think.
There we go. Nicely done. Yes. Now they're really going at pace now. Zooming into that crater for the final rock. Or second to last, maybe.
So they've only got a couple minutes now to get this done. So
yeah.
It's going to be a tight squeeze.
Only 4 minutes left on the clock. They haven't had a chance to get to the pavers this time, but they've certainly displayed an impressive effort, taking a lot into the excavation zone.
Certainly sticking to their strengths for sure.
That's right, especially after that hiccup that they had earlier. All right, rock in hand. Yeah, no time wasted here. They're back over the... Whoa! Over they go.
It almost acts like a claw, doesn't it?
Yeah, it does. Wow, congratulations. Amazing job by the team. Now, how are they going to spend these last 3 minutes or so?
Maybe they'll do some burnouts.
Maybe pick up their friend along the way. Or is it going to be back to the regolith pit? Or the pavers?
Paver.
There we go. Pressure's on now. Oh, wouldn't this be a fantastic finish if they can get the pavers out?
This would be crazy.
All eyes on QUT now.
Yeah, this payload has been so multi-purpose.
Yeah, really versatile, and they've got it down to a T with the control on that. Just 2 minutes left. Are they going to get a paver out? They will get points if they do. Less than 2 minutes now. The clock is ticking for QUT. And they've done it!
Wow.
Picked up a paver. Can they put it down on the ground? Remembering that it has to lie flat if they want to get points.
Wow.
I reckon that's pretty flat to me.
That looks good.
Can they get another one in the last 1 minute 10 on the clock? I think maybe magnetized now that I look at it. Yeah.
Maybe electromagnetic, so they can just change the direction of charge to latch and detach. There you go. So we just got an update. There are magnets inside the pavers. And yeah, using electromagnetism, we're able to attach and detach.
Yeah, I have a feeling that's what they used last year as well, and it worked really effectively for them. There's 40 seconds left. Now, these pavers do have to be touching for it to count as, well, they have to be within 1 centimetre of each other for it to count as connected. Maybe not quite.
They're definitely touching. Last 10 seconds.
So the pavers are not allowed to overlap, which means they might just spend the time trying to readjust this one. Can they just lift it off at least?
That's time.
That's time for QUT Raw. We'll leave that to the judges.
And hands off once time runs out.
Yeah, that was some real perseverance and tenacity from QUT there. Amazing job, guys.
I think any points from the paving task is going to be a bonus for this team.
Yeah. How about that, getting to it in just the final 3 minutes of the task? That is super, super impressive. I mean, they could have given up and done burnouts or picked up the mini Rover, but... Oh, they got them. I assume that's a thumbs up. They've got the points.
Yeah, there you go. So it just shows you got to at least give it a go. You just never know what you might get.
Yeah, I mean, the fact that they got that paver sort of away from the first one so that they weren't overlapping would have been in their favour.
Yeah, really great work from the team, especially that troubleshooting early on. Operated like it never happened afterwards.
Yeah, that's exactly right. So coming up next, we're going to have rival team from Indonesia. We've heard from them over the last few days as they've competed throughout the challenge. They'll be coming on at 4 p.m. local time. This is a perfect opportunity to hear from one of our sponsors, Caterpillar, who are out here at the Rover Challenge throughout this week. I believe Shagaf has got an interview lined up with them, so we'll head to you, Shagaf.
All right, everyone, back here in the workshop tent. I've got two lovely team members from the company Caterpillar. They're one of the main sponsors partnering with the Australian Rover Challenge here today. They're also the company that has presented and sponsored the excavation and construction task. So tell me your names and your roles in Caterpillar.
My name is Lauren Lestrange. I'm HR for the technology segment with Caterpillar.
And my name's Liz Fleming and I'm the talent acquisition partner looking after Caterpillar of Australia with all the recruitment and hiring, and that's why we're here hoping to meet and partner with some of the greatest and early talent people that we have available at this event.
Amazing. And you know what, at your hands, right before you here, you've got an incredible amount of student engineers, student, software specialists, people who are really putting to work a real-life application of their skills. How have you found so far your experience just being here, seeing all of this? What do you think about it?
So captivating. The energy, especially in the pits in particular, is so engaging. We're very, very excited, and we've been able to have really, really meaningful chats with all of the teams here, individuals from varying different degrees and specialties. So we're just learning about their interests and where their careers are possibly going to take them.
Amazing. And tell me a little bit about what's happening at your tent. So you've got a booth out there near the pitch. What can we do if we come and say hi?
Do come and say hi. If you haven't already, do come and get your 2026 Rover Challenge hat. They are a collector's item, so please come and see us. QR code as well to learn about those internships and graduate opportunities, as well as going in the draw to win some really cool Lego prizes that will be drawn and given away just before their presentation tomorrow.
That is awesome. And here you heard it first, Caterpillar booth next to the pitch. Go and sign up. I definitely have my eye on that Lego set, so you better get in quick. They're only here today and tomorrow. Back to you guys.
There we go. That's a pretty good opportunity to win a nice looking SLS Lego kit there. I know I'll be trying to enter that later on.
Yeah, I'll be chasing that cap down for sure.
So it's at least 3 of us you have to compete with there, but definitely go and check out the Caterpillar tent. And it's great to hear that they've had such a wonderful time here interacting with the students and just seeing the atmosphere here and all the excitement from the crowd. You know, it's a really great place to be in person, but also online as well. We've had so many people joining us across the world on the live stream or through the official viewing hub in Adelaide at the Australian Space Discovery Centre. And if you're watching from any of those places today, a very big hello to you all. And it's fantastic to have you join us here online.
Yeah, I'm sure some of the folks online for teams like the Indonesian team and the Polish team would have friends and family all over the world watching the live stream right now.
And here we go. We've got Rival from the 10 November Institute of Technology in Indonesia underway as the time ticks over to 4 p.m. We'll be beginning the excavation and construction task any moment now.
It's actually quite impressive how well this team has done. It's their first time. doing the Australian Rover Challenge, and they've really adapted really quickly to every single new task that they've had to take on.
Yeah, that's right. So when I was chatting with the team yesterday, they were telling me they were a robotics club and they'd never built a rover before. Now, I guess something we've not really talked much about this challenge is what is the difference between a robot and a rover? Well, all rovers are robots, but not all robots are rovers. So really the difference is that rovers are robots that are designed for extreme terrain.
Mm.
Taking from the verb rovering. So the team were able to adapt their robotics knowledge to create a rover from scratch. And they said it was a huge advantage for them to be able to come to Australia. You know, Indonesia, we're quite close neighbours. They weren't able to get over to some of the European challenges or the ones in the United States. Australia was the perfect location for them to test their rover. And so we're so excited to have them here.
Yeah, definitely. I think being based in Europe, you have so many other opportunities to go to European countries. But if you're on this side of the world, there's usually fewer opportunities to go to challenges like this. So it's really great to see that the rival team was able to come down and join this great challenge.
Yeah, and they've really dived headfirst into this challenge. You know, you can see here, they've built this rover entirely from scratch. They said they found out about the challenge last year and they said, yeah, we've got to do this. So they've got, you know, a chassis, full drive system, a really robust looking robotic arm, full communication system. That's just really been fantastic to see. And they're even going to attempt mapping and autonomy tomorrow. So they have signed up for all 4 tasks. Which is really, really impressive.
Yeah, I think you highlight something really important there, Georgia. Just the fact that taking on each of these tasks is in itself a great achievement, let alone scoring some points here and there.
Yeah, and they've scored quite a few points already this challenge. They did quite well in space resources the other day and also post-landing. Seems like they're going straight away for the Paver task.
It's actually been interesting to see different teams approach the order of tasks in different ways. I'm guessing relying on the strengths of their rover to decide that order.
Yeah, and this end effector has been really multifunctional for them over the last few days. They'll be using it to clean or, I guess, extract frozen regolith by sort of scraping it off the top of the sample the other day.
Mm. You can see so many different cameras pointing out of the end module there as well. Just to allow the operators as many angles as possible when they're doing any sort of operation. Just like that, you can see so many different angles there. You can see this paver is using a lot more of a conventional clasp mechanism where you have the black part sticking up and the white clamp grabbing onto it.
Yeah, it's proven pretty successful for them so far. They're only 4 minutes into the run and they've already laid down a paver.
Yeah.
So pretty amazing effort by the team.
It just shows that sometimes simplicity can go a long way.
Yeah, exactly. We often have a motto in engineering of KISS, being able to keep it simple, stupid.
That's it. I think as engineers, it's very easy to want to over-engineer your solutions. Engineers tend to love putting in as much technology into their solution as possible. And sometimes we have to be reminded that maybe keeping things a bit more simple is actually going to make things work a lot better.
That's exactly right. And that's why we do these design trade-offs, right? You can reach for the sky, but sometimes you don't need the most complicated solution ever to get there.
As you can see there, there's got another PlayStation controller there to navigate the rover. I wonder if there's a bias between using an Xbox or a PlayStation controller.
It's a good question. Oh no, this is going to be tough. So if they want these pavers to be connected together, they're going to have to get that latch into the white section that you can see there. But they can't overlap if they want the points.
There's so many fine motor adjustments for alignment like this. See, they slowly get closer and closer. Looks nice and lined up there.
Amazing precision there. Wow, that's so impressive.
Yeah, amazing work from the team there. Wow. Incredible. Completely lined up, no overlap.
Jeez.
Just gotta get that release now.
Yeah, but the paver also has to be flat. So that's going to be the next challenge, I think.
You can see how many constraints these teams have to operate under.
Yeah. There we go. 2 pavers
Wow,
down. Nice
incredible.
work, rival.
It's going for another paver here now. Just see how many angles they've got on their cameras.
Isn't it so nice how the sort of handle on those pavers fit into the end effector? They've got a bit of a lip at the bottom, which fits really snug.
Yeah, just to allow that extra ease to lift it up and have that control.
Yeah, it's a really clever solution there with that I-beam. You can see just the most precise maneuvers there. Look how carefully they're using that controller. It's barely any force.
You can see the analog sticks allow you to have that really precise control over the movements versus maybe if you had a keyboard, it's just you're just pressing the arrow keys or whatnot. Analog sticks give you a bit more granular control over those movements.
If they're able to get the third paver, I think this will make them one of the most successful teams so far for the paver construction.
Yeah, it seems some of the other teams have prioritized more on the excavation side of things. So it's great to see how different teams have set different priorities.
And Rival is our last team for the day as well. So once their run is done, that will wrap up day 3 of the challenge. It's amazing how much this time is just flown by here in the commentary box.
Yeah, we've seen it all. We've seen a bit of jousting. We've seen a mini rover.
We've seen some autonomous action.
That's it.
a bit of a rock unsticking. Oh, not quite there yet. So the pavers are considered connected if a light tug on any of the paver translates that force through the connected tiles. So for this to count, they do have to be connected together.
This is where the design of the actual paver connectors come in so critical.
Yeah, that's something you really don't want to over-engineer because you can see just how difficult it is to align them.
Looks like they're almost using that sensor to push the connector in. I think that looks good. Wow, all right. That's a third paver down. Amazing work from the rival team. Yeah, incredible effort. Once again, for their first time, this is really great to see.
Here we go, final paver.
Yeah, this team has definitely performed one of the best for this paver task.
It's a really interesting strategy they've gone for here. They've really focused on this paver construction.
What's the point distribution for this one?
Yeah, so there's 30 points available for the pavers.
Yeah, definitely a big chunk there.
Yeah, and there's up to 5 points available for justifying to judges the relevance and the utility of the constructed features using the pavers. This includes things like the size, the location, the context. So that might explain the particular placement of the pavers as well, sort of close to the lander. It's useful for astronauts, I suppose, to be able to traverse on.
Maybe it could be that the electric factor of regolith, how that can go up onto the tires and damaged parts. Maybe you could argue this can protect other vehicles on top of there as well.
Yeah, that's right, to disturb the regolith too much.
We don't want to do too much of their homework though.
I guess the only thing is that they've sacrificed about 15 minutes of their run. Super close there to connecting the last paver.
Just refusing to get in line there.
Oh, I reckon they might have done it.
It's difficult to see from that angle, but I'm sure we'll get another view soon. Oh, that looks positive.
Yeah, just got to shake it free. I guess they're testing that connection a little bit too.
Yeah, wow.
Amazing job from Rival.
Great.
The first team of the competition to get all of their pavers laid out.
Amazing
Fantastic
work.
job.
Almost a celebratory dance there.
This is actually very rare. I very rarely see teams lay down pavers at all, let alone every single one that they have. So really great effort from the team. We just saw the precision that was required there, and It took about 15 minutes. That's not bad, all things considered.
Yeah, definitely.
Leaves them 25 minutes on the clock though, so if they want to get any additional points, remembering that there are 100 up for grabs, they've hopefully just secured about 30 to 35, so they're going to have to work hard to secure the remaining points.
Maybe we'll get another nail biter like the last one.
Oh, I really hope so. That would be a great way to finish the day.
I'm sure a rival team would definitely not want that, but it would make for a good spectacle.
Exactly. Looks like they're going to be coming around for the rock debris clearing.
You can see how it's sometimes going to be quite difficult to actually see what's going on just based off the cameras like we've discussed with other teams.
Yeah, and that would affect the order that they do the tasks in as well. There's some that might be a lot more difficult for them. You can see they've got those 2 mounted cameras there on the scoop. It doesn't look like, oh, there's a depth sensing camera at the bottom, but it doesn't look like there's any more. Yeah.
You just need so many sensors for something like this.
Heading slowly but surely over to the crater now. All right, here we go. It's rock time.
So it looks like we're eyeing down that blue one maybe to start with. Kind of rode over the big rock.
Oh, that's not what we were expecting to see.
So you can see how easily just one small wrong input can send it in a completely different direction.
Yeah, we were talking a fair bit about PID tuning. We saw that there was a bit of shaking on the robotic end effect, and we thought maybe there was some overshoot there.
Yeah, definitely. It's critical part of these robotic mechanisms. The PID tuning allows you to move them with so much more precision and as required. So it's not just the actual angle that you want to achieve, but the way it moves as well is a big part of the tuning process.
Now there's 30 points available for the rock clearing. For each small and medium-sized rock, there's a total of 4 points available. For each large and huge rock, there's a total of 7 points. And then you get 2 points or 3 points for moving the rock any distance from its starting position. And then another 2 or 4 points for placing the rock in the collection zone, and that's for the small and large rocks, respectively.
There's still plenty of time to get some points on the board.
That's right, but it means that even if they can kick a few rocks around, that's quite a lot of points that they can get.
All right, looks like they've lined it up with that blue rock now.
I'm sure once they get this first one out of the way, similar to the other teams, they'll get the confidence to be able to be more efficient coming back. Can you hear those motors working overtime? And they're now halfway through their task time. tension is really going to increase. Just need to be able to close that end effector, get that clamping force, and then they're well on their way to getting more points.
Still not able to get a good grasp just yet.
It's quite interesting, isn't it, how they were able to do the paver construction quite successfully, but then you take it to a larger object that's not like a custom fit for their end effector, and it suddenly becomes so much more complex.
Yeah, definitely. This is the challenge of designing something that can do multiple tasks, right? It'll definitely have some strengths in some tasks and weaknesses in other tasks. And I wonder if the team was aware of this, and that's why I took on the paver challenge first.
Yeah, it's a really good point, and I suppose you can see the way that end effector moves actually goes along a bit of a guide rail. It's not opening up with an actuator like some of the other end effectors have.
Yeah, there's a lot less angle options, it seems.
Here we go. Just trying to sink down onto the rock.
So we've just hit under 20 minutes now, about 18 minutes left.
Going in for the kill.
As long as it's
going to be enough clamping force? Oh, looks like they just grazed the top of the rock there. We'll know in just a handful of seconds if they've... Oh, not quite.
This must be frustrating for the team.
Yeah, and you can see as it sinks further into the sand, that's really going to create a problem for them.
I wonder how many attempts they put on before they decide maybe to move on to the excavation task.
Yeah, well, I wonder if just, how far they're able to open up that end effector, because if they split it so much, that it was just one half instead of the two together, what that would do for their operations.
It seems like they're widening it, going for the big rock.
Yeah, it would make sense. Okay, we'll watch this next rock attempt. Come on. Oh, so close.
So you can see a bit of frustration there as well from the base station team. This definitely looks a lot more lined up there. Since the rock isn't as far deep into the regulars, there's more of it that you can grip onto there.
Yeah, I think you're right. I reckon the success is going to be pretty high for this one.
All right, here we go. It looks
Yeah,
in there.
I mean, it's in the enclosure. Oop,
I think
there
they've
they
got
go.
it.
They've got a hold of it.
All right. Now just bring it back. Just keep that clamp force as tight as possible.
Yeah, the next challenge is getting back over that crater ridge without losing it. Here they go.
Holding on just by a thread.
They really love picking up these rocks just with a millimetre to spare, don't they? Just like we saw before.
It seems like that every team we've seen so far in the excavation after lunch has been all right by the edge.
That's right, for sure. Let's watch them deposit this rock. Nice,
Wow.
great job, Rival.
Amazing
The rock
work.
in the bag. And they've got 15 minutes on the clock. So I think while we watch Rival go back, Shagaf has got an interview with QUT Raw, who we'd love to hear from after their recent run. Shagaf, how is it going?
All right, so I've got Queensland University of Technology Rover team over here, two of the lovely team members. Tell us your names and your roles on the team.
Hi, I'm Matt. I'm the deployables lead for the team.
Hi, I'm Hewan, and I'm in charge of development of our robotic arm and our web interface.
Brilliant. Now, you just attempted the excavation and construction task out there on the field. How did it go? Give us a summary.
Yeah, we had a few issues with some of our ENC bucket in our payload, but once we got that resolved through one of our team members running out, it was amazing. We flew through those tasks.
Amazing. And you had a few issues with the little guy. What was the name again?
Our little deployable's name is Kibbasis. Do you want to...
What actually happened?
Yeah, so we had an issue with mounting Kibbasis to the rover. When we actually deployed him off, he fell kind of down. To get out of the lander, the Perseus had to drive over Kibbasis to get free, and they tipped him over. Luckily, we got drive up and working, so we kind of went for a bit of a washing machine, spun the wheels full speed, and he eventually flipped himself upright, and off we went.
Brilliant. And both of you mentioned that you've been part of this competition. You came out here to Adelaide last year and this year as well. What has been your favourite part of coming here, competing in the Australian Rover Challenge?
My favourite part is coming and seeing all of the different ways that people are here trying to complete these tasks, as this being one of the most complicated rover challenges in the world. It's great to see all of the ingenuity that the teams can present.
That is awesome. And do you know what time you're on tomorrow to complete the mapping and autonomous task? We're going to have to double check that one as well. Yeah? Okay, cool. Well, Queensland University of Technology Rover team, tomorrow is their final task, the mapping and autonomous task. So stay tuned for the final day of the Australian Rover Challenge 2026. Back to you guys.
Oh, thank you to Shagaf and QUT Raw. And once again, for those in the team that don't know, they're competing at 10:45 a.m. tomorrow for mapping and autonomy.
I think as the final day rolls around, I think some of the teams are losing track of what's going on.
Yeah, the time doesn't really exist here up at Roseworthy, does it? It's just one long, continuous stretch of rovers.
All right, coming back to the rival team here, they've got another rock they're attempting to grab. Seems to be a solid hold here, but it's hard to see from this angle, but you can hear the motors really going at it. Looks like we've got a good grip on it there.
Oh, no! Oh, gosh, they were so close.
It's quite interesting. That one looked like it was actually more inside of the end effector, but it slipped out.
Yeah. And of course, on the lunar surface under 1/6 gravity, the physics of this would be completely different again.
Yeah.
Fall a lot slower to the ground, that's for sure.
And just as we were talking about before, there's so many different conditions to simulate lunar conditions, and there's only so many things you can recreate on Earth, and I think gravity is definitely one of the more harder ones to recreate.
Yeah, that's right. Especially for rover systems. They were talking about how the drive system is one of the ones that gets the most affected, but one of the hardest to simulate. The 1/6 gravity offset.
Yeah, you see astronauts get trained underwater, or they get suspended into the air as ways to simulate that anti-gravity effect.
Yeah, and a neutral buoyancy lab is not something that's particularly easy to put a rover in.
Definitely not. Yeah, I wonder when they grab it more closer to the edge, they actually get more surface area to attach onto the rock. versus when it's fully enclosed in the end effector.
Yeah, it's an interesting point, and I guess we'll see that unfold in the coming moments.
Time is getting more and more critical as we get closer to the end of the session time.
Yeah, it's the last 10 minutes of day 3. And then tomorrow it will be all Rover. Sorry. Of course, there will be a closing ceremony tomorrow as well, which will be very exciting for the teams, as we hopefully will have the scores to announce the winner of the Australian Rover Challenge, and also award some other prizes too, because as we've said throughout the week, it's not just about the points. You know, this is a Rover Challenge. It's not a Rover competition. We're about friendly rivalry. We're not about bitter rivalry. So it's all about encouraging the teams. I mean, the challenge was really founded with 4 purposes. It was about facilitating the growth of multidisciplinary student teams. It was about providing a platform for national collaboration of technological innovation and development, especially for the space industry. And it was also about pioneering some of these full-scale planetary simulation missions. Because what this really serves as a big test bed for validating new technologies. I mean, we saw that the Rover mission, for example, has taken on board engineers who worked on rover teams here at this challenge. So these technologies that they've learnt about or even developed are now being applied directly on real mission concepts. And something else that this challenge does is really promoting collaborative learning and friendly competition. And that's what we want to reward as well later on.
Yeah, definitely. And you can see that when you look at the interviews that we've been able to do with the teams over the day, over the last couple of days, how much collaboration goes on across all the teams and how much learnings they pass on to each other. And that's really the spirit of this challenge.
Yeah, so there'll be, you know, an overall challenge prize awarded based on the sum of all the scoring activities, but then we've also got prizes for best team culture and display of camaraderie, community spirit, demonstrating those values that we just spoke about, best first-year team, which will be awarded to the new team with the highest score. Also, most improved, because we always like to have teams coming back that have made leaps and bounds in their development. We might even have some additional prizes as well, so it's something for the teams to keep in mind that, you know, everyone here is sharing that community spirit.
Yeah, you definitely get that energy in the tent. Everyone's there to work with each other, learn from their mistakes, and most people are keen to take on the challenge and the learnings from one year to the next.
Yeah, and I think that's really facilitated by the open plan design of the workshop that we see too. I think it's quite unique for a competition of this style. You would see lots of other engineering competitions, you know, everyone would be sectioned away in their own tent, hidden from the other teams, or, you know, like you see in motorsports, they all have their own garage and they go to extreme lengths to block off the technology that they're developing to hide it from other teams. But here it's very much all out in the open.
Yeah, exactly right.
We are just about to tick over to the final 5 minutes. Rival are still trying to get another rock.
It's really great to see that these tasks are designed in such a way that it stretches every team in a different way, while allowing them to shine in their own unique areas. So it brings enough challenge that everyone can really show their skill sets.
You can see the agony from the team in the base station. They know they're so close to be able to get another rock. And again, for a first-time team, a rover built from nothing. This rover did not exist 12 months ago.
Yeah, really great work, this team. And, you know, I was talking to them earlier, bringing this across from another country, putting it into your luggage, it's a really tough process, and being able to bring it all out and put it back together is definitely a challenge in itself.
Yeah, you would certainly need a pretty big checked luggage and carry-on to get these parts over.
It looks like they're realigning the rover to aim at maybe another rock. Let me give that yellow rock another go then, I think.
It is an interesting strategy focusing on the rock clearing. They haven't gone for any of the excavation part yet. Maybe they think their end effector is not quite up to the task, the way that it's designed, making it a bit harder to sort of scoop the regolith.
It's definitely one of the smaller ones as well, size-wise. I think it may need to require a lot of iterations of going back and forth before they have a substantial mound.
Yeah, it wouldn't be super efficient, so maybe they thought it would be too hard to make that minimum volume requirement.
Almost at only 2 minutes now.
I think they're going to deliver us that nail-biting finish, Peter.
I definitely think so.
Go, go, rival.
You can really hear those motors go on for it.
Yeah, they're going into overtime there. This must be the maximum speed of the rover, judging by the sound of those motor controllers. So I guess they know for next time they potentially need more torque if they want to make further ground. You can see the sweating from the team. They've got 1 minute remaining. They weren't able to get that final rock, so maybe they're just headed for a victory lap. They've already shown an impressive display today. All pavers out, all connected. Hopefully they'll get a lot of points for that. And they were able to get a rock into the collection zone. For a first-time team, that's got to be applauded. That's very, very impressive from Rival.
Yeah, amazing work, Rival team. Amazing. I think just the fact that they were the only team to get that full paver out as well is such an extraordinary feat.
Oh, the Rover's waving at us. Hello. Greetings all the way from Adelaide, Australia, for everyone watching on their live stream. Amazing work, Rival. That is coming down to the end. 2, 1, and the time is up for Rival. Fantastic work, guys. You can be super proud of your efforts today. Lots of learnings for next year. So we're coming to collect that rover off the pitch. And with the conclusion of Rivals Run, that brings us to the end of day 3 of the Australian Rover Challenge 2026. Time is really flying now. I mean, yesterday we were halfway through, now we're 3/4 of the way through. We are so close to the end of this challenge. Peter, how do you feel after today?
It's been amazing, honestly. I think the composure every single team has had and the robust rovers that they've made is impressive. You know, last year I remember one almost went on fire. So I think we've come a long way, and every team is solid. You know, being able to take on these tasks, and even just seeing today, every single team has their own unique traits and their own strong suits. So it's been awesome to see how each of these teams have taken a unique approach, but effective approach in their own right.
Yeah, that's right. I mean, we've really seen a lot today. I mean, starting all the way back at 9 o'clock, we had rovers stuck on rocks and last-minute attempts in the excavation construction task and funny faces on scoops and mini rovers, and the innovations just keep coming every single year, and that's one of my favourite parts of this challenge, is just every single day is different. You never know what to expect here, and that's just the fun of science, isn't it, really? That's what STEM is all about. It's pushing the boundaries, going to the edge of what you think is possible, and also just having fun.
No, exactly right. And I love the personality these teams bring to each of their rows. It just shows like a lot of this work, you know, it is highly scientific, it is engineering work, but hey, we still have personality, we still have energy. And that's been awesome to see, the amount of energy all of these teams bring, you know. It really makes this event that much more lively, that much more exciting.
Yeah, I couldn't agree more. Well, a big thank you to everyone who is watching us today. Thank you to Fida and Shagav who made up our commentating team. Thank you so much to the staff, the volunteers, the judges who make this challenge possible. And of course to you, our audience. You've been joining us now for the last 3 days, but it does not stop there. We will be back tomorrow, day 4 of the Australian Rover Challenge, the finale. We start again at 9 a.m. with University of Wollongong and Monash Nova Rover. So join us again tomorrow morning, and we look forward to seeing you all soon. Good night.
Good night.
Change is the only constant. The question is, who is leading it?
What if the next space race took off from our state? What if Whyalla powered the world with clean green hydrogen? What if 2 of the state's leading universities came together to create a global university for the future? Welcome to Adelaide University, a defining mark in our state's story of firsts.
Australia is a nation of creators, aviators, protectors and innovators. From aviation's first light to the dawn of the jet age and beyond, at Boeing, we're building the future together here in Australia. Inspiring those in pursuit of new frontiers, connecting, protecting and exploring our region and the world. Home to the broadest aerospace portfolio in Australian industry, powered by talented, dedicated and diverse teammates. Delivering manufacturing excellence, building composite aircraft parts for the world's most efficient airplanes, using advanced robotics, materials and digital technologies. Never compromising on safety or quality, always focused on sustainability. Solving tomorrow's problems today with Australia's leading researchers, scientists and universities. Developing new military platforms and communications networks and helping ensure they are always mission ready. Keeping customers airborne by providing the services they require. We stand shoulder to shoulder with Australians during natural disasters, on the front line and in peacetime. We support veterans and our community, and we nurture the next generation of aviators to excite, to be bold. Boeing Australia. Made in Australia by Australians for the world.
Change is the only constant. The question is, who is leading it and why? Because purpose is everything. It's the bold ambition needed to take on the multi-generational challenges before us. It's the creation of a contemporary and accessible education ecosystem to drive greater social cohesion and prosperity. It's reimagining partnered research of focus at scale to become an engine for growth. Adelaide University is Australia's new university for the future, designed to empower individuals to be the best they can be. With more than 180 years of collective experience and achievement, Adelaide University will leverage the capabilities and resources of its foundation institutions to launch bright futures and breakthroughs. We're transforming teaching and learning by co-designing degrees with future employers. Our students will be equipped with an entrepreneurial mindset and will be ready to take on an AI world. Ethical leaders who do what is right over what is easy. Adelaide University is establishing South Australia as a centre for progress and innovation. As a group of 8 university, we're combining the investment and infrastructure needed to accelerate future-making research that is nation-critical and globally relevant across defence and national security, creative and culture, food, agriculture and wine, personal and societal health, and sustainable green transition. From society to seas to space, we're partnering with industry, communities and regions to create impact that transcends borders and time. As an exemplar for excellence and equity, we bring together the esteemed and enterprising to prepare a diverse next-generation workforce that's adaptable and ready to respond to an ever-evolving world. To provide a nation-leading student experience that unlocks individual potential and passions. To connect an inspiring global community of over 400,000 alumni. To contribute an estimated $4.7 billion a year to our national economy. And to deliver value across the full chain, from research translation to commercialisation. Adelaide University is a force for positive change. Together, we'll shape what's next for a better Australia and a better world.